Here are 100 plus behavioral question and answers most commonly asked in FAANG interviews.
In FAANG-style behavioral interviews, at companies like Amazon, Meta, Google, Apple, and Netflix, the widely accepted ideal response structure is the STAR framework. However, candidates who perform best typically use an enhanced version of STAR that emphasizes ownership, measurable impact, and deep decision-making. We will master both the baseline and the optimized STAR+L framework to ensure you communicate with the clarity of a principal architect.
The STAR+L Framework.
The structure top candidates use to turn a simple story into a strategic analysis. 1. Situation, brief context of the problem and the constraints you faced. 2. Task, your specific role and what success meant in that moment. 3. Action, the most important section, your decision-making process, trade-offs, and leadership actions. 4. Result, quantifiable outcomes, business metrics, and project impact. 5. Learning, the +L, your post-mortem reflection on what you would do differently and the system changes you implemented to prevent recurrence. Top candidates add learning and reflection. This is the difference between a junior hire and a staff-level architect.
The FAANG Optimized Behavioral Framework, STAR+L.
In FAANG-level strategy rounds, the way you structure your answer is as important as the answer itself. We use the STAR+L framework. It is not just a storytelling tool. It is a strategy to defend your decisions and prove your architectural maturity.
The anatomy of a FAANG-optimized senior answer.
1. Situation, 15% brief context. Define the constraints, budget, time, or regulatory pressure. 2. Task, 10%, your specific ownership and what success looked like. 3. Action, 55%, the meat of the answer. Explain the trade-offs, the alternative paths you rejected, and your leadership behavior. 4. Result, 20%, quantified outcomes. Impact, metrics, and business value. 5. Learning +L, what you changed in the system design to prevent the failure from ever happening again. Most candidates give the action. Elite architects give the why behind the action.
Deconstructing this 100 plus FAANG behavioral scenarios.
We have compiled the 100 plus most commonly asked behavioral questions from top-tier tech companies into 13 core behavioral categories. We aren't just going to list them. We are going to deconstruct them. We will show you the exact frameworks, the red flags that trigger instant rejections, and how to scale your answers for L5, L6, and L7 roles. Because this list is so massive and dense with value, we have split it into 2 distinct masterclasses.
The 2-part masterclass structure.
We have divided the 13 core behavioral categories based on the mindset required to conquer them. 1. Part 1, this video, the execution and influence round. How you drive projects, align difficult teams, and deliver business value. 2. Part 2, next video, the crisis and judgment round. How you handle catastrophic failure, immense pressure, and ethical dilemmas. Part 1 proves you can build it. Part 2 proves you can survive when it breaks.
What we will cover Part 1, this video.
In this Part 1 video, we focus on the first 6 categories, the foundation of engineering leadership. We will conquer 50-plus high-stakes scenarios covering 1. Leadership and ownership, 12 scenarios. 2. Collaboration and teamwork, 13 scenarios. 3. Communication, 5 scenarios. 4. Impact and results, 8 scenarios. 5. Initiative and innovation, 8 scenarios. 6. Customer focus, 5 scenarios. By the end of this video, you will know exactly how to prove you can guide teams without a formal title.
The reality check.
Although the list of potential interview questions is massive, 80% of FAANG behavioral interviews are drawn from a core set of about 25 questions. You do not need to memorize 100 different answers. Most elite candidates succeed by preparing 6 to 8 strong, modular STAR+L stories and intelligently adapting them to fit different prompts. Stop memorizing answers. Start mastering the framework, and you master the interview.
FAANG-specific nuances.
While STAR+L is universal, you must tailor your stories to the specific company culture. 1. Amazon maps stories to the 16 leadership principles, for example, customer obsession, dive deep, bias for action. 2. Google emphasize googliness, comfort with ambiguity, bias for action, and a collaborative spirit. 3. Meta focus on high-impact results, rapid execution, and resolving cross-functional conflict. 4. Apple focus on deep work and user experience. Show how you took the time to obsess over the smallest technical detail to make the product better. 5. Netflix emphasize freedom and responsibility. Demonstrate how you acted like an owner to solve a problem without needing permission or specific instructions. Culture is the filter. If your story does not map to their values, you will not pass the round.
The reality levels dictate depth.
An L4 junior and an L6 staff will often get the exact same question, like tell me about a conflict. The scenario itself is a constant. However, the depth of your follow-up defense is the variable and the evaluation bar is vastly different. 1. L4 evaluation: can they resolve a small conflict and keep their head? 2. L6 evaluation: can they resolve a systemic, organizational conflict while maintaining long-term stakeholder relationships? A senior architect does not answer the prompt. They defend their architectural and relational trade-offs.
The 3 patterns of interview probing.
No matter which scenario you get, every interviewer will drill down using these 3 predictable patterns. You must practice answering these for every story in your bank. 1. The ownership or clarification probe: who made the final call, or what was your specific contribution versus the team? 2. The logic or depth probe: what were the trade-offs of that decision, or why did you choose that path instead of alternative X? 3. The EQ or curveball probe: how did your stakeholder feel about that? Or what would you do differently if you had to do it again today? If you cannot answer the follow-up, your primary story holds no weight.
How real interviews unfold.
In a real 45-minute behavioral round, you typically get only 3 to 4 primary questions. The interviewer spends 8 to 10 minutes on each. The flow is always the same: a 2-minute opening question, followed by 2 minutes of digging for ownership, and 4 minutes of intense pressure, the curveball or depth probe. Your job is to stay structured, maintain your narrative, and welcome the interrogation as an opportunity to show seniority.
Pro-level tips for success in FAANG interviews.
Refine your delivery with these rules to stand out from the crowd. 1. Match your level. Senior roles require stories about systemic impact and strategy. Junior roles focus on execution and coachability. 2. Be specific. Replace generic phrases like "I communicate well" with "I realized the product team had a timeline mismatch, so I scheduled weekly syncs to align goals." 3. Own the I. Interviewers evaluate you. Use I to describe your specific decisions, not we to describe the group's work. 4. Prepare for the drill down. FAANG interviewers are trained to dig deep. Expect "why did you make that choice? What would you do differently? Or how did they react?" 5. The power of reflection. Always close your story with a lesson learned to show growth mindset. This is mandatory for failure-based questions. Speaking your stories out loud is the only way to check your pacing and clarity.
Finally, let's start with Category 1, leadership and ownership.
We begin with the most requested behavioral category in FAANG interviews: leadership and ownership. This is where interviewers determine if you are just an executor of tasks or an architect who takes full responsibility for the technical and business outcome.
Category 1, leadership and ownership.
Mastering these scenarios demonstrates your ability to influence, lead, and test your ability to influence, manage performance, and delegate. 1. Tell me about a time you took ownership of a problem outside your responsibility. 2. Tell me about a time you showed leadership without having formal authority. 3. Describe a situation where you stepped up when others did not. 4. Tell me about a time you had to motivate a team. 5. Tell me about a time you led a project from start to finish. 6. Describe a time you had to make a difficult leadership decision. 7. Tell me about a time you influenced others to adopt your idea. 8. Tell me about a time when you took initiative to improve something. 9. Tell me about a time you had to manage or mentor someone struggling. 10. Tell me about a time you handled an underperforming teammate. 11. Tell me about a time you had to delegate work effectively. 12. Describe a time when you had to step into a leadership role unexpectedly. These questions test your ability to own outcomes beyond your job description. Prepare one hero story for each of these. Adaptability is your greatest asset. Question 1. Tell me about a time you took ownership of a problem outside your immediate responsibility. Note, this heavily tests Amazon's ownership and bias for action principles.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to hunt for specific negative signals. Avoid these traps. 1. The hero complex, saying the other team was incompetent, so I stepped in to save the day. This shows arrogance, not leadership. 2. The not my job defense, saying I escalated it to my manager and waited. This shows a lack of bias for action. 3. The unilateral action, saying I just pushed a fix to their repo without telling them. This shows a dangerous lack of respect for team boundaries. 4. The process-obsessed candidate, saying I filed a ticket and waited for the SLA. A true owner does not let a product launch die while waiting for a ticket priority update. 5. The blame shift narrative, spending 5 minutes explaining why the other team was at fault. Hiring managers do not want to hire someone who focuses on who broke it. They want someone who focuses on how to fix it.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 critical leadership signals. 1. Ownership. Did the candidate take personal responsibility for the outcome? 2. Collaboration. Did they build bridges instead of overriding other teams? 3. Business impact. Was the time investment justified by the ROI for the business? 4. Systems thinking. Did they implement a guardrail to prevent recurrence? 5. Growth mindset. Did they reflect on what they would change if they had to do it again? Strong candidates demonstrate all 5 signals in a single, cohesive story.
Here is the FAANG level senior answer, STAR+L.
Pass the senior bar. Structure your answer using the STAR+L method. Situation: an upstream payment service was failing, blocking my team's critical Q4 product launch. Task: I needed to unblock the launch without stepping on the toes of the overwhelmed payment team. Action: I analyzed their logs, found a connection exhaustion issue, scheduled a sync with their lead, offered surge support, and submitted a fully tested PR implementing exponential backoff. Result: the fix was merged in 48 hours, failure rates dropped to 0.2%, and our product launched on schedule. Learning plus L. I realized cross-team collaboration should not require a crisis. I later championed an inner source model so any engineer could securely contribute to core services. The plus L, learning, proves you fix the system, not just the bug.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how our STAR+L structure naturally checks off every requirement on the interviewer's rubric without sounding arrogant. 1. Ownership matched. You claim the blocker as your own instead of waiting for the upstream team to fix it. 2. Collaboration matched. You offered surge support and submitted a PR, respecting their boundaries rather than complaining. 3. Business impact matched. You quantified the result, 0.2% failure rate, and explicitly tied it to saving the Q4 launch. 4. Systems thinking matched. You identified the root cause connection exhaustion rather than just adding a band-aid fix. 5. Growth mindset matched. The plus L step proved you looked beyond the incident by championing the inner source model to prevent future silos. This is how you turn a simple technical fix into an architect-level behavioral defense.
Follow-up 1, clarification probe. You mentioned you submitted a PR. Who actually tested and approved the code before it went to production?
Answer: while I wrote the unit tests and ran the initial load simulation and staging, the payment team remained the ultimate gatekeepers. I required their tech lead to be the mandatory reviewer on the PR. I provided the code, but I respected their authority to own the deployment.
Follow-up 2, level 3 or level 4 junior depth. What data did you use to convince the payment team that your fix was actually the correct approach?
Answer: I did not just bring an opinion. I brought a dashboard. I showed them the correlation between the transaction drops and the database connection spikes in Datadog. I then provided the results of my staging load test, which proved that the exponential backoff immediately flattened the connection curve.
Follow-up 3, level 5 or level 6 senior depth. Fixing another team's code takes time away from your own sprint commitments. How did you justify that trade-off to your own stakeholders?
Answer: I justify it through business impact. I explained to my product manager that delaying our feature work by 2 days to fix the payment service guaranteed our launch date. Ignoring the payment service guaranteed a delay. At a senior level, my job is not just to write code for my specific feature. My job is to ensure the company ships the product.
Follow-up 4, curveball. What if the payment team's lead felt threatened by your PR, got defensive, and flat-out rejected your code, even though the data proved it worked?
Answer: I de-escalate immediately. I would pull the PR back to a draft state and say, I completely respect that you own this service. Here is the data I found. How would you prefer we approach solving this together? If they still refuse and the business launch is at risk, I escalate objectively to my director, framing it as a resource or timeline blocker, not an interpersonal fight.
Leadership pro tip: the Amazon ownership principle.
At companies like Amazon, ownership means you never say that's not my job. However, true senior ownership is collaborative, not combative. 1. When you step outside your scope, your goal is to empower the owning team, not embarrass them. 2. Senior engineers who pass Amazon interviews almost always mention how they credit the owning team during the postmortem. Interviewers interpret shared credit as the ultimate signal of mature ownership. Question 2. Tell me about a time you showed leadership without having formal authority. Note, this tests your ability to influence cross-functional teams and drive alignment using soft skills and data, not an org chart title.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to weed out aggressive or passive candidates. Avoid these traps. 1. The dictator approach, describing a time you gave orders to peers. This shows you confuse leadership with bossiness. 2. The martyr complex, saying no one else would do the work so I just did it all myself. This is individual heroism, not leadership. 3. The escalator, immediately complaining to a manager to force another team to act. This proves you lack peer influence. 4. The meeting organizer, believing that simply scheduling a meeting counts as leadership without driving an actionable technical outcome. 5. The credit hog, taking the glory for the eventual success when the broader team executed the actual work.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 critical leadership signals. 1. Influence: can the candidate persuade others to change direction without using managerial power? 2. Empathy: do they understand and respect the competing priorities of other teams? 3. Structure: can they bring order to a chaotic or deadlocked situation? 4. Alignment: can they unite competing factions around a single business goal? 5. Growth mindset: do they institutionalize the fix to prevent future friction? Strong candidates demonstrate all 5 signals in a single, cohesive story.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: midway through a core migration, our front-end and back-end teams were completely deadlocked over an API contract, threatening our release date. Neither team reported to me. Task: I needed to break the deadlock and align both engineering groups without stepping on the respective tech lead's toes. Action: I did not call a debate. I drafted a neutral, data-driven API contract proposal doc. I hosted a 30-minute workshop to facilitate compromise and volunteered to build a mock server so the UI team could unblock immediately while the backend finished the real logic. Result: the tension dissolved, both teams agreed to the contract, and we shipped the migration 3 days ahead of the deadline. Learning plus L. I realized informal leadership is about reducing friction. I later implemented Open API Swagger auto-generation into our CI pipeline, making API alignment a programmatic standard rather than a human negotiation. The plus L, learning, proves you fix the system, not just the bug.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how our STAR+L structure naturally checks off every requirement on the interviewer's rubric without sounding arrogant. 1. Influence matched. You used a shared document and a mock server to drive alignment rather than giving orders. 2. Empathy matched. You recognized the UI team's frustration and built a mock server to relieve their pressure. 3. Structure matched. You created the API contract proposal to move the teams from emotional arguing to data-driven engineering. 4. Alignment matched. You got 2 siloed, deadlocked teams to agree on a single source of truth. 5. Growth mindset matched. The plus L step solved the systemic issue by integrating Open API auto-generation globally. This is how you turn a simple meeting into an architect-level demonstration of influence.
Follow-up 1, clarification probe. You stepped in to lead, but the actual tech leads were in the room. How did they react to you taking over their domain?
Answer: I made sure I did not take over their authority. I took over the administrative burden. I framed my actions as facilitation, saying, let me draft this proposal so we have something concrete to review. Tech leads appreciate when someone does the heavy lifting of documentation and alignment, as long as you defer the final technical approval to them.
Follow-up 2, Level 3 or Level 4 junior depth. How did you identify that the API contract was the exact bottleneck? rather than just general slow development from the teams?
Answer: I looked at the objective data in our sprint board. The UI team's pull requests were stuck in draft state for over a week, and the comment threads specifically cited waiting on backend JSON payloads to proceed. Data and observability always reveal the true bottleneck.
Follow-up 3, Level 5 or Level 6 senior depth. What if the backend team refused your API proposal because they claimed it required them to refactor too much of their legacy code?
Answer: I would validate their technical constraint. If the backend effort was truly too high, I would pivot the strategy to a backend for frontend BFF pattern. I would propose we write a lightweight Node.js translation layer. This compromises by giving the UI the clean data they need, without forcing a massive, risky legacy rewrite on the backend.
Follow-up 4, Curveball. What if, despite your workshop and the mock server, the two teams still fundamentally refuse to cooperate due to a toxic historical rivalry?
Answer: if peer-to-peer influence completely fails due to cultural toxicity, informal leadership reaches its limit. I would document the exact technical impasse and the business cost, specifically the threat to the release date, and escalate it cleanly to the engineering director. True leadership is knowing when an organizational issue requires executive intervention to resolve.
Leadership pro tip: the power of friction removal.
The secret to influence without authority is understanding human psychology in the workplace. Informal leadership is not about being the loudest voice or the smartest engineer in the room. It is about volunteering to take on the unglamorous work, like documentation, scheduling, and mocking data. If you remove the friction that is causing the argument, you make it incredibly easy for people to agree. And when you make it easy to agree, they will naturally follow you. In engineering, the person who writes the document controls the direction of the architecture. Question 3. Describe a situation where you stepped up when others did not. Note: interviewers use this to test bias for action and your ability to conquer the bystander effect in large engineering organizations.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to hunt for specific negative signals. Avoid these traps. 1. The martyr complex, saying everyone else was lazy so I had to work the weekend to save the project. This shows deep resentment and poor team dynamics. 2. Throwing peers under the bus, naming specific individuals who failed to act. True leaders solve problems without tearing down their colleagues. 3. The busy work trap, stepping up to do something trivial like organizing a wiki, rather than stepping up to solve a high-stakes technical or business risk. 4. Acting without alignment, stepping up by changing core architecture in a vacuum without telling the team or stakeholders. 5. The temporary hero, fixing a symptom once, but doing nothing to address why the team ignored the problem in the first place.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 critical leadership signals. 1. Bias for action. Does the candidate wait for permission to investigate a critical risk? 2. High standards. Do they tolerate broken windows or do they demand operational excellence? 3. Tact. Can they intervene in an orphaned area without alienating the surrounding teams? 4. Business acumen. Did they step up for something that actually mattered to the bottom line? 5. Systemic thinking. Did they fix the root cause of the bystander effect to prevent it from happening again? Strong candidates demonstrate all 5 signals in a single, cohesive story.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: we had a legacy notification service that processed email alerts. It was generating a slow trickle of timeouts. Because the failure rate was under 1%, it did not trigger pager duty. The original developers had left, so everyone ignored it, assuming another team would eventually rewrite it. Task: I realized this 1% failure rate meant thousands of users were not getting password reset emails, leading to silent customer churn. I needed to patch it immediately and establish clear ownership. Action: I did not wait for a reorg. I timeboxed 4 hours, dove into the legacy codebase, identified a memory leak in the connection pool, and deployed a hotfix. Then, I drafted a proposal for our architecture guild to officially absorb the service into our core platform team. Result: the timeout rate dropped to 0, immediately reducing support tickets by 15%. The architecture guild approved my proposal, and the service finally had an official owner. Learning: +L. I learned that unowned code is the biggest risk in a microservices architecture. I subsequently implemented a service catalog using Backstage, enforcing a strict rule that every repository must have an active, listed owner. The +L, learning, proves you fix the system, not just the bug.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how our STAR+L structure naturally checks off every requirement on the interviewer's rubric without sounding arrogant. 1. Bias for action matched. You investigated the silent failure before it became a catastrophic outage. 2. High standards matched. You refused to accept a 1% failure rate just because the monitoring alarms were not ringing. 3. Tact matched. You did not shame other teams for ignoring it. You proactively absorbed it into your team's domain. 4. Business acumen matched. You connected technical timeouts directly to customer churn and support ticket costs. 5. Systemic thinking matched. The +L step solved the organizational issue by mandating a service catalog to eliminate orphan code globally. This is how you turn a hotfix into an architect-level demonstration of organizational leadership.
Follow-up 1. Clarification probe. You mentioned you time-boxed 4 hours to fix it. Did you drop your assigned sprint work to do this?
Answer: no, I am highly protective of my sprint commitments. I used my allocated engineering buffer time, which our team reserves for technical debt and ad hoc investigations, to diagnose the issue. Once I realized the fix was simple, I executed it. Had it required days of work, I would have documented the findings, added it to the backlog, and pitched it in the next sprint planning.
Follow-up 2. Level 3 or Level 4 junior depth. If the service had no official owner, how did you get the permissions to deploy to production without violating compliance?
Answer: I strictly adhered to our CI/CD governance. Even though the service was orphaned, the repository still required standard approvals. I paired with a staff engineer from another domain to review my PR, ensuring a second set of eyes validated the memory leak fix, and we let the automated pipeline handle the deployment to maintain the audit trail.
Follow-up 3. Level 5 or Level 6 senior depth. Why do you think an entire engineering organization ignored a failing service for so long? What is the root cause of that culture?
Answer: it is the classic bystander effect, exacerbated by Conway's law. When companies transition from monoliths to microservices rapidly, the boundaries between domains often become fuzzy. Engineers aren't malicious. They are just hyper-focused on their own KPIs. If leadership does not explicitly map every microservice to a team's KPI, orphaned services become inevitable. That is exactly why I pushed for the service catalog.
Follow-up 4. Curveball. What if your hotfix inadvertently brought the notification service completely down, severing all emails for the company? How would you defend taking action on a system you did not own?
Answer: I would not defend the failure. I would own the outage. I would immediately roll back the deployment and declare an incident. During the post-mortem, I would state that, while my intent to stop the bleeding was correct, my execution lacked adequate regression testing on a legacy codebase. I would use the failure as a forcing function to prioritize a complete, structured rewrite of the service, rather than relying on tactical hotfixes.
Leadership pro tip. The broken window theory.
Interviewers use this question to test if you subscribe to the broken window theory of software engineering. Junior engineers walk past a broken window because they did not break it. Senior engineers stop and fix it because they know that ignoring small signs of decay eventually ruins the entire neighborhood. When you step up, frame it as protecting the engineering culture, not just fixing a bug. Question 4. Tell me about a time you had to motivate a team during a difficult project. Note: interviewers use this question to evaluate your ability to inspire alignment and drive performance during low morale or high-pressure sprints, which is a key leadership signal evaluated at companies like Amazon and Netflix.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to identify candidates who confuse motivation with pressure. Avoid these traps. 1. The cheerleader, saying you motivated the team with speeches or encouragement but without changing the project conditions or removing obstacles. 2. The taskmaster, describing motivation as pushing the team to work longer hours or weekends. 3. The manager proxy, claiming motivation came from escalating the issue, so management forced the team to deliver. 4. The invisible leader, saying the team eventually succeeded but failing to describe what you actually did to influence the outcome. 5. The credit collector, taking credit for the team's perseverance while ignoring the contributions of the engineers who did the work.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 leadership signals. 1. Emotional intelligence. Does the candidate recognize when morale is collapsing? 2. Obstacle removal. Did they eliminate technical or process friction blocking the team? 3. Goal framing. Can they reconnect engineers with the larger business impact of their work? 4. Ownership. Did they personally take responsibility for improving the situation? 5. Long-term leadership. Did they implement changes that improved team dynamics beyond the single project? Strong candidates demonstrate that motivation comes from solving problems, not giving speeches.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our team was migrating a monolithic billing system into microservices. Halfway through the project, the team morale collapsed because integration tests were failing unpredictably, and engineers felt the migration would never finish. Task: as one of the senior engineers on the team, I needed to restore momentum and help the team regain confidence in the project. Action: I started by diagnosing the real issue behind the frustration. The root problem was our unstable integration environment. I proposed creating a deterministic local testing harness that simulated downstream services. I volunteered to build the first prototype and documented how every service could run the test suite locally without relying on flaky shared environments. Result: once engineers could run stable tests locally, productivity rebounded. Pull request cycle time dropped by 40%, and the migration milestone that had slipped for weeks was completed within the next sprint. Learning plus L. I realized morale problems often hide technical bottlenecks. After the project, I helped introduce a company-wide standard for deterministic integration testing so future migrations would not suffer the same issue. The plus L, learning, proves the candidate improved the engineering system, not just the team's mood.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how our STAR+L structure naturally checks off every requirement on the interviewer's rubric. 1. Emotional intelligence matched. You recognize that the team's frustration came from unreliable testing infrastructure, not laziness. 2. Obstacle removal matched. You solved the real blocker by creating a deterministic integration test harness. 3. Goal framing matched. By stabilizing testing, engineers could see real progress again, restoring confidence in the migration. 4. Ownership matched. You personally built the prototype and enabled the rest of the team to adopt it. 5. Long-term leadership matched. The plus L step ensured future projects used deterministic integration testing across the organization. This demonstrates that strong leaders motivate teams by removing friction.
Follow-up 1, clarification probe. Were you officially responsible for the testing infrastructure, or did you step outside your role?
Answer: the infrastructure technically belonged to another platform team, but the instability was blocking our delivery. Rather than escalating immediately, I created a prototype solution and then collaborated with the platform team to integrate the idea properly into our environment.
Follow-up 2, Level 3 or Level 4 junior depth. How did you confirm that the unstable integration environment was the root cause of the morale issue?
Answer: I analyzed our CI logs and noticed that identical pull requests passed or failed randomly, depending on the environment state. I also reviewed developer comments on the pull requests, which repeatedly referenced unreliable test results. That combination of technical evidence and team feedback clearly pointed to the environment as the bottleneck.
Follow-up 3, Level 5 or Level 6 senior depth. Why did you build a local testing harness instead of investing more time fixing the shared integration environment?
Answer: fixing the shared environment would have required coordination across multiple infrastructure teams and could have taken months. The local harness provided immediate developer autonomy. Engineers could validate changes quickly without waiting for a centralized environment, which dramatically improved delivery speed.
Follow-up 4, curveball. What if the team remained demotivated even after your technical fix?
Answer: if the technical solution did not restore momentum, I would focus on transparency and short-term wins. I would break the migration into smaller, visible milestones and publicly track progress. Small, frequent successes help teams rebuild confidence in large projects.
Leadership pro tip. Motivation comes from momentum.
In engineering organizations, morale rarely improves through speeches or encouragement. It improves when engineers see consistent forward progress. The fastest way to motivate a struggling team is to remove the friction that prevents them from shipping working software. Question 5. Tell me about a time you led a project from start to finish. Note, interviewers use this question to assess end-to-end ownership, from scoping to delivery with trade-offs, revealing your project management rigor and adaptability, a core signal at companies like Google and Meta.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to detect candidates who misunderstand what project leadership actually means. 1. The task tracker, describing leadership as updating JIRA tickets or running stand-ups rather than driving technical direction. 2. The partial story, explaining the implementation but skipping the planning, alignment, or final delivery stages. 3. The scope chaos, leading a project where requirements constantly change because no structure was established. 4. The solo builder, saying you built the entire system yourself instead of coordinating a team. 5. The no outcome, finishing the project but failing to quantify what impact it had on the business or product.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate whether you demonstrate these project leadership signals. 1. Vision, can the candidate translate a vague goal into a clear technical plan? 2. Planning, did they break the project into achievable milestones and manage scope effectively? 3. Coordination, did they align engineers, product managers, and stakeholders throughout the project? 4. Execution, did the project actually ship on time and meet technical expectations? 5. Impact, did the project produce measurable improvements for the business or users? Strong candidates show leadership across the entire life cycle of the project.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our search platform was struggling with slow query latency during peak traffic, causing users to abandon searches. Leadership asked our team to improve performance before the holiday season. Task: I proposed leading a project to redesign the search caching layer to reduce latency and improve scalability. Action: I started by analyzing production metrics and identified that repeated identical queries were hitting the database unnecessarily. I designed a distributed caching strategy using RIDIs, broke the work into 3 milestones, and coordinated backend engineers, SRE, and the product team to roll out the change safely. Result: after deployment, average search latency dropped by 60%, and user engagement increased because results loaded instantly during peak hours. Learning plus L. I realized performance work should be proactive rather than reactive. I later implemented automated performance monitoring dashboards so latency regressions would be detected early. The plus L demonstrates that the candidate improved engineering practices beyond the immediate project.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates leadership across the full project lifecycle. 1. Vision matched, you identified a clear strategy to improve performance using a caching layer. 2. Planning matched, you divided the project into milestones instead of attempting a risky big bang deployment. 3. Coordination matched, you aligned engineers, SRE, and product managers throughout the rollout. 4. Execution matched, the system shipped successfully and improved latency in production. 5. Impact matched, you quantified the improvement with a 60% latency reduction. This shows true project leadership, not just technical implementation.
Follow-up 1, clarification probe. Were you officially assigned as the project lead, or did you volunteer to lead the effort?
Answer: initially the project had no clear owner. I volunteered to draft the technical proposal and roadmap, and once the plan was approved, I coordinated the work across the team to ensure each milestone was completed on schedule.
Follow-up 2, level 3 or level 4 junior depth. How did you ensure the RIDI's caching layer would not introduce data consistency issues?
Answer: I implemented a short TTL policy and designed the cache to act as a read-through layer rather than a source of truth. This ensured stale data would expire quickly while still dramatically reducing repeated database queries.
Follow-up 3, Level 5 or Level 6 Senior Depth. What would you have done if the caching solution had not produced the expected latency improvement?
Answer: I would treat it as a failed hypothesis, which happens at scale. I would immediately communicate the data to leadership to reset expectations. Then, I would pivot the engineering team's focus toward deeper bottlenecks, like database indexing or read replicas, while keeping the cache in place as a protective layer.
Follow-up 4, Curveball. What if the project timeline started slipping and leadership demanded immediate results?
Answer: in that situation, I would rely on strict scope management. I would reassess the roadmap and drop nice-to-have features, prioritizing only the highest impact caching improvements. Delivering an incremental 30% improvement quickly restores stakeholder confidence much better than making them wait for a 60% improvement.
Leadership pro tip. Leadership means shipping results.
Many candidates think project leadership means coordinating meetings, running agile ceremonies, or tracking tasks in Jira. In reality, strong engineering leaders define the problem clearly, ruthlessly manage scope creep, and deliver measurable improvements in production systems. You lead the outcome, not just the process. Question 6. Describe a time you had to make a difficult leadership decision. Note: interviewers use this question to probe judgment under uncertainty, such as prioritizing features amid constraints, highlighting ethical trade-offs and decisiveness, evaluated heavily at companies like Apple and Amazon.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to detect weak decision makers. Avoid these traps. 1. The consensus addict, refusing to make a decision until everyone fully agrees. Leadership sometimes requires acting despite disagreement. 2. The manager escalator, immediately escalating the decision to management instead of evaluating the trade-offs yourself. 3. The gut feeling, claiming you made the decision based purely on intuition without analyzing data or technical risks. 4. The avoidance strategy, delaying the decision indefinitely until circumstances forced a resolution. 5. The no consequences story, describing a decision where there were no meaningful risks or downsides.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate whether you demonstrate these leadership signals. 1. Judgment: can the candidate evaluate multiple options and select the most reasonable path? 2. Trade-off analysis: did they clearly understand the risks and benefits of each option? 3. Ownership: did they take responsibility for the final decision rather than deferring indefinitely? 4. Communication: did they clearly explain the decision to stakeholders and maintain alignment? 5. Accountability: did they stand by the decision and manage the outcome afterward? Strong candidates show that leadership decisions require balancing risk, speed, and long-term impact.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our team was building a new recommendation engine, but halfway through development we discovered the current architecture could not handle projected holiday traffic. Task: I had to decide whether to continue the project with risky performance limitations or delay the launch to redesign the system for scalability. Action: I gathered performance benchmarks, evaluated system bottlenecks, and presented 2 options to the team. After analyzing the risks, I recommended delaying the launch by 2 weeks to implement a scalable distributed processing pipeline. Result: the redesign allowed the system to handle 5 times the original traffic estimates, and the launch proceeded without outages during peak holiday usage. Learning plus L. I learned that delaying a launch can be difficult, but protecting system reliability is often the correct long-term decision. I later introduced load testing benchmarks as a required milestone in our development lifecycle. The +L shows the candidate institutionalized better decision-making practices.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L structure demonstrates strong leadership judgment. 1. Judgment matched: you evaluated system capacity and recognized the risk of launching with an unstable architecture. 2. Trade-off analysis matched: you compared 2 realistic options, shipping immediately or delaying for scalability improvements. 3. Ownership matched: you made a clear recommendation instead of deferring the decision indefinitely. 4. Communication matched. You explained the technical reasoning to stakeholders before implementing the decision. 5. Accountability matched. You accepted responsibility for delaying the launch and ensured the final system delivered reliable performance. This demonstrates decision leadership rather than passive consensus.
Follow-up 1. Clarification probe. How did the product team react when you proposed delaying the launch?
Answer: initially they were concerned about the delay because the launch was tied to a marketing campaign. I walked them through the performance benchmarks and explained the potential user impact of system outages during peak traffic. Once they saw the risk clearly, they supported the decision.
Follow-up 2. Level 3 or Level 4 junior depth. How did you validate that the new distributed architecture would actually scale better?
Answer: we implemented load testing scenarios that simulated peak holiday traffic and monitored system performance metrics such as latency and throughput. The results showed that the redesigned system handled significantly higher traffic with stable response times.
Follow-up 3. Level 5 or Level 6 senior depth. What would you have done if leadership had refused to delay the launch?
Answer: if leadership insisted on launching on schedule, I would have recommended limiting the rollout through a staged release. This approach would allow us to monitor system performance gradually while reducing the risk of a full-scale outage.
Follow-up 4. Curveball. What if your decision to delay the launch had turned out to be unnecessary?
Answer: leadership decisions often involve uncertainty. If the delay turned out to be unnecessary, I would still consider it a responsible decision because it was based on the best available data and protected system reliability for users.
Leadership pro tip. Difficult decisions define leadership.
The hardest leadership decisions usually involve choosing between speed and reliability. Strong engineering leaders make these decisions based on data and long-term impact, even when the short-term choice is uncomfortable. Question 7. Tell me about a time you influenced others to adopt your idea. Note: interviewers use this question to gauge persuasion without authority, using data to overcome resistance, a vital signal for cross-functional impact at companies like Google and Meta.
Here are the critical red flags. The instant rejection signals.
FAANG interviewers use this question to detect weak influence strategies. Avoid these traps. 1. The authority argument, saying people adopted your idea simply because you were the most senior engineer in the room. 2. The opinion battle, describing a debate where you won by arguing louder rather than presenting evidence. 3. The manager shortcut, escalating your idea to leadership so they force the team to accept it. 4. The silent success, claiming your idea was eventually adopted but failing to explain how you persuaded others. 5. The no resistance story, presenting a situation where everyone immediately agreed, which suggests the idea was never truly challenged.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate whether you demonstrate these influence signals. 1. Credibility. Did the candidate support their idea with data or technical analysis? 2. Empathy. Did they understand the concerns and priorities of other engineers? 3. Communication. Could they explain the idea clearly and address objections? 4. Persistence. Did they iterate on the proposal instead of abandoning it after initial resistance? 5. Impact. Did the idea ultimately improve the system or the business? Strong candidates demonstrate influence through reasoning and collaboration.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our platform relied heavily on synchronous API calls between services, which caused cascading failures during traffic spikes. Task: I proposed introducing asynchronous messaging using a queue-based architecture to decouple critical services. Action: initially, several engineers resisted the idea because they worried it would complicate debugging. I built a small prototype using Kafka and demonstrated how it improved service resilience under simulated load tests. I also documented clear debugging patterns so engineers could understand message flows. Result: after seeing the prototype results, the team agreed to adopt the event-driven architecture. Within 3 months, we migrated several critical services and reduced cascading failure incidents by 70%. Learning plus L. I learned that prototypes are the most effective persuasion tool in engineering discussions. Since then, I often build small proofs of concept before proposing major architectural changes. The plus L shows the candidate refined their influence strategy for future decisions.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR plus L answer demonstrates effective technical influence. 1. Credibility matched. You supported the proposal with load testing and a working prototype. 2. Empathy matched. You addressed the team's debugging concerns rather than dismissing them. 3. Communication matched. You documented the architecture clearly so engineers could understand how the system would work. 4. Persistence matched. You refined the proposal instead of abandoning the idea after initial resistance. 5. Impact matched. The architecture reduced cascading failures by 70%. This demonstrates persuasion through evidence rather than authority.
Follow-up 1. Clarification probe. Were you officially responsible for system architecture decisions at the time?
Answer: no. The architecture decisions were shared across the team. My role was to present the idea clearly, demonstrate its benefits, and address the concerns raised by other engineers.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the Kafka-based system would not introduce message ordering issues?
Answer: we designed the event streams using partition keys that preserved ordering for related entities. This allowed services to process events sequentially while still benefiting from asynchronous communication.
Follow-up 3. Level 5 or Level 6 senior depth. What if the team still refused to adopt your architecture proposal?
Answer: if the team still had concerns, I would narrow the scope and apply the architecture to a single non-critical service first. Demonstrating real production improvements is often the most convincing argument.
Follow-up 4. Curveball. What if your architecture change caused unexpected system complexity later?
Answer: architectural changes always involve trade-offs. If complexity increased, I would evaluate whether the resilience benefits justified it and refine our tooling and documentation to manage the new architecture effectively.
Leadership pro tip. Engineers are persuaded by evidence.
In engineering organizations, the most effective persuasion tool is not authority or debate. It is a working prototype backed by data. When engineers can see measurable improvements, adoption happens naturally. Question 8. Tell me about a time when you took initiative to improve something. Note: interviewers use this question to test proactive problem solving beyond your role, like automating workflows, signaling innovation and ownership at companies like Netflix and Amazon.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect passive engineers who wait for JIRA tickets. Avoid these traps. 1. The assigned task describing a project that was already assigned to you by management. That is execution, not initiative. 2. The small optimization, improving something trivial like refactoring a script instead of solving a meaningful business or reliability risk. 3. The complaint without action, pointing out a system flaw but stopping at "I told my manager about it." 4. The local fix, improving your own local workflow while ignoring the broader engineering impact. 5. The temporary patch, fixing a symptom without addressing the systemic architectural cause.
Here are the signals the interviewer is scoring.
While answering this question, interviewers evaluate whether you demonstrate these ownership signals. 1. Proactive ownership. Did the candidate identify a systemic risk without being prompted by an incident or a manager? 2. Technical depth. Did they validate their hypothesis using real telemetry or observability tools? 3. Execution. Did they write an RFC and drive the engineering solution? 4. Impact. Did the change produce measurable, quantified improvements? 5. Systemic thinking. Did they introduce CI/CD guardrails to prevent regression? Strong candidates improve the entire system, not just the single bottleneck.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. While casually reviewing our production dashboards in Datadog, I noticed our checkout API's P95 latency was gradually creeping up, occasionally breaching our 200 millisecond service level objective during traffic bursts. Task. The spikes were not triggering pager duty yet, but I recognized it as a hidden reliability risk that would cause timeouts during our upcoming peak season. Action. I analyzed the distributed traces and found the bottleneck: synchronous cache misses. I drafted a lightweight RFC proposing an asynchronous cache stampede protection mechanism using RIDI's background workers and built a prototype during my focus time. Result: after peer review and deployment, P95 latency dropped from 240 milliseconds to 110 milliseconds, a 54% improvement, and our SLO violations dropped by 87%. Learning plus L. I realized we should not rely on humans spotting dashboard trends. I introduced automated latency regression tests into our CI pipeline, ensuring any PR that degraded latency by more than 10% would fail the build. The plus L shows that the candidate replaced human vigilance with automated governance.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L structure satisfies the FAANG leadership rubric. 1. Ownership matched. You proactively investigated a reliability risk before it triggered an incident. 2. Technical depth matched. You used Datadog traces to pinpoint the exact synchronous bottleneck. 3. Execution matched. You did not just complain. You wrote an RFC and built the async RIDI's architecture. 4. Impact matched. You quantified the business value, 54% latency drop, 87% fewer SLO violations. 5. Systemic thinking matched. The CI latency regression tests now prevent future performance decay. This turns a simple performance tweak into a system-wide reliability upgrade.
Follow-up 1. Clarification probe. Why did you investigate the latency spikes if they were not causing active incidents or customer complaints?
Answer: because SLO breaches often appear as gray failures before becoming hard outages. The Datadog dashboard showed a clear, degrading trend. At senior level, my job is not just to put out fires. It is to identify where the next fire will start and remove the kindling. Fixing it early meant we stabilized performance before the Black Friday traffic spike hit.
Follow-up 2. Level 3 or Level 4 junior depth. How did you confirm the synchronous cache refresh was the root cause, rather than just a slow database query?
Answer: I correlated the Datadog application traces with our RIDI's metrics. The flame graphs clearly showed the application threads blocking while waiting for the cache invalidation and synchronous rebuild to complete. The database queries themselves were fast, but the cache stampede was locking up the application threads.
Follow-up 3. Level 5 or Level 6 senior depth. Moving from synchronous to asynchronous cache updates introduces eventual consistency. How did you ensure this did not negatively impact the business logic?
Answer: that was the primary trade-off in the RFC. I met with the product manager to define the acceptable staleness window. We agreed that serving a 30-second-old cached price was acceptable, but serving an out-of-stock item was not. I implemented a targeted TTL strategy where critical inventory data remained synchronous, while heavy, non-critical metadata used the async refresh.
Follow-up 4. Curveball. What if your product manager told you to stop working on this prototype because it was not on the current sprint roadmap?
Answer: I would respect the roadmap but defend the technical debt. I would quantify the risk for them. If we do not fix this now, the data shows a 70% probability we will experience checkout timeouts during peak season. If they still deprioritized it, I would accept the business decision, disagree and commit, but ensure the risk was formally documented in our backlog so we were not caught off guard.
Leadership pro tip. Initiative means removing risk.
Senior engineers do not wait for outages to improve systems. They hunt for gray failures, slow queries, rising error rates and degrading SLOs, and proactively strengthen the architecture. When you show initiative in an interview, prove that your actions prevented a future disaster. Question 9. Tell me about a time you had to manage or mentor someone struggling. Note: interviewers use this question to evaluate empathy, coaching skills, and growth enablement in underperformers, a people leadership signal prized at companies like Google and Apple.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers watch carefully for how you describe the struggling teammate. Avoid these traps. 1. The savior complex: they could not do it, so I just rewrote their code for them to meet the deadline. This enables bad habits and does not scale. 2. The condescending tone, using words like incompetent or lazy to describe the person. This shows zero empathy or leadership. 3. The vague feedback trap, telling them to do better without providing actionable, measurable milestones. 4. The instant PIP move, escalating straight to HR or a performance improvement plan before attempting one-on-one coaching. 5. The sink or swim mentality, assigning them a difficult task and watching them fail without providing guardrails or pair programming.
Here are the signals the interviewer is scoring.
While answering this question, interviewers evaluate whether you demonstrate these mentorship signals. 1. Root cause empathy. Did the candidate figure out why the person was struggling? Skill gap versus motivation versus personal issues. 2. Structured coaching. Did they provide a clear, actionable plan for improvement? 3. Accountability. Did they hold the struggling engineer accountable for meeting the new expectations? 4. Psychological safety. Did they create an environment where the engineer felt safe asking questions? 5. Systemic thinking. Did they improve the onboarding or documentation process so others would not struggle in the same way? Strong leaders build systems that make it easier for people to succeed.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: a newly hired mid-level engineer on my team was consistently missing sprint commitments. Their PRs were routinely rejected for architecture flaws, and they were beginning to withdraw in stand-ups. Task: as the tech lead, I needed to intervene, uncover the root cause of the struggle, and get them back on track without doing their work for them. Action: in a private one-on-one, I asked open-ended questions and discovered they were overwhelmed by our undocumented microservices architecture. I stopped giving them complex feature work. Instead, I paired them with myself for one sprint, assigned them exclusively to writing integration tests to learn the system boundaries safely, and set up twice-weekly 15-minute architecture whiteboard sessions. Result: by breaking the learning curve into smaller, verifiable chunks, their confidence returned. Within 6 weeks, they were independently delivering complex features, and their PR rejection rate dropped to the team average. Learning plus L. I realized our onboarding process relied entirely on tribal knowledge. I subsequently drafted a developer first 30 days playbook and mandated architecture decision records, ADDR, so future hires would not hit the same wall. The plus L proves that you recognize when a people problem is actually a process problem.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L structure satisfies the FAANG leadership rubric. 1. Root cause empathy matched. You investigated and found the issue was missing documentation, not a lack of talent. 2. Structured coaching matched. You shifted their workload to writing integration tests, a safe way to learn the codebase. 3. Accountability matched. You set up twice-weekly check-ins to monitor progress without micromanaging. 4. Psychological safety matched. You took the conversation offline to a private one-on-one to avoid embarrassing them in stand-up. 5. Systemic thinking matched. The plus L step solved the problem globally by creating a standardized 30-day onboarding playbook. This turns a frustrating team dynamic into an organizational win.
Follow-up 1, clarification probe. How did you broach the topic in the initial one-on-one without making them defensive?
Answer: I framed it around my failure as a leader, not their failure as an engineer. I said, I noticed you have been hitting some blockers on the recent PRs. I want to make sure I have not set you up to fail. Do you feel like you have the context and documentation you need to execute these tickets? This immediately lowered their defenses and opened an honest dialogue.
Follow-up 2, level 3 or level 4 junior depth. You mentioned you had them write integration tests. Why was that the specific coaching strategy?
Answer: writing integration tests forces an engineer to understand the inputs, outputs, and boundaries of a microservice without the pressure of designing the internal business logic. It provides immediate, automated feedback. The test passes or fails, which builds confidence much faster than waiting for a human PR review.
Follow-up 3, level 5 or level 6 senior depth. Redirecting your time to pair program and mentor them must have impacted your own sprint deliverables. How did you manage that trade-off?
Answer: I explicitly communicated the trade-off to my engineering manager. I explained that spending 20% of my time mentoring them now was an investment that would yield a 100% capacity engineer in 6 weeks. If I did not make that investment, we would be carrying a net negative contributor indefinitely, which is far worse for the team's long-term velocity.
Follow-up 4, curveball. What if, after the 6 weeks of pairing and coaching, their code quality still was not improving and they were dragging the team down?
Answer: if I have provided clear expectations, dedicated support, and measurable milestones, and the performance still does not improve, my role shifts from coach to manager. I would formally document the ongoing gaps, escalate to HR and the engineering manager, and initiate a formal performance improvement plan. PIP. You must protect the team's morale and velocity from chronic underperformance.
Leadership pro tip: is it skill or will?
When someone is struggling, elite engineering leaders immediately diagnose whether it is a skill issue or a will issue. A skill issue, lack of knowledge, can be fixed with documentation, pairing, and patience. A will issue, lack of effort, or toxic attitude, cannot be coded away and requires swift management intervention. Diagnose first, act second. Question 10. Tell me about a time you handled an underperforming teammate. Note: this question is interesting because it tests accountability and difficult interpersonal leadership. Senior engineers are expected to address performance issues constructively while maintaining team morale. This type of question is commonly asked at companies like Amazon and Google.
Here are the critical red flags, the instant rejection signals.
FAANG interviewers use this question to detect candidates who avoid conflict or handle it unprofessionally. Avoid these traps. 1. The avoidance trap: ignoring the problem and just doing the person's work for them to avoid an uncomfortable conversation. 2. The immediate escalation: running straight to the manager before attempting to solve the issue peer-to-peer. 3. The public shaming: calling the person out in a stand-up or group setting rather than privately. 4. The vague feedback: telling them to do better without providing specific, actionable examples. 5. The lack of empathy: assuming they are lazy without investigating if they are blocked, burned out, or lacking context.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 leadership signals. 1. Courage: did the candidate have the difficult conversation directly with the peer? 2. Empathy and discovery: did they seek to understand the root cause of the underperformance? 3. Actionable feedback: did they provide specific, constructive examples rather than personal attacks? 4. Support: did they offer help or resources to get the teammate back on track? 5. Escalation judgment: did they know when it was appropriate to eventually involve management? Strong candidates balance high standards with deep empathy.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: a mid-level engineer on my team was consistently missing sprint deadlines and submitting PRs with basic logic errors, which was slowing down our release cycle. Task: as the tech lead, I needed to address the performance drop to protect the team's velocity while helping the engineer recover. Action: I scheduled a private one-on-one. Instead of accusing them, I used data. I noticed your last 3 PRs required significant rework, and you missed the deadline. Is there a blocker I can help remove? They admitted they were overwhelmed by a new internal framework. I set up daily 15-minute pairing sessions and assigned them smaller, focused tickets to rebuild their confidence. Result: within 3 sprints, their code quality returned to baseline, and they successfully delivered a critical component of the release independently. Learning plus L. I learned that sudden underperformance is rarely a skill issue. It is usually a context issue. I later pushed to improve our team's documentation for that specific internal framework. The +L shows you fixed the systemic issue documentation that caused the personal struggle.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature performance management. 1. Courage matched: you initiated the private one-on-one rather than waiting for the manager to notice. 2. Empathy matched: you framed the conversation around removing blockers, not assigning blame. 3. Actionable feedback matched: you cited specific data, the last 3 PRs, rather than vague feelings. 4. Support matched: you provided tangible help through pair programming and scoped tickets. 5. Systemic thinking +L matched: you identified the root cause, poor documentation, and fixed it for future engineers. This demonstrates that you can manage performance without relying on formal authority.
Follow-up 1. Clarification probe. Did you inform your engineering manager that you were having this conversation with the teammate?
Answer: I briefly mentioned to my manager that I noticed the engineer was struggling and that I was going to offer some pairing support. I did not frame it as a performance issue to management yet, because I wanted to give the engineer a chance to correct it peer-to-peer first.
Follow-up 2, Level 3 or Level 4 junior depth. How did you balance spending time pairing with them while still meeting your own sprint deliverables?
Answer: I explicitly communicated the trade-off to the team. I stated in stand-up that I would be dedicating 20% of my capacity this sprint to pairing and unblocking. By being transparent, I managed expectations around my own output while ensuring the team knew we were investing in long-term velocity.
Follow-up 3, Level 5 or Level 6 senior depth. What if the engineer had become defensive during that one-on-one and denied that their work was subpar?
Answer: if they became defensive, I would de-escalate the emotion and return to the data. I would say, I'm not questioning your effort. I'm looking at the PR rejection rate compared to the team average. If they still refuse to acknowledge the gap, I would document the conversation and at that point, escalate to the engineering manager as it transitions from a coaching opportunity to a formal performance management issue.
Follow-up 4, Curveball. What if you found out the root cause was not the framework, but that they were secretly working a second full-time job?
Answer: that immediately crosses the line from a performance issue into an ethical and legal violation of company policy. As a senior leader, I cannot manage that peer-to-peer. I would immediately escalate the finding to my manager and HR with the evidence I had, and step back from the coaching process.
Leadership pro tip: the skill versus will matrix.
Elite engineering leaders use the skill versus will framework. If it is a skill issue they do not know how, you coach them. If it is a will issue they do not care or they are toxic, you manage them out. Diagnose the root cause quickly and apply the correct intervention. Question 11. Tell me about a time you had to delegate work effectively. Note: this question is interesting because it tests whether senior engineers understand leverage and how to distribute work across a team efficiently. Delegation and engineering leverage are major leadership signals in organizations like Amazon and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to find candidates who either micromanage or abdicate responsibility. Avoid these traps. 1. The task dumper, assigning work without providing the necessary context, resources, or deadlines. 2. The micromanager, delegating a task but then hovering over the engineer and dictating exactly how to write every line of code. 3. The only I can do it complex, refusing to delegate critical tasks because you believe no one else is capable, which creates a massive bottleneck. 4. The zero follow-up, delegating a task and never checking in until the deadline is missed. 5. The blame shifter, delegating a task, watching it fail, and blaming the junior engineer for the failure.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 leverage signals. 1. Trust and empowerment. Did the candidate empower the team to make decisions? 2. Clarity of scope. Were the goals, constraints, and definitions of done clear? 3. Milestone management. Did they establish appropriate check-ins without micromanaging? 4. Growth opportunity. Did they delegate tasks that helped a junior engineer stretch their skills? 5. Ultimate accountability. Did they accept that while the task is delegated, the final accountability remains with them? Strong candidates use delegation to build team capacity, not just to clear their own plate.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: I was leading a critical database sharding migration. I was drowning in the architectural planning, but we also needed to write a massive suite of data validation scripts before the cutover. Task: I needed to delegate the validation script creation to a mid-level engineer so I could focus on the core migration logic, ensuring both were done on time. Action: instead of just handing them a Jira ticket, I wrote a one-page technical brief defining the inputs, expected outputs, and edge cases. I told them what needed to be built, but left the how, language, libraries up to them. We agreed on a mid-week design review so I could provide course correction early. Result: empowered by the autonomy, the engineer delivered a highly efficient Python validation suite ahead of schedule. This freed me to finalize the architecture, and the migration was executed flawlessly. Learning plus L. I learned that the key to delegation is defining the API boundary of the task. I started applying this: define the what, Delegate the how template to all epic-level planning. The +L shows you scaled your delegation methodology into a reusable template.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature engineering leverage. 1. Trust and empowerment matched. You let the engineer choose the language and libraries, giving them ownership. 2. Clarity of scope matched. You provided a one-page technical brief defining inputs and edge cases. 3. Milestone management matched. You scheduled a specific mid-week review to catch errors early. 4. Growth opportunity matched. You gave a mid-level engineer ownership of a critical migration component. 5. Ultimate accountability matched. By checking in midweek, you ensured the project would not fail under your watch. This demonstrates that you understand the difference between delegation and abdication.
Follow-up 1. Clarification probe. During the midweek design review, did you have to course-correct the engineer?
Answer: yes. They had chosen a library that was not approved by our InfoSec team. Because we caught it at the design phase rather than during the final PR review, it took them only 30 minutes to swap the library out, saving days of wasted effort.
Follow-up 2. Level 3 or Level 4 junior depth. How did you decide which specific parts of the project to delegate and which parts to keep for yourself?
Answer: I kept the high-risk, high-complexity architectural decisions, the actual sharding logic and cutover sequence, because those required deep historical context of the system. I delegated the data validation scripts because they were a discrete, decoupled task with clear inputs and outputs.
Follow-up 3. Level 5 or Level 6 senior depth. What if the engineer had missed the deadline, putting the entire migration at risk? Who is responsible?
Answer: I am. As the project lead, delegated work is still my responsibility. If they miss the deadline, it means my midweek check-ins were not rigorous enough, or I misjudged their capacity. In that scenario, I would immediately step in to pair program with them to cross the finish line, and later adjust my delegation strategy for their specific skill level.
Follow-up 4. Curveball. What if the engineer pushed back and said, I'm already at full capacity this sprint. I cannot take this on?
Answer: I would respect their capacity. I would not force them to burn out. Instead, I would sit down with them and their manager to review the sprint board. I would ask, given that this migration is a P0 business priority, what lower priority tasks can we safely bump to the next sprint to make room for this? Delegation requires prioritization.
Leadership pro tip. Define the what, not the how.
The fastest way to kill a senior engineer's momentum is to become a bottleneck. FAANG companies expect L5 and L6 engineers to be force multipliers. You achieve leverage by defining the what, the exact requirements, and letting the team define the how, the implementation. This builds trust and scales your impact. Question 12. Describe a time when you had to step into a leadership role unexpectedly. Note, this question is interesting because it tests situational leadership and crisis ownership. Senior engineers are expected to take control during ambiguous or high-pressure situations, even without formal authority. This is a common evaluation pattern in organizations like Netflix and Amazon.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who hesitate during crises or act recklessly. Avoid these traps. 1. The wait for permission, waiting for a manager to wake up or step in before taking action to stop a critical failure. 2. The lone wolf fixer, jumping into the terminal to solve technical issues silently without coordinating the rest of the panic team. 3. The hero narrative, claiming you solved the entire outage alone without delegating or recognizing the team's contributions. 4. The blame story, spending your interview criticizing the missing leader instead of describing how you stabilized the situation. 5. The short-term fix, resolving the immediate technical issue but ignoring the systemic reason the leadership gap occurred in the first place.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these situational leadership signals. 1. Situational awareness. Did the candidate recognize that a leadership vacuum existed and needed immediate filling? 2. Initiative. Did they step in proactively to establish order, or did someone have to ask them to? 3. Incident command. Did they organize the team effectively, delegating tasks rather than trying to do everything themselves? 4. Decision making. Did they make clear, confident, and data-driven decisions under extreme pressure. 5. Systemic improvement. Did they institute a process change to prevent future leadership gaps? Strong candidates demonstrate leadership through decisive action and subsequent systemic repair.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. During a Black Friday promotion, our primary payment gateway started returning intermittent 500 errors. The designated incident commander, Ike, lost internet connectivity due to a severe local storm, leaving the response team paralyzed and panicking in Slack. Task. As a staff engineer on the call, I needed to immediately assume the IC role to stop the bleeding and coordinate the diagnostic effort, despite not being officially on call. Action. I explicitly announced in the channel, I am taking IC. I stopped everyone from making speculative changes. I assigned one engineer to monitor Datadog traces, another to check database locks, and a third to draft external comms. When traces showed the primary gateway API was failing, I made the call to initiate our circuit breaker and failover to the secondary gateway. Result, the failover was executed smoothly, stabilizing the checkout process within 12 minutes and preventing an estimated $150,000 in lost revenue. Learning, plus L. I realized our incident process had a single point of failure. I later authored an RFC to implement an automated shadow IC protocol, ensuring every high-severity incident automatically pages a designated backup leader if the primary IC drops off for more than 2 minutes. The plus L proves you do not just survive crises, you engineer systems to prevent them.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite crisis management. 1. Situational awareness matched. You recognize the leadership vacuum and the danger of speculative changes during a SEV1. 2. Initiative matched. You explicitly declared yourself the incident commander to restore order. 3. Incident command matched. You delegated specific diagnostic vectors rather than trying to debug the gateway yourself. 4. Decision-making matched. You made the authoritative call to failover based on data, not guesses. 5. Systemic improvement matched. The plus L step solved the organizational vulnerability by formalizing a shadow IC protocol. This demonstrates that true leadership is seized during moments of friction, not granted by a title.
Follow-up 1, clarification probe. How did the official incident commander react when they finally reconnected and saw you had taken over?
Answer: they were incredibly relieved. Because I had maintained strict communication discipline in the incident channel, they were able to read the log, see exactly what actions were taken and why, and immediately get up to speed. I then formally handed the IC role back to them so they could lead the post-mortem, ensuring they did not feel undermined.
Follow-up 2, Level 3 or Level 4 Junior Depth. Why did you explicitly announce, I am taking IC, instead of just starting to give directions?
Answer: during a high-severity incident, implicit leadership creates confusion. Multiple engineers might start giving conflicting directions, leading to duplicated effort or, worse, competing configuration changes. By explicitly claiming the role using standardized incident terminology, I established a clear chain of command and stopped the chaos.
Follow-up 3, Level 5 or Level 6 Senior Depth. What would you have done if the root cause had not been identified quickly and the outage dragged on for hours?
Answer: as an incident commander, my primary job is mitigation, not root cause analysis. If the diagnostic teams could not find the bug quickly, I would have aggressively shifted all focus away from troubleshooting and entirely toward mitigation, such as enforcing heavy traffic throttling or disabling non-essential features, to protect the core checkout flow.
Follow-up 4, Curveball. What if your decision to failover to the secondary gateway actually made the situation worse by overwhelming an under-provisioned system?
Answer: incident response always involves making risk decisions with incomplete data. If my failover caused cascading failures, I would immediately announce the mistake, roll back the routing change, and explicitly halt any further speculative actions. During a SEV1, making blind guesses creates worse outages. You stabilize the bleeding, reassess the telemetry, and pivot your strategy.
Leadership pro tip: never let a good crisis go to waste.
In high-performing engineering cultures, An unexpected crisis is the ultimate proving ground. Interviewers want to see that you view chaos not as a threat, but as an opportunity to establish order. Furthermore, elite architects always extract systemic value from a failure. Fixing the outage proves you are a good engineer. Building a protocol to prevent the leadership gap from recurring proves you are a leader.
Category 1 Wrap-Up, the essence of ownership.
You have now mastered the leadership and ownership category. You understand that true FAANG leadership is not about managing people. It is about managing outcomes, taking extreme ownership of system failures, and stepping up when the organization is paralyzed. But taking charge is only half the equation.
Transition from ownership to alignment.
In a massive enterprise, you cannot build a system alone. You have to influence product managers, negotiate with other engineering teams, and resolve deep technical disagreements without creating toxic environments. This brings us to the second most heavily tested area in the FAANG loop: collaboration and teamwork.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google Caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep: fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
The Google SRE interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war-room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Category 2 Collaboration and teamwork.
Interviewers use these questions to test your emotional intelligence and maturity. They want to know if you view conflict as a personal attack or as a necessary tool to find the best technical truth. At the staff and principal levels, interviewers are measuring your team scalability. Do you make the people around you better, or do you create friction?
Collaboration and teamwork, part 1 of 2.
The first half of this category focuses intensely on your ability to handle interpersonal and technical friction. 13. Tell me about a time you had a conflict with a coworker. 14. Describe a disagreement with your manager. 15. Tell me about a time when your idea was rejected. 16. Describe a time you had to convince someone who strongly disagreed. 17. Tell me about a difficult teammate. 18. Tell me about a time you had to work with someone very different from you. 19. Describe a situation where collaboration failed and how you handled it. If you cannot resolve a disagreement without escalating to your manager, you will fail the senior loop.
Collaboration and teamwork, part 2 of 2.
The second half evaluates your ability to operate globally and across different business domains. 20. Tell me about a time when communication broke down on your team. 21. Tell me about a time you worked with a cross-functional team, product or design or marketing. 22. Tell me about a time you collaborated with a non-technical stakeholder. 23. Describe working with a distributed or remote team across time zones. 24. Tell me about a time when you had to align multiple teams with different priorities. 25. Describe a time you worked on a diverse team and how you ensured inclusivity. Enterprise architects must align business, product, and engineering under one unified vision. Question 13. Tell me about a time you had a conflict with a coworker. Note, interviewers use this question to evaluate whether you can resolve technical disagreements objectively using data without damaging relationships, which is a major leadership signal evaluated at companies like Meta and Netflix.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who are toxic, passive, or arrogant. Avoid these traps. 1. The "I was right" narrative, spending 5 minutes proving your technical superiority while painting your coworker as incompetent. 2. The fake conflict, giving a non-answer like "we disagreed, so I showed them the code and they instantly agreed." That is not a conflict. 3. The Slack warrior, describing a heated argument that took place entirely over text or pull request comments without taking it offline. 4. The immediate escalation, running to the engineering manager to act as a referee before trying to find a peer-to-peer compromise. 5. The pushover, yielding to a bad technical decision simply to avoid having an uncomfortable conversation.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 collaboration signals. 1. De-escalation. Did the candidate move the conversation out of a public text-based forum into a private high-bandwidth medium? 2. Empathy. Did they actively try to understand the constraint or goal driving the coworker's position? 3. Objectivity. Did they use data, benchmarks, or architecture principles to resolve the issue instead of opinions? 4. Compromise. Did they find a path forward that satisfied the business requirement without breaking the system? 5. Systems thinking. Did they implement a process to prevent similar subjective arguments in the future? Strong candidates turn interpersonal friction into architectural alignment.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. During a major UI rewrite, the front-end lead and I, back-end lead, had a sharp disagreement. They wanted a single, massive GraphQL payload for the dashboard. I insisted on paginated REST endpoints because our legacy database could not handle the heavy join required for the single payload. Task. The argument was stalling the sprint in the PR comments. I needed to resolve the deadlock without sacrificing back-end stability or ruining the UI performance. Action. I realized Slack was stripping our tone, so I took it offline to a 15-minute video call. I started by asking about his core constraint. He explained he had a strict sub-200 milliseconds render budget. I ran a quick load test showing the GraphQL query would take 800 milliseconds and crash the DB under peak load. We compromised by introducing a backend for frontend BFF layer using Redis to pre-aggregate the data he needed. Result: the BFF pattern met his 200 milliseconds render budget while completely shielding the legacy database from heavy joins. The feature launched with 0 timeouts. Learning +L. I learned that a PI design should not happen in PR comments. I introduced a mandatory API contract RFC, request for comments, template for all future features, forcing alignment before a single line of code is written. The +L shows you replaced emotional arguments with a structured engineering process.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite conflict resolution. 1. De-escalation matched. You recognize the toxicity of arguing in PR comments and moved to a video call. 2. Empathy matched. You stopped arguing your side and asked about his goal, the 200 milliseconds render budget. 3. Objectivity matched, you proved your point with a load test benchmark, not ego. 4. Compromise matched, you did not just force rest. You architected a BFF layer that solved both of your constraints. 5. Systems thinking matched, the +L step introduced RFCs, eliminating the root cause of the friction for the whole organization. This demonstrates you handle conflict like an architect, not a junior coder.
Follow-up 1. Clarification probe. Building a backend for front-end BFF layer takes time. Did this compromise cause you to miss the sprint deadline?
Answer: it added 3 days of scope to the backend work, but we still met the release date. I explicitly raised the scope change in our daily stand-up, and the product manager agreed that spending 3 days building a stable BFF was cheaper than spending 3 weeks fixing database crashes in production.
Follow-up 2. Level 3 or Level 4 junior depth. How did you run a load test so quickly during an active sprint dispute?
Answer: I did not build a massive test suite. I wrote a simple K6 script that fired 50 concurrent requests against a staging replica running the proposed GraphQL query. The metric that mattered was the database CPU spiking to 100%, which took less than an hour to prove, and provided the objective data we needed to move forward.
Follow-up 3. Level 5 or Level 6 senior depth. What if, even after seeing the load test data, the front-end lead refused to compromise and escalated to the VP of engineering claiming you were blocking them?
Answer: if data fails, it becomes an alignment issue. I would welcome the escalation, but I would structure it as a risk decision rather than a personal fight. In the meeting with the VP, I would present the benchmark data alongside the front-end lead's requirements and ask the VP to decide, do we accept the risk of database latency to ship this specific UI experience, or do we prioritize stability? Once the business owner makes the call, I execute it fully.
Follow-up 4. Curveball. 2 weeks after launch, you discover that the Redis BFF layer you proposed is actually causing massive memory leaks and restarting. How do you handle that with the coworker you argued with?
Answer: I own the failure immediately and publicly. I would message the front-end lead and the team, stating, my BFF architecture is causing memory leaks. I am leading the incident response now to patch it. Taking extreme ownership of your own mistakes builds immense trust. If you are quick to bring data to win an argument, you must be just as quick to bring data when your solution fails.
Leadership pro tip. Conflict is missing context.
In engineering, 90% of conflicts are not personal. They are the result of missing context. The front-end engineer did not want to crash the database. He just wanted a fast UI. The back-end engineer did not want a slow UI. She just wanted a stable database. When you face conflict in an interview, frame it as a puzzle of competing constraints rather than a battle of egos. Question 14. Describe a disagreement with your manager. Note, this question is interesting because it tests whether you can push back on authority using data rather than emotion, and whether you understand the principle of disagree and commit. This is a major leadership signal evaluated at companies like Amazon and Apple.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who are either insubordinate or overly compliant. Avoid these traps. 1. The yes man saying you have never disagreed with a manager. This signals a lack of technical backbone and independent thought. 2. The ego war, describing a disagreement where your primary goal was proving you were smarter than your boss. 3. The silent mutiny, disagreeing, losing the argument, and then passive-aggressively doing a bad job executing the manager's decision. 4. The opinion battle, arguing based on best practices or clean code without tying your argument to business risk or customer impact. 5. The public humiliation, confronting or correcting your manager in front of stakeholders or junior engineers.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 collaboration signals. 1. Data-driven pushback. Did the candidate use objective metrics to challenge the manager's directive? 2. Upward empathy. Did they understand the business pressure or constraint driving the manager's request? 3. Constructive compromise. Did they offer a solution that mitigated risk while still hitting the business goal? 4. Disagree and commit if overruled. Did they execute the manager's final decision flawlessly? 5. Professionalism. Was the disagreement handled privately and respectfully, Strong candidates protect the system without undermining their leadership.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: my manager directed our team to bypass the final load testing phase of a new payment API to ensure we hit a strict end-of-quarter OKR deadline. Task: I believed skipping load tests on a financial system was dangerously risky, but I also understood my manager was under intense pressure from the VP to deliver the milestone. Action: I did not just say no. I wrote a one-page risk assessment document. I used historical data to show that deploying untested payment services had a 60% probability of causing an outage, which would cost more in SLA penalties than missing the OKR. I proposed a compromise. We do a dark launch, shadow traffic only, to hit the deployment OKR, but delay the live traffic cutover by 48 hours to run the load tests. Result: my manager appreciated the data and accepted the dark launch compromise. We hit the OKR, and the 48-hour load test actually caught a severe thread-locking bug that would have taken production offline. Learning plus L. I learned that managers push for speed when they lack visibility into risk. I subsequently built an automated deployment risk matrix dashboard, giving leadership real-time visibility into test coverage so they could make informed trade-offs. The plus L shows you fix the communication gap between engineering and management.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature upward management. 1. Data-driven pushback matched. You used a one-page risk assessment and historical SLA penalty data instead of arguing about best practices. 2. Upward empathy matched. You acknowledged the manager's pressure to hit the end-of-quarter OKR. 3. Constructive compromise matched. You proposed a dark launch to satisfy the business timeline while protecting the technical infrastructure. 4. Disagree and commit matched. You framed the conversation around finding a mutual win, showing you are a strategic partner. 5. Professionalism matched. You handled it via a structured document rather than an emotional argument. This demonstrates that you manage your manager as well as you manage your code.
Follow-up 1. Clarification probe. Did the dark launch actually satisfy the business OKR, or was that just a technical loophole?
Answer: it satisfied the exact wording of the OKR, which was deploy the new payment API to production by quarter 3. By deploying it to production but routing shadow traffic to it, we technically delivered the milestone. This decoupled the concept of deployment from release, allowing us to satisfy executive tracking without endangering the customer.
Follow-up 2. Level 3 or Level 4 junior depth. How did you generate the risk data so quickly if you were already under a tight deadline?
Answer: I did not start from scratch. I pulled the post-mortem reports from the last 3 major outages our organization had, all of which were caused by bypassed performance testing. Bringing past incident reports to a current debate is the fastest way to quantify risk without needing to run new experiments.
Follow-up 3. Level 5 or Level 6 senior depth. What if your manager had rejected your one-pager and ordered you to do a full live cutover immediately? What would you do?
Answer: I would disagree and commit. I would explicitly state, I advise against this due to the risk of a database lock, but if this is the business decision, I will execute it flawlessly. I would then immediately prepare the rollback scripts, alert the on-call SRE team to be on standby, and ensure the deployment was heavily monitored. If you lose the debate, your job is to mitigate the fallout.
Follow-up 4. Curveball. What if the dark launch succeeded, but in the executive review meeting, your manager took 100% of the credit for the idea of the shadow deployment?
Answer: in the moment, I would stay completely silent and let the manager take the credit. The goal of an engineer is system stability and business success, not personal ego. However, during my next private one-on-one with that manager, I would politely but firmly set a boundary, requesting that technical contributions from the team be accurately represented to leadership moving forward to ensure team morale.
Leadership pro tip. Disagree and commit.
Disagree and commit does not mean argue and surrender. It means you have a professional obligation to bring data to a debate and fight for the best technical outcome. But once the person with the business authority makes the final call, you must execute their decision with the exact same passion and rigor as if it were your own idea. Sabotaging a decision you disagree with is a fast track to termination. Question 15. Tell me about a time when your idea was rejected. Note, interviewers use this question to evaluate your resilience, ego management, and ability to disagree and commit when leadership overrides your technical proposal, which is a major collaboration signal evaluated at companies like Amazon and Apple.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who are arrogant or take technical rejection personally. Avoid these traps. 1. The bitter genius, claiming your idea was rejected because leadership did not understand the tech or was too short-sighted. 2. The passive-aggressive execute, saying you did what they asked but making it clear you made sure everyone knew it would fail. 3. The frivolous idea, pitching an idea that was rejected because it lacked data, research, or business justification in the first place. 4. The never surrender, bragging about how you secretly built your idea anyway after being told no. This is insubordination, not innovation. 5. The defeated developer, admitting that the rejection killed your motivation and caused you to disengage from the project.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 collaboration signals. 1. Ego management. Did the candidate separate their self-worth from their technical proposal? 2. Business acumen. Did they understand why the idea was rejected, for example, cost, timeline, org readiness? 3. Resilience. Did they bounce back quickly and channel their energy into the approved path? 4. Disagree and commit. Did they fully support and optimize the alternative solution? 5. Systemic learning. Did they adapt their future proposals based on this rejection? Strong candidates prove that their ultimate loyalty is to the business outcome, not their own ideas.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. During a massive latency reduction initiative, I pitched migrating our core inter-service communication from REST to gRPC. I built a working proof of concept showing a 40% drop in payload size and latency. Task. I presented the architecture proposal to the engineering review board, advocating strongly for the migration to hit our performance OKRs. Action. The board rejected the proposal. While the performance data was undeniable, the principal architect pointed out that our DevOps team had zero tooling for gRPC observability, meaning an outage would be impossible to debug. I immediately dropped my defense of gRPC, validated their operational concern, and pivoted my effort. I led a task force to heavily optimize our existing REST payloads instead, utilizing aggressive compression and field trimming. Result, we achieved a 28% latency reduction using the optimized REST endpoints. It did not hit the 40% of gRPC, but it shipped weeks earlier with zero operational risk. Learning plus L. I learned that the best technology is useless if the organization cannot operate it. I subsequently co-authored a tech radar document with DevOps to map out our operational readiness for new protocols before teams invest time in POCs. The +L shows you learn to align technical innovation with operational reality.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates extreme professional maturity. 1. Ego management matched. You did not argue when faced with the operational reality. You dropped the defense and pivoted. 2. Business acumen matched. You understood that debuggability trumped raw speed in a production environment. 3. Resilience matched. You did not sulk. You immediately started optimizing the REST endpoints. 4. Disagree and commit matched. You successfully executed the REST optimization, delivering a 28% improvement. 5. Systemic learning matched. The +L step, the tech radar, ensured future engineers would not waste time pitching unsupportable tech. This demonstrates you are an architect who balances innovation with operational safety.
Follow-up 1, clarification probe. Were you frustrated that you spent all that time building a proof of concept just for it to be rejected?
Answer, not at all. A proof of concept is designed to test a hypothesis, and in this case, it successfully proved the performance gains but also uncovered the operational gaps. That is exactly what a POC is supposed to do. The code was thrown away, but the architectural clarity we gained was highly valuable.
Follow-up 2, level 3 or level 4 junior depth. How did you achieve the 28% latency reduction in REST after the gRPC idea was scrapped?
Answer: I audited the JSON payloads and realized we were overfetching massive amounts of nested data that the downstream services were just ignoring. By implementing strict GraphQL-style field filtering on our REST endpoints and enabling Brotli compression at the API gateway, we drastically reduced the network transfer time without changing the protocol.
Follow-up 3, Level 5 or Level 6 senior depth. When leadership rejected the idea, how did you manage the morale of the junior engineers who helped you build the gRPC prototype?
Answer: I controlled the narrative immediately. I brought the team together and framed it as a massive strategic win, not a loss. I told them our code was so fast it exposed a gap in our infrastructure monitoring. I ensured they understood that their engineering was flawless, but the business constraint was operational. Protecting the team's morale from feeling rejected is a core duty of a tech lead.
Follow-up 4, Curveball. What if you absolutely knew that the REST optimizations would not be enough, and that failing to adopt gRPC would literally crash the system during Black Friday?
Answer: if it were a guaranteed existential threat to the business, I would escalate, but with a different strategy. I would not argue the code, I would argue the risk. I would write a document detailing the projected Black Friday load against our current REST capacity limits. I would then offer a phased rollout plan, partnering specifically with DevOps to build the gRPC observability tooling first, mitigating their primary objection before touching the application code.
Leadership pro tip: the best tech versus the right tech.
Junior engineers evaluate technology based on speed, elegance, and modern trends. Senior architects evaluate technology based on maintainability, organizational readiness, and total cost of ownership. When an interviewer asks about a rejected idea, they want to hear that you eventually agreed with the business constraint. Proving you can let go of a brilliant technical idea for the good of the company is the ultimate senior signal. Question 16. Describe a time you had to convince someone who strongly disagreed. Note: interviewers use this question to evaluate your ability to influence without authority, overcome deep technical bias using data, and navigate organizational friction. This is a critical evaluation of the have backbone, disagree and commit principle at companies like Amazon and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who rely on coercion or endless debating. Avoid these traps. 1. The appeal to authority, saying "I just had my manager talk to their manager to force them to do it." This proves zero interpersonal influence. 2. The debate champion, framing the disagreement as a battle you won by out-arguing the other person. This signals a combative, toxic teammate. 3. The buzzword bully, attempting to convince someone by just citing industry best practices or what Google does without providing local context. 4. The strawman argument, misrepresenting the coworker's valid concerns to make your own idea sound flawless. 5. The relentless nag, claiming you convinced them by simply bringing it up over and over until they gave in out of exhaustion.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 collaboration signals. 1. Empathy for constraints. Did the candidate actively listen to and validate the root cause of the disagreement? 2. Data-driven persuasion. Did they use prototypes, metrics, or architecture diagrams rather than opinions? 3. Risk mitigation. Did they alter their own proposal to address the safety concerns of the dissenter? 4. Professional respect. Did they maintain a collaborative tone with an opposing expert? 5. Systemic alignment. Did they document the resolution so the organization would not have the same argument again? Strong candidates prove that persuasion is about reducing fear, not increasing logic.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: we were decomposing a legacy monolith. I proposed a database per service architecture. Our principal DBA vehemently disagreed, arguing that losing strict ACID transactions across domains would lead to massive data corruption during financial rollbacks. Task: I needed to convince the DBA to support the decoupling, as sharing the database was causing severe deployment bottlenecks, but I could not ignore their valid concerns about data integrity. Action: I stopped arguing the theoretical benefits of microservices. I scheduled a working session and validated his fear distributed transactions are dangerous. Instead of pushing my original idea, I authored a targeted RFC introducing the transactional outbox pattern combined with a Saga orchestrator. I built a lightweight prototype simulating a network failure during a multi-step checkout, proving the system would automatically execute compensating transactions to restore consistency. Result: seeing concrete proof that failure states were handled gracefully eliminated the DBA's anxiety. He not only agreed to the architecture, but actively helped optimize the outbox polling queries. We decoupled the service and increased our deployment frequency by 5 times. Learning plus L. I learned that senior engineers do not resist change. They resist unmitigated risk. I created a standard distributed consistency checklist for our architecture guild to use whenever teams propose splitting databases in the future. The plus L translates a single hard-won consensus into a reusable organizational standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical persuasion. 1. Empathy for constraints matched. You acknowledged that the DBA's fear of losing ACID transactions was completely valid, not just legacy thinking. 2. Data-driven persuasion matched. You built a working prototype simulating a failure state instead of relying on whiteboard theory. 3. Risk mitigation matched. You adjusted your architecture by explicitly introducing the outbox and Saga patterns to ensure safety. 4. Professional respect matched. You turned an adversary into an ally who helped optimize the final design. 5. Systemic alignment matched. The plus L step introduced the distributed consistency checklist to the architecture guild. This demonstrates you influence others through engineering rigor, not corporate politics.
Follow-up 1. Clarification probe. Building a prototype of a Saga orchestrator and an outbox pattern sounds time-consuming. Did this stall the overall project?
Answer: it took me 2 days during a sprint buffer to build a stripped-down, mock version using an in-memory database and local queues. Those 2 days of effort saved us weeks of endless architectural debates and potential political escalation. In enterprise engineering, a fast prototype is often the cheapest form of conflict resolution.
Follow-up 2. Level 3 or Level 4 junior depth. How did the outbox pattern specifically address the DBA's fear of data corruption?
Answer: the DBA was afraid of dual-write failures, updating our database but failing to publish the event to Kafka, leaving systems out of sync. The outbox pattern solved this by writing the state change and the outbound event to the exact same database table in a single local ACID transaction. A separate process then reliably relayed that event to Kafka. It gave the DBA the local transactional guarantee they required, while giving me the event-driven decoupling I needed.
Follow-up 3. Level 5 or Level 6 senior depth. What if, even after the prototype and the RFC, the principal DBA still said no? We are keeping the shared database out of pure stubbornness.
Answer: if I have exhausted empathy, data, and prototypes, it becomes a business risk issue. I would formally escalate to the director of engineering, but I would not make it personal. I would present the RFC, the prototype data, and the DBA's objections side by side. I would ask leadership to make a definitive ruling on our risk appetite. Are we optimizing for zero distributed complexity, or are we optimizing for deployment velocity? Once leadership makes the call, I disagree and commit.
Follow-up 4. Curveball. What if, a year after you convinced him and deployed the Saga pattern, it caused a massive production outage due to orchestration complexity? How do you handle the "I told you so" moment?
Answer: I would take extreme public ownership of the failure. I would go directly to the DBA and say, "You were right about the complexity risk, and my design failed to handle this specific edge case." I would then lead the postmortem to uncover exactly why the compensating transactions failed. Hiding from your mistakes destroys influence. Owning them builds permanent trust.
Leadership pro tip. Persuasion is risk mitigation.
Junior engineers think persuasion is about proving their idea is the smartest. Senior architects know that persuasion is about proving their idea is safe. When a highly competent engineer strongly disagrees with you, it is rarely because they are stubborn. It is usually because they see a catastrophic risk that you have ignored. Validate their fear, mitigate the risk in your design, and the disagreement will disappear. Question 17. Tell me about a difficult teammate. Note: Interviewers use this question to evaluate your emotional intelligence, conflict resolution skills, and ability to separate personal frustration from professional outcomes. This is a highly scrutinized culture fit signal at companies like Netflix and Google.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question as a trap to see if you will badmouth a colleague. Avoid these signals. 1. The venting session, using the interview to complain about a former colleague's personality or competence. 2. The unprofessional diagnosis, claiming the teammate was lazy, toxic, or stupid. This reflects poorly on your professionalism. 3. The avoidance tactic, saying you just ignored them, worked around them, or did their work for them to avoid conflict. 4. The non-technical conflict, telling a story about someone stealing your lunch from the fridge rather than a technical or process dispute. 5. The unresolved ending, telling a story where the relationship remained broken and toxic until one of you left the company.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 EQ signals. 1. Objective framing. Did the candidate describe the difficulty in terms of work styles, processes, or technical constraints rather than personality? 2. Direct communication. Did they address the issue with the teammate directly and privately? 3. Empathy. Did they attempt to understand the teammate's perspective or constraints? 4. Constructive action. Did they find a systemic or process-oriented compromise? 5. Relationship preservation. Did the interaction ultimately improve the working relationship? Strong candidates solve the interpersonal friction by fixing the underlying technical or process friction.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: I was tech leading a greenfield microservice project. One of the senior engineers on the team was extremely difficult during code reviews. He would leave dozens of pedantic comments about syntax and formatting, often blocking PRs for days and destroying our sprint velocity. Task: I needed to stop the PR bottleneck and improve the team's morale without alienating a highly knowledgeable engineer. Action: I scheduled a one-on-one with him. Instead of accusing him of being difficult, I approached it structurally. I said, "Your PR feedback is technically correct, but the asynchronous back and forth is killing our lead time. It seems we are relying on humans to enforce style." I proposed we automate his standards. We spent an afternoon configuring a strict linter, SonarQuebec rules, and a pre-commit hook that codified his exact formatting preferences. Result: by automating the style checks, his PR reviews shifted from formatting arguments to actual architectural discussions. Our PR merge time dropped from an average of 3 days to under 4 hours, and our working relationship improved dramatically. Learning +L. I learned that when an engineer is being difficult about a standard, it usually means the system is lacking an automated guardrail. You cannot fix human behavior by arguing. You fix it by pushing the friction into the CI/CD pipeline. The +L shows you transformed an interpersonal conflict into an automated engineering standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates extreme emotional and technical maturity. 1. Objective framing matched. You framed the difficulty as a PR bottleneck caused by manual style checks, not as the engineer being a jerk. 2. Direct communication matched. You took the issue offline into a private one-on-one. 3. Empathy matched. You validated that his technical feedback was actually correct, which disarmed his defensiveness. 4. Constructive action matched. You did not just ask him to stop. You built an automated linter together. 5. Relationship preservation matched. The relationship improved because you elevated his role from syntax checker to architecture reviewer. This demonstrates that you manage team dynamics through engineering solutions.
Follow-up 1. Clarification probe. What if the engineer had refused to help you configure the linter, saying that developers should just know better?
Answer: if he refused to collaborate on the automation, I would have configured the baseline linter myself. In the next sprint planning, I would have explicitly demonstrated to the team how the automated pipeline speeds up our workflow. Once a difficult engineer sees that the team has adopted a new standard and velocity is increasing, they usually adapt to the new process rather than fighting the tooling.
Follow-up 2. Level 3 or Level 4 junior depth. Setting up SonarQuebec and pre-commit hooks takes time away from feature work. How did you justify that effort?
Answer: I justified it using basic math. I showed our engineering manager that PRs were sitting in the in-review column for an average of 72 hours, largely due to syntax debates. Spending one day configuring a linter was an immediate ROI that paid for itself within the very next sprint by unblocking feature delivery.
Follow-up 3, Level 5 or Level 6 Senior Depth. What if his PR comments were not about syntax, but were constant, fundamental disagreements about your architecture design?
Answer: if the friction is architectural, it means we failed during the design phase. I would stop the PR reviews and mandate an architecture decision record adder review before any code is written. Difficult architectural arguments in PRs are a symptom of missing upfront alignment. By forcing the debate into the design document phase, we resolve the conflict before the code is authored.
Follow-up 4, Curveball. What if, even after automating the linter and doing design reviews, the engineer was just fundamentally toxic and hostile in meetings?
Answer: if an engineer is fundamentally hostile and degrades the psychological safety of the team, it ceases to be a peer-to-peer technical conflict and becomes an HR and management issue. I would meticulously document specific instances of hostile behavior, escalate the issue to our mutual manager, and request that the behavior be addressed formally. I will fix broken processes, but I cannot fix toxic personalities.
Leadership pro tip: elevate the conflict.
When asked about a difficult person, the best candidates elevate the narrative. Instead of telling a story about a personality clash, tell a story about a process failure that manifested as a personality clash. By fixing the underlying system, whether through automation, CI/CD, or better documentation, you prove that you are an architect who builds scalable environments where it is easy to collaborate. Question 18. Tell me about a time you had to work with someone very different from you. Note: interviewers use this question to evaluate your adaptability, cross-functional empathy, and ability to leverage cognitive diversity. This is a major collaboration signal evaluated at companies like Apple and Google, where you frequently collaborate across specialized domains.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out rigid or dogmatic candidates. Avoid these traps. 1. The culture clash trap, focusing on personal, cultural, or demographic differences instead of professional, technical, or working style differences. 2. The my way or the highway approach, forcing the other person to adapt entirely to your workflow because your way is the industry standard. 3. The secretly superior tone, describing the other person's working style as reckless, slow, or chaotic, implying you had to fix them. 4. The avoidance strategy, saying you simply divided the work perfectly in half so you never actually had to collaborate with them. 5. The zero learning ending, successfully finishing the project but failing to articulate what you actually learned from their unique perspective.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 collaboration signals. 1. Adaptability: did the candidate adjust their own communication and workflow to bridge the gap? 2. Cognitive empathy: did they recognize the valid business reasons behind the colleague's different approach? 3. Cross-functional synergy: did they combine their complementary strengths to produce a better result than either could alone? 4. Interface building: did they establish clear technical or process contracts to make collaboration seamless? 5. Systemic growth: did they institutionalize this cross-functional workflow for future teams? Strong candidates prove that diversity of thought is an engineering asset, not a bottleneck.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: we were integrating a new machine learning recommendation engine into our core checkout flow. I was the backend architecture lead, obsessed with strict CI/CD typing and sub 50 milliseconds latency. My counterpart was the lead data scientist, obsessed with model accuracy, rapid experimentation, and manual deployments via Python notebooks. Task: our working styles clashed immediately. He found my CI/CD requirements bureaucratic and slow. I found his manual deployments terrifying for production stability. I needed to bridge this gap to launch the feature safely. Action: instead of forcing him to learn Kubernetes and Terraform, I scheduled a pairing session to understand his workflow. I realized his priority was iteration speed. I proposed a compromise: we decoupled our domains. He would own the model training and output a standardized artifact to a model registry, ML flow. I would build an automated Go or gRPC inference wrapper that pulled his latest approved artifact and served it with strict latency and memory guardrails. Result, by letting him work in his preferred style and wrapping it in my preferred safety controls, we shipped the integration 2 weeks early. The model increased upsell revenue by 12%, and the Go wrapper kept our P99 latency strictly under 45 milliseconds. Learning plus L. I learned that forcing software engineering practices onto data scientists destroys their velocity. I later co-authored an ML Ops paved road RFC that standardized this artifact handoff pattern across the entire engineering organization. The plus L shows you turned a personal compromise into an organizational capability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite cross-functional leadership. 1. Adaptability matched. You did not force the data scientist to become a DevOps engineer. You adapted the pipeline to fit his output. 2. Cognitive empathy matched. You shadowed him to understand why he valued iteration speed over deployment rigor. 3. Cross-functional synergy matched. You combined his ML accuracy with your distributed systems reliability. 4. Interface building matched. You established a clean API and registry boundary so both of you could work asynchronously. 5. Systemic growth matched. The plus L step translated this successful collaboration into a company-wide ML Ops standard. This demonstrates you can unite entirely different engineering disciplines to drive business value.
Follow-up 1. Clarification probe. How did you handle the initial friction before you reached the compromise? Did it get heated?
Answer: there was definite tension in our early Slack messages, mostly stemming from mutual misunderstanding. I stopped the text-based back and forth immediately and asked to grab coffee. I explicitly said, I think we are optimizing for 2 different, equally important things. Can you walk me through your ideal deployment flow? Disarming the tension by validating his goals changed the dynamic instantly.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure that his new models would not break your Go wrapper if he changed the data inputs?
Answer: we agreed on a strict protobuf API contract. Even though he was writing Python and I was writing Go, the protobuf definition acted as the source of truth. If his new model artifact required different input tensors, his automated tests against the protobuf schema would fail before it ever reached my inference wrapper.
Follow-up 3. Level 5 or Level 6 senior depth. What if the data scientist had refused the ML flow registry idea and insisted on deploying his raw scripts directly to the production servers to save time?
Answer: at that point, it transitions from a workflow difference to an unacceptable operational risk. I would firmly draw a hard boundary. I would explain that direct production access violates our SOC 2 compliance and poses an existential risk to checkout uptime. If he remained insistent, I would escalate the risk to our mutual director, presenting my proposed paved road as the required compromise to satisfy both his speed and the company's compliance.
Follow-up 4. Curveball. What if, after all this collaboration, the model goes live and causes a massive 500 milliseconds latency spike that starts failing customer checkouts?
Answer: I would not point fingers or blame the data scientist's model. As the architect of the inference wrapper, protecting the core checkout flow is my responsibility. I would immediately trigger my pre-built circuit breaker, falling back to a static, cached list of recommendations to restore sub-50 milliseconds latency. Once the bleeding was stopped, we would investigate the inference bottleneck together as a unified team.
Leadership pro tip. Build APIs for people.
Elite architects know that coupling is not just a software problem. It is an organizational problem. When working with people who are radically different from you, do not try to change how they operate. Instead, define a clear interface or contract between your workflows. If you decouple your working styles using clear boundaries, diversity of thought becomes your greatest asset. Question 19. Describe a situation where collaboration failed and how you handled it. Note, this question is interesting because it tests your ability to objectively diagnose organizational failures, rebuild broken trust, and implement processes to prevent future misalignment. This is a critical evaluation of earned trust and dive deep at companies like Amazon and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to see if you take accountability or play the victim when teams clash. Avoid these traps. 1. The blame game, blaming the failure entirely on the other team's incompetence, laziness, or poor leadership. 2. The hero complex, claiming you fixed the failed collaboration by just doing the other team's work for them. 3. The process bureaucrat, trying to fix poor communication by adding 5 new mandatory standing meetings, which just drains velocity. 4. The toxic gossip, venting about the failure without demonstrating how you actively intervene to repair the relationship. 5. The surface patch, fixing the immediate code bug but ignoring the root reason the two teams failed to communicate in the first place.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 collaboration signals. 1. Blameless accountability. Did the candidate own their part in the failure rather than pointing fingers? 2. Root cause analysis. Did they look past the symptoms to find the systemic communication breakdown? 3. De-escalation. Could they reset the relationship, diffuse tension, and rebuild trust? 4. Systems thinking. Did they introduce a technical solution to solve the human misalignment? 5. Systemic alignment. Did they successfully establish a new organizational standard to prevent recurrence? Strong candidates recognize that failed collaboration is usually a symptom of missing engineering contracts.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: my backend team and a client UI team were building a real-time analytics dashboard. 2 weeks before launch, we attempted our first end-to-end integration and it failed catastrophically. The data structures did not match and both teams blamed each other for changing the requirements mid-flight. Task: the finger pointing was turning toxic. I needed to halt the escalation, unblock the integration, and salvage our launch date. Action: I called a joint reset meeting and explicitly stated, this is a failure of our integration process, not a failure of either team, and I own my part in that. I proposed we halt feature development for 48 hours to jointly write a strict open API specification. I then set up a mock server using this spec, so the UI team could immediately resume work while we adapted the backend. Result: by de-escalating the emotion and providing a mock server, trust was restored. We successfully integrated the systems in 3 days and launched the dashboard on time with 0 P1 bugs. Learning plus L. I learned that relying on wiki pages for cross-team collaboration guarantees failure. I later championed contract-driven development across the engineering org, mandating that machine-readable API schemas be written, reviewed, and merged before any implementation code is authored. The +L translates a painful team failure into a company-wide engineering standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite conflict resolution. 1. Blameless accountability matched. You stop the finger pointing by absorbing the blame into a process failure. 2. Root cause analysis matched. You recognize the issue was not bad coding but drifting assumptions. 3. De-escalation matched. You called a joint reset meeting and validated both teams' frustrations. 4. Systems thinking matched. You used a mock server and an open API spec to permanently bridge the gap. 5. Systemic alignment matched. The +L step embedded contract-driven development into the company culture. This demonstrates that you fix broken teams using engineering leadership.
Follow-up 1, clarification probe. How did you convince the other team to pause feature development for 48 hours, so close to a major deadline?
Answer: I used the sunk cost reality. I showed them that continuing to code against mismatched assumptions would guarantee a missed deadline. I framed the 48-hour pause not as a delay, but as the only mathematical path to launching on time. Once they saw the mock server would unblock them immediately after the pause, they agreed.
Follow-up 2, Level 3 or Level 4 junior depth. Why do you think the requirements drifted so far apart in the first place?
Answer: we made the classic mistake of relying on an asynchronous Confluence document. As edge cases arose during sprints, each team updated their own internal Jira tickets and made local assumptions without updating the central wiki. Without a machine-readable, version-controlled contract, Human memory and siloed documentation will always drift.
Follow-up 3, Level 5 or Level 6 senior depth. What if the other team's tech lead was extremely defensive and refused to accept the new open API process, claiming it was too much overhead?
Answer: I would de-escalate by validating their concern about overhead, then shift the focus to time to market. I would offer to do the heavy lifting. Let me write the first draft of the open API spec and set up the mock server. If it does not save your team time by Friday, we will revert. By absorbing the initial friction, I prove the value of the process without forcing them to take on the initial setup cost.
Follow-up 4, Curveball. What if, despite your intervention, the integration still failed and you missed the launch date? How would you handle the fallout with leadership?
Answer: I would own the failure completely. In the executive review, I would present a blameless post-mortem. I would say, we missed the deadline because we discovered the integration gap too late. The root cause was our lack of API contracts. We have now instituted contract-driven development to ensure this class of failure never happens again. Leadership respects engineers who extract systemic value from expensive failures.
Leadership pro tip: code fixes code, process fixes people.
When collaboration fails, it is rarely because engineers are malicious or incompetent. It is almost always because the system allowed them to operate on misaligned assumptions. Elite architects do not try to make people communicate better. They introduce technical constraints, like API schemas and automated mocks, that make misalignment mathematically impossible. Question 20. Tell me about a time when communication broke down on your team. Note: interviewers use this question to evaluate whether you can detect misalignment early, restore clarity between engineering stakeholders, and introduce mechanisms that prevent future failures. This is a core leadership signal tied to dive deep and earn trust at companies like Amazon and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out engineers who treat communication failures as someone else's problem. Avoid these traps. 1. The blame the PM story, claiming the failure happened because product or design gave unclear requirements. 2. The hidden in Slack excuse, saying the information existed somewhere in Slack threads or Jira tickets but people simply missed it. 3. The silent engineer, continuing to implement features despite noticing conflicting assumptions between teams. 4. The meeting explosion, fixing the issue by adding more status meetings instead of clarifying technical contracts. 5. The temporary patch, solving the integration bug but failing to address the systemic communication breakdown that caused it.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer is evaluating these 5 engineering leadership signals. 1. Early detection: did the candidate recognize the communication breakdown before it caused a major production failure? 2. Ownership: did they step in to restore alignment rather than waiting for management to intervene? 3. Technical artifacts: did they introduce durable communication mechanisms like design docs, RFC, or API schemas? 4. Risk mitigation: did they adjust the system design to reduce ambiguity between teams? 5. Systemic improvement: did they create a long-term process to prevent similar communication failures? Strong candidates fix communication failures with engineering structure.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: my team was building a high-volume notification platform responsible for sending real-time alerts across several internal services. 2 weeks before launch, our load testing revealed massive request spikes that were overwhelming downstream APIs owned by another team. Task: the backend team assumed the downstream service could handle burst traffic, while the receiving team assumed we would implement strict rate limits. This communication gap created a serious risk of cascading failures during peak events. Action: I halted feature development and organized a technical alignment session between both teams. Instead of debating assumptions, I created a short RFC documenting our expected throughput, up to 50,000 notifications per minute, and shared Datadog load testing dashboards showing burst patterns. The data made it clear that neither system could safely handle the load without buffering. We jointly redesigned the architecture to introduce a Kafka event buffer and implemented token bucket rate limiting enforced at the API gateway. Result: the new architecture absorbed traffic spikes smoothly. During launch week, the system processed over 30 million notifications without any downstream service degradation, and alert delivery latency remained under 200 milliseconds at P95. Learning plus L. The root cause was relying on verbal assumptions rather than explicit contracts. After the project, I introduced a mandatory cross-team interface RFC process requiring throughput expectations, rate limits, and failure modes to be documented and reviewed before implementation. The plus L demonstrates that you converted a communication failure into a durable engineering process.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite engineering leadership. 1. Early detection matched, load testing revealed the communication gap before it caused a production outage. 2. Ownership matched, you paused development and created a structured alignment process. 3. Technical artifacts matched, the RFC and observability dashboards provided objective evidence for the design decision. 4. Risk mitigation matched, Kafka buffering and rate limiting protected downstream services during traffic spikes. 5. Systemic improvement matched, the plus L step introduced a cross-team interface RFC to prevent future misalignment. This demonstrates that you resolve communication failures with engineering discipline.
Follow-up 1. Clarification probe. Why did not the teams discover the throughput mismatch earlier in the project?
Answer: the teams had separate design documents and assumed the other group had validated scalability requirements. Because there was no shared architecture review between services, those assumptions were never explicitly verified. The cross-team interface RFC solved that by forcing joint review before implementation.
Follow-up 2. Level 3 or Level 4 junior depth. Why did you choose Kafka buffering instead of simply throttling requests at the gateway?
Answer: gateway throttling would have dropped notifications during traffic spikes, which was unacceptable for critical alerts. Kafka allowed us to absorb bursts and process them steadily, preserving reliability while protecting downstream services.
Follow-up 3. Level 5 or Level 6 senior depth. What if the downstream team still disagreed with your architecture proposal?
Answer: if alignment could not be reached technically, I would escalate the decision to our architecture review board with clear data, load test results, throughput projections, and operational risk. The board would decide based on business priorities, and once the decision was made, we would execute it fully.
Follow-up 4. Curveball. What if the Kafka buffer itself became a bottleneck during peak traffic?
Answer: that possibility was part of the design review. We configured partition scaling and consumer auto-scaling policies based on throughput thresholds observed in load testing. If Kafka lag exceeded a predefined SLO, our auto-scaling pipeline would provision additional consumers automatically.
Leadership pro tip. Communication requires contracts.
In complex systems, communication failures usually happen because assumptions remain implicit. Senior engineers replace assumptions with contracts through API schemas, RFC, and architecture reviews. These artifacts transform fragile conversations into durable alignment across teams. Question 21. Tell me about a time you worked with a cross-functional team, product, design, or marketing. Note: interviewers use this question to evaluate whether you can translate technical constraints into business decisions while collaborating with non-engineering disciplines. This leadership signal reflects the ability to bridge engineering execution with product strategy, which is heavily evaluated at companies like Google and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out engineers who struggle to collaborate outside engineering. Avoid these traps. 1. The engineering knows best attitude, dismissing product or design input as unrealistic without explaining the technical constraints. 2. The translator failure, using heavy technical jargon that non-engineers cannot understand. 3. The passive builder, simply implementing whatever product asks for without raising architectural or scalability concerns. 4. The blame product story, claiming the project failed because the product team changed requirements. 5. The feature factory, treating engineering as a ticket execution machine instead of contributing to product strategy.
Here are the signals the interviewer is scoring.
While you answer this question, The interviewer is evaluating these 5 cross-functional leadership signals. 1. Technical translation. Can the candidate clearly explain engineering constraints to non-engineers? 2. Product empathy. Do they understand the business goals behind product or marketing requests? 3. Trade-off judgment. Can they balance customer experience with system reliability and scalability? 4. Collaborative problem solving. Do they work with other disciplines to find a feasible solution? 5. Organizational impact. Did the candidate improve the collaboration process for future projects? Strong candidates elevate engineering from implementation to strategic partnership.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our company was launching a major marketing campaign that required a new real-time recommendation widget on the homepage. The product and marketing teams wanted dynamic personalized recommendations refreshed every page load. Task: from an engineering perspective, generating recommendations on every request would create extreme load on our recommendation service and database, potentially increasing homepage latency beyond our 150 milliseconds SLO. Action: I partnered with product and marketing to analyze the user experience they were targeting. Using our observability dashboards and load testing data, I demonstrated that generating recommendations per request would increase backend load by nearly 8 times. Instead of rejecting the idea, I proposed a compromise architecture. We pre-computed personalized recommendation sets every 15 minutes using a batch pipeline, cached them in Redis, and served them instantly at request time. Result: this hybrid design preserved the personalized experience while keeping homepage latency under 90 milliseconds. The marketing campaign launched successfully and increased click-through rates on recommended items by 18%. Learning plus L. I realized cross-functional projects often fail because technical constraints are discovered too late. After this project, I introduced a lightweight engineering feasibility review during early product planning, so engineering constraints could shape product design before implementation began. The +L demonstrates that strong engineers improve the collaboration process, not just the system.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong cross-functional collaboration. 1. Technical translation matched. You explain latency constraints using real observability data. 2. Product empathy matched. You focused on the user experience marketing wanted to deliver. 3. Trade-off judgment matched. You balanced personalization quality with system scalability. 4. Collaborative problem solving matched. Instead of rejecting the request, you designed a hybrid architecture. 5. Organizational impact matched. The feasibility review process improved future product engineering collaboration. This demonstrates engineering leadership that aligns technology with business goals.
Follow-up 1. Clarification probe. Why did you choose a 15-minute batch refresh instead of real-time streaming updates?
Answer: our analysis showed that user preferences did not change meaningfully within short windows. A 15-minute refresh allowed us to maintain near real-time relevance while dramatically reducing computational load on the recommendation service.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the Redis cache did not become a single point of failure?
Answer: we used a sharded Redis cluster with replication and implemented fallback logic in the application layer. If the cache became unavailable, the service would gracefully degrade to a static recommendation list instead of failing the homepage request.
Follow-up 3. Level 5 or Level 6 senior depth. What if marketing insisted on real-time recommendations despite the latency risks?
Answer: if product requirements directly conflicted with reliability constraints, I would present the trade-off explicitly. Real-time recommendations would increase homepage latency beyond our SLO and risk degraded user experience. With that data, leadership could decide whether the business value justified the risk.
Follow-up 4. Curveball. What if the caching strategy caused stale recommendations during a viral marketing spike?
Answer: the system included a cache invalidation mechanism triggered by major behavioral events such as purchases or trending items. This allowed us to refresh affected recommendation segments quickly while keeping the majority of traffic served from cache.
Leadership pro tip. Engineers must speak business.
In cross-functional teams, technical excellence alone is not enough. Senior engineers translate system constraints into business trade-offs that product and marketing leaders can understand. When engineering decisions are framed in terms of user experience, latency, and business impact, collaboration becomes significantly easier. Question 22. Tell me about a time you collaborated with a non-technical stakeholder. Note: interviewers use this question to evaluate whether you can translate complex technical constraints into clear business decisions while maintaining system reliability. This tests your ability to influence product or business stakeholders without relying on technical jargon, a collaboration signal heavily evaluated at companies like Google and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out engineers who cannot effectively collaborate outside engineering. Avoid these traps. 1. The technical wall, overwhelming the stakeholder with jargon about microservices, queues, and latency budgets instead of explaining the real business risk. 2. The ticket machine, treating the stakeholder's request as a simple task and implementing it without discussing scalability or reliability implications. 3. The engineering arrogance, dismissing the stakeholder's idea as unrealistic without understanding the underlying business objective. 4. The late discovery, agreeing to the request initially and only raising technical concerns once the project is already underway. 5. The no influence, describing a situation where you simply executed what was asked without shaping the decision.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 collaboration signals. 1. Business understanding. Did the candidate first understand the stakeholder's actual business goal? 2. Technical translation. Could they explain system limitations using language the stakeholder understands? 3. Trade-off judgment. Did they clearly present options balancing business value and technical risk? 4. Influence without authority. Were they able to guide the stakeholder toward a technically sound solution? 5. Organizational learning. Did the candidate introduce a process improvement for future cross-functional decisions? Strong engineers do not block business goals. They reshape them into technically viable solutions.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our marketing team wanted to launch a large promotional campaign that would send push notifications to every user simultaneously at a specific time. The idea was to create a sense of urgency for a limited-time sale. Task: from an engineering perspective, sending millions of notifications instantly would create a traffic spike, capable of overwhelming our notification service and downstream mobile gateways. Action: instead of rejecting the idea, I met with the marketing lead to understand the business objective. Their real goal was ensuring most users saw the notification within a short window. I used our Datadog dashboards and previous campaign metrics to demonstrate that an immediate broadcast would likely create a 4 times traffic spike and risk delivery failures. I proposed a rolling delivery strategy where notifications were distributed over a 10-minute window using Kafka queues and rate-limited workers. Result: the campaign successfully delivered notifications to 98% of active users within the 10-minute window while maintaining system stability. Engagement during the campaign increased click-through rates by 22% without any service degradation. Learning plus L. The incident highlighted the importance of aligning technical feasibility with business initiatives early. After the project, I introduced a campaign technical review checklist requiring engineering input before any large-scale marketing launch. The +L shows that you improve the collaboration process between engineering and business teams.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong cross-functional leadership. 1. Business understanding matched. You first clarified the marketing goal rather than rejecting the request. 2. Technical translation matched. You used real observability metrics instead of engineering jargon to explain the system risk. 3. Trade-off judgment matched. You proposed a rolling notification strategy that balanced marketing urgency with system stability. 4. Influence without authority matched. The stakeholder adopted the alternative approach because the data made the trade-off clear. 5. Organizational learning matched. The campaign technical review process prevented future large-scale launch risks. This demonstrates that senior engineers align engineering systems with business outcomes.
Follow-up 1, clarification probe. Why was a 10-minute window acceptable for the marketing campaign?
Answer: user engagement analysis showed that most promotional notifications were opened within several minutes regardless of delivery time. Delivering within a 10-minute window preserved the urgency while significantly reducing infrastructure risk.
Follow-up 2, Level 3 or Level 4 junior depth. How did you ensure the notification workers could scale during the campaign?
Answer: we configured auto-scaling based on queue depth metrics. If the Kafka queue backlog increased beyond a predefined threshold, additional worker instances were automatically provisioned to maintain the delivery rate.
Follow-up 3, Level 5 or Level 6 senior depth. What if the marketing team insisted on instant delivery despite the risk?
Answer: if the business decision still favored instant delivery, I would clearly document the operational risks and propose mitigation strategies such as temporary infrastructure scaling and throttling safeguards. Ultimately, leadership must make the trade-off decision, but engineering ensures the risks are visible and managed.
Follow-up 4, curveball. What if the rolling delivery caused some users to receive the promotion too late and complain?
Answer: the campaign design included real-time monitoring of delivery latency and user engagement. If we saw delays beyond acceptable thresholds, we could temporarily increase worker capacity to accelerate delivery while still maintaining safe system load.
Leadership pro tip. Translate technology into business risk.
Non-technical stakeholders do not think in terms of queues, latency budgets, or throughput limits. Effective engineers translate those concepts into business outcomes such as user experience, reliability, and revenue risk. When you frame engineering constraints in business terms, cross-functional decisions become much easier. Question 23. Describe working with a distributed or remote team across time zones. Note: interviewers use this question to evaluate your ability to maintain engineering velocity and alignment when teams are geographically distributed. This tests whether you can design communication systems, not just participate in meetings. The signal maps strongly to earn trust and ownership at companies like Amazon and Google.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect engineers who struggle in distributed environments. Avoid these traps. 1. The meeting dependency, relying entirely on synchronous meetings to make decisions, which becomes impossible across time zones. 2. The slow handoff, waiting a full day for answers instead of designing workflows that allow teams to work asynchronously. 3. The time zone blame, complaining that the other team was slow or difficult due to location differences. 4. The chat chaos, using scattered Slack threads instead of structured artifacts for decision-making. 5. The local optimization, solving problems only within your team's hours rather than optimizing for global collaboration.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 distributed team leadership signals. 1. Asynchronous leadership. Did the candidate design workflows that allow progress without real-time meetings? 2. Clear technical contracts. Did they introduce artifacts such as API schemas, design docs, or RFCs to reduce ambiguity? 3. Operational discipline. Did they ensure deployments and releases could be executed safely across time zones? 4. Velocity optimization. Did their system reduce idle time between teams? 5. Organizational impact. Did the candidate introduce a distributed workflow that improved collaboration for the entire organization? Strong engineers build systems where time zones stop being a bottleneck.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our platform team in the United States was responsible for core backend services, while a front-end team in India owned the user-facing dashboard. We were integrating a new analytics API, but development stalled because each team needed clarifications from the other, causing 24-hour delays between iterations. Task: the slow feedback loop threatened the project timeline, and the teams were becoming frustrated with the constant waiting between questions and answers. Action: I realized the core problem was that our integration relied on conversational clarification instead of clear technical contracts. I proposed we adopt a contract-driven development approach. I authored an open API specification describing every endpoint, request schema, and response payload. I also generated a mock server from the spec so the front-end team could develop and test their integration independently. Result: the new workflow eliminated the daily dependency loop. The front-end team could build against the mock API while our back-end team implemented the service. This reduced cross-time zone blocking delays and allowed the feature to launch 2 weeks ahead of the revised schedule. Learning plus L. The project showed that distributed teams require stronger interface contracts than CO-located teams. After the launch, I introduced a guideline requiring machine-readable API schemas and mock servers for all cross-team integrations. The +L demonstrates that you optimize the engineering workflow for global teams.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong distributed team leadership. 1. Asynchronous leadership matched. The API contract allowed teams to progress without waiting for real-time discussions. 2. Clear technical contracts matched. The open API specification removed ambiguity in the integration process. 3. Operational discipline matched. The mock server ensured both teams could test integration safely. 4. Velocity optimization matched. Eliminating the 24-hour feedback cycle significantly accelerated development. 5. Organizational impact matched. The API contract standard improved future cross-team integrations. This demonstrates leadership through engineering process design.
Follow-up 1. Clarification probe. Why did the teams rely on conversation instead of an API contract initially?
Answer: the integration began quickly without a formal design phase. As edge cases appeared, both teams started making assumptions about the API behavior. Without a shared contract, those assumptions diverged.
Follow-up 2. Level 3 or Level 4 junior depth. How did the mock server improve the front-end team's workflow?
Answer: the mock server allowed the front-end team to simulate back-end responses before the actual service existed. This meant they could develop UI logic and error handling without waiting for the back-end implementation.
Follow-up 3. Level 5 or Level 6 senior depth. What if the back-end implementation diverged from the API specification later?
Answer: we integrated contract validation into the CI pipeline. Backend tests automatically verified that the implementation matched the open API specification, preventing drift between teams.
Follow-up 4. Curveball. What if the distributed team still struggled despite the API contract?
Answer: if issues persisted, I would introduce structured async updates such as daily engineering summaries and design review recordings, so each region could review decisions during their working hours without blocking progress.
Leadership pro tip. Design for asynchronous work.
Distributed engineering teams cannot rely on real-time conversation. Senior engineers design workflows that allow teams to work independently through clear contracts, documentation, and automated validation. When done correctly, time zone differences become an advantage rather than a bottleneck. Question 24. Tell me about a time when you had to align multiple teams with different priorities. Note: interviewers use this question to evaluate whether you can resolve organizational misalignment when several teams have competing goals. Senior engineers are expected to align technical execution with product and operational priorities across teams. This leadership signal is strongly evaluated at companies like Amazon and Meta under principles such as ownership and earned trust.
Here are the critical red flags. The instant rejection signals.
Interviewers use this question to identify candidates who struggle with organizational complexity. Avoid these traps. 1. The manager escalation, immediately escalating the disagreement to leadership instead of attempting alignment first. 2. The my team first mentality, optimizing only for your team's deliverables while ignoring system-wide impact. 3. The endless meetings fix, trying to solve misalignment by scheduling more meetings rather than clarifying the decision framework. 4. The technical tunnel vision, focusing only on engineering concerns without acknowledging product or operational priorities. 5. The temporary compromise, achieving short-term alignment but leaving the structural conflict unresolved.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Systems perspective. Did the candidate understand the priorities and constraints of each team? 2. Decision framing. Did they structure the discussion around clear trade-offs instead of opinions? 3. Data-driven alignment. Did they use metrics or evidence to guide the decision? 4. Collaborative influence. Were they able to guide teams toward a shared solution without authority? 5. Organizational improvement. Did the candidate introduce a process or artifact that prevented future misalignment? Strong engineers align teams by clarifying system-level goals.
Here is the FAANG-level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our company planned to launch a new checkout feature during a major holiday promotion. The product team prioritized rapid feature delivery to meet the campaign deadline, while the infrastructure team was concerned that the new checkout logic would increase database load during peak traffic. Task: my responsibility was to align both teams so we could deliver the feature without risking checkout outages during the promotion. Action: instead of letting the discussion turn into a debate between speed and stability, I reframed the conversation using production metrics. I pulled Datadog dashboards from previous holiday traffic spikes and showed that our checkout database already reached 70% CPU utilization during peak hours. I then ran a load test using our staging environment that simulated the new feature's query pattern. The results showed the feature could increase peak load by nearly 35%. Based on this data, I proposed a compromise. We would ship the feature behind a feature flag and gradually roll it out while monitoring system load. Result: both teams agreed on the phased rollout approach. The feature launched successfully during the promotion, and gradual traffic ramp-up ensured the database remained stable. The campaign generated a 15% increase in checkout conversions without any service disruption. Learning plus L. The alignment challenge revealed that major launches often lack shared technical visibility. After the project, I introduced a launch readiness review process that required cross-team load testing and capacity planning before any high-traffic feature release. The +L shows that you transformed a one-time alignment challenge into an organizational launch standard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong cross-team leadership. 1. Systems perspective matched. You acknowledged both the product deadline and infrastructure stability concerns. 2. Decision framing matched. The conversation was reframed as a trade-off between delivery speed and system reliability. 3. Data-driven alignment matched. Load testing and observability data replaced opinion-based arguments. 4. Collaborative influence matched. The phased rollout approach satisfied both teams without escalation. 5. Organizational improvement matched. The launch readiness review process improved future cross-team coordination. This demonstrates leadership that aligns engineering execution with business goals.
Follow-up 1. Clarification probe. Why did the teams initially disagree about the feature launch?
Answer: each team was optimizing for different goals. Product focused on delivering the feature quickly for the marketing campaign, while the infrastructure team focused on maintaining system reliability during peak traffic.
Follow-up 2. Level 3 or Level 4 junior depth. How did the feature flag help mitigate the risk?
Answer: feature flags allowed us to gradually enable the new functionality for a small percentage of users first. This allowed us to observe real production metrics before fully enabling the feature.
Follow-up 3. Level 5 or Level 6 senior depth. What if the load test results had shown even higher risk?
Answer: if the results showed unacceptable risk, I would recommend delaying the feature launch or redesigning the implementation to reduce database load. Protecting system stability must take priority over feature timelines.
Follow-up 4. Curveball. What if leadership insisted on launching the feature immediately despite the risks?
Answer: in that case, I would clearly document the risks and prepare mitigation strategies such as traffic throttling and database read replicas. Engineering's responsibility is to ensure leadership understands the trade-offs and that safeguards are in place.
Leadership pro tip. Align teams around data.
When teams disagree, the debate often becomes emotional or opinion-driven. Senior engineers shift the conversation to objective evidence such as system metrics, load tests, and operational data. Data creates a shared reality that allows teams with different priorities to align around the same decision. Question 25. Describe a time you worked on a diverse team and how you ensured inclusivity. Note, interviewers use this question to evaluate whether you can build psychologically safe engineering environments where people with different backgrounds, experience levels, and technical perspectives can contribute effectively. This is an increasingly important leadership signal, evaluated at companies like Google and Meta, where diverse teams collaborate across functions and regions.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who misunderstand inclusivity in engineering teams. Avoid these traps. 1. The surface diversity story, focusing only on demographic differences without addressing how collaboration actually worked. 2. The hero narrative, claiming you single-handedly created inclusivity without acknowledging team contributions. 3. The silence problem, ignoring situations where junior or remote team members were not participating in technical discussions. 4. The token participation, allowing diverse team members to attend meetings but not actively contribute to decisions. 5. The no structural change, describing a positive team environment but failing to introduce processes that support inclusive collaboration.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 inclusive leadership signals. 1. Psychological safety. Did the candidate create an environment where engineers felt comfortable sharing ideas and concerns? 2. Participation balance. Did they ensure quieter or junior engineers had opportunities to contribute? 3. Communication accessibility. Did they structure communication so remote or non-native speakers could participate effectively? 4. Decision transparency, were technical decisions documented so everyone understood the reasoning? 5. Organizational improvement. Did the candidate introduce processes that improved inclusive collaboration across the team? Strong engineers build environments where diverse perspectives improve system design.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: I was leading a back-end infrastructure project involving engineers across 3 regions, the United States, Europe, and India. The team included senior distributed systems engineers as well as several newer engineers who had recently joined the company. Task: during early architecture discussions, I noticed that the same 2 senior engineers dominated design meetings, while several remote engineers rarely contributed, even though they were responsible for major parts of the implementation. Action: to make discussions more inclusive, I introduced 2 structural changes. First, we required architecture proposals to be written as RFC documents before meetings. This allowed team members across time zones to review and comment asynchronously. Second, during design reviews, I implemented a round-robin discussion format, so each service owner had an opportunity to raise concerns before decisions were finalized. Result: the changes significantly improved participation across the team. One engineer from our European team identified a potential data consistency issue in the caching layer that the rest of us had overlooked. Fixing that issue early prevented a class of race conditions that could have caused intermittent checkout failures. Learning plus L. The experience reinforced that inclusive engineering environments require structural support. After this project, I standardized asynchronous RFC reviews and documented design decisions in architecture decision records so all engineers could contribute regardless of location or seniority. The +L demonstrates that inclusive collaboration improves technical outcomes, not just team culture.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates inclusive engineering leadership. 1. Psychological safety matched. The structured discussion format encouraged quieter engineers to share concerns. 2. Participation balance matched. Round-robin design reviews ensured all service owners contributed to the discussion. 3. Communication accessibility matched. RFC documents allowed engineers across time zones to review proposals asynchronously. 4. Decision transparency matched. Architecture decision records documented the reasoning behind design choices. 5. Organizational improvement matched. The inclusive design review process became a standard workflow for future projects. This demonstrates that inclusive teams produce stronger engineering outcomes.
Follow-up 1, clarification probe. Why do written RFCs improve inclusivity compared to purely verbal design discussions?
Answer: written RFCs give engineers time to review ideas carefully and formulate responses, which is especially helpful for remote team members or engineers who may not be comfortable interrupting discussions during live meetings.
Follow-up 2, Level 3 or Level 4 junior depth. How did you ensure that RFC discussions did not slow down development?
Answer: we used lightweight templates and strict review timelines so RFCs could be reviewed within a few days. This maintained velocity while still ensuring alignment across the team.
Follow-up 3, Level 5 or Level 6 senior depth. What if senior engineers resisted the structured discussion format?
Answer: if senior engineers preferred open discussion, I would explain that the structure was designed to capture more perspectives and reduce blind spots in system design. In practice, once they saw how the process surfaced important issues earlier, most engineers supported the approach.
Follow-up 4, curveball. What if an engineer still remained silent during discussions despite these changes?
Answer: in that case, I would follow up individually to understand whether the barrier was technical uncertainty, communication style, or time zone constraints. Addressing those issues directly helps ensure everyone can contribute effectively.
Leadership pro tip. Inclusivity improves system design.
Diverse engineering teams bring different experiences and problem-solving approaches. Inclusive processes such as written design proposals, asynchronous reviews, and structured discussions ensure those perspectives are captured. In complex systems, more perspectives often lead to more resilient architectures.
Category 2 wrap-up. The art of architectural alignment.
You have now mastered the collaboration and teamwork category. You understand that senior engineering is not just about the code, it is about the people writing the code. You have learned how to de-escalate technical friction, manage difficult stakeholders, and build cross-functional bridges. You are no longer just a contributor. You are an organizational sync mechanism.
Transition, scaling information flow.
Alignment creates the what and the who, but communication defines the how. As systems grow in complexity, the most dangerous bottleneck in an organization is rarely the CPU. It is the human communication layer. This brings us to Category 3, communication skills, where we move from team dynamics to the precise art of high-stakes information delivery.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google Caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
the Google SRE interview bundle covers
1. recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Question 26. Describe a time you had to explain a complex technical concept to a non-expert. Note: interviewers ask this question to evaluate your ability to translate deep technical complexity into clear business understanding. Senior engineers must communicate architectural risks and system behavior to product managers, executives, or customers who may not have engineering backgrounds. This signal is strongly evaluated at companies like Amazon and Google, where engineers influence decisions across disciplines.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify engineers who struggle to communicate outside technical circles. Avoid these traps. 1. The jargon dump, explaining the concept using technical terms like distributed consensus, container orchestration, or message queues without simplifying the idea. 2. The talking down tone, explaining the concept in a condescending way that makes the stakeholder feel uninformed. 3. The oversimplification, removing so much technical detail that the stakeholder cannot make an informed decision. 4. The no decision context, explaining the technology but failing to connect it to the actual business decision being made. 5. The slide reader, simply presenting diagrams without ensuring the stakeholder truly understands the implications.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 communication signals. 1. Audience awareness. Did the candidate adapt the explanation to the stakeholder's level of expertise? 2. Conceptual clarity. Did they simplify the concept without losing the essential engineering truth? 3. Decision framing. Did they connect the technical explanation to a business decision? 4. Use of evidence. Did they support the explanation with data, diagrams, or real system metrics? 5. Organizational influence. Did the explanation enable the stakeholder to make a better decision? Strong engineers translate technical complexity into business clarity.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our platform team proposed migrating our monolithic backend to a microservices architecture to improve scalability and deployment velocity. However, the executive product leadership team was concerned that the migration would slow feature development. Task: my responsibility was to explain the scalability risks of continuing with the monolith and justify the architectural investment in a way that non-engineering leadership could understand. Action: instead of discussing service meshes or container orchestration, I framed the problem using real production metrics. I showed Datadog dashboards illustrating that our checkout service CPU usage was reaching 85% during peak events. I explained that the monolith forced every feature team to deploy together, creating deployment bottlenecks and increasing incident risk. Using a simple diagram, I compared it to a single highway handling all traffic versus multiple parallel roads handling independent workloads. Result: the leadership team clearly understood the operational risk. They approved a phased migration plan starting with the checkout and payment services. Within 6 months, independent service deployments increased our release frequency from once per week to several times per day. Learning plus L. The discussion revealed that architecture proposals often fail because stakeholders cannot visualize system constraints. After this project, I introduced a standard architecture review deck format that translates system metrics into business impact for executive stakeholders. The plus L shows you improved how technical architecture decisions are communicated across the organization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates elite technical communication. 1. Audience awareness matched. You avoided deep infrastructure jargon when explaining microservices. 2. Conceptual clarity matched. The highway analogy made system scalability understandable. 3. Decision framing matched. You connected the architecture discussion directly to deployment velocity and reliability. 4. Use of evidence matched. Datadog production metrics grounded the discussion in real data. 5. Organizational influence matched. The explanation enabled leadership to confidently approve the migration. This demonstrates that senior engineers influence decisions through clear communication.
Follow-up 1. Clarification probe. Why were executives initially hesitant about the migration?
Answer: from their perspective, the monolith already worked, and the migration sounded like a risky engineering project that might slow product development. Explaining the operational bottlenecks and deployment risks helped them understand the long-term cost of doing nothing.
Follow-up 2. Level 3 or Level 4 junior depth. How did you estimate the scalability limits of the monolith?
Answer: we analyzed CPU usage, request latency, and database load during peak traffic events using Datadog dashboards. These metrics showed that the checkout component was approaching infrastructure limits even during normal growth.
Follow-up 3. Level 5 or Level 6 senior depth. What if leadership had rejected the migration proposal despite the evidence?
Answer: if leadership still preferred the monolith, I would propose incremental risk mitigation, such as isolating the most heavily loaded services behind internal APIs. This approach would reduce operational risk while gradually preparing the system for a full migration.
Follow-up 4. Curveball. What if the microservices migration later introduced operational complexity?
Answer: that risk was part of the design discussion. We introduced automated service templates, centralized observability, and standardized CI/CD pipelines, so each new service followed the same operational patterns.
Leadership pro tip. Translate systems into stories.
When explaining complex systems to non-engineers, avoid technical vocabulary and focus on operational outcomes. The goal is not to teach distributed systems theory, but to help stakeholders understand the risks, trade-offs, and business impact of engineering decisions. Question 27. Tell me about a time when you had to communicate bad news to stakeholders. Note: interviewers use this question to evaluate whether you can communicate operational risk or project setbacks transparently while maintaining stakeholder trust. Senior engineers are expected to surface problems early, present clear mitigation strategies, and protect system reliability even when the message is difficult. This leadership signal is heavily evaluated at companies like Amazon and Meta under principles such as earn trust and ownership.
Here are the critical red flags. The instant rejection signals.
Interviewers use this question to detect engineers who avoid accountability or hide problems. Avoid these traps. 1. The delay the message, waiting until the problem becomes critical before informing stakeholders. 2. The technical excuse, blaming the issue entirely on infrastructure, legacy systems, or another team. 3. The panic announcement, communicating the issue without a mitigation plan or next steps. 4. The overly optimistic spin, downplaying the severity of the issue to avoid difficult conversations. 5. The information dump, explaining the failure with technical jargon instead of focusing on impact and recovery.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Transparency. Did the candidate communicate the issue clearly and promptly? 2. Impact awareness. Did they explain the business or customer impact of the problem? 3. Accountability. Did they take ownership rather than shifting blame? 4. Mitigation planning. Did they present a clear recovery strategy? 5. Organizational learning. Did the candidate implement systemic improvements after the incident? Strong engineers deliver bad news early and accompany it with a recovery plan.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: Our team was preparing to launch a new checkout fraud detection system before a major seasonal sales event. During final load testing, we discovered the fraud detection model significantly increased checkout latency during peak traffic. Task: the increased latency risked slowing down checkout for millions of users during the promotion, but the feature had already been announced to leadership as a major fraud prevention improvement. Action: instead of waiting for the issue to surface during launch, I scheduled an immediate update with product leadership and operations stakeholders. I presented load test results from our staging environment showing checkout latency increasing from 120 milliseconds to nearly 450 milliseconds under peak load. I explained the risk clearly and proposed a mitigation strategy. We would temporarily deploy the fraud detection system in monitoring mode to collect data while optimizing the model asynchronously. Result: leadership agreed with the phased rollout approach. The system launched safely during the sales event with no impact to checkout performance. Within 3 weeks, we optimized the model inference pipeline and reduced latency by 65%, allowing the feature to move to full enforcement mode. Learning plus L. The incident revealed that our deployment process lacked performance validation for machine learning services. After the project, I introduced automated load testing benchmarks into our CI pipeline to ensure all new services met latency SLO requirements before deployment. The plus L demonstrates that you converted a risky launch into a stronger engineering safeguard.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature stakeholder communication. 1. Transparency matched. You communicated the performance issue before it impacted production. 2. Impact awareness matched. The explanation focused on checkout latency and customer experience. 3. Accountability matched. You owned the problem instead of blaming infrastructure or the ML model. 4. Mitigation planning matched. The monitoring mode rollout allowed progress without risking system stability. 5. Organizational learning matched. CI performance benchmarks ensured similar issues would be caught earlier. This demonstrates responsible engineering leadership during difficult situations.
Follow-up 1. Clarification probe. Why did the latency issue only appear during final testing?
Answer: the earlier testing environments used smaller datasets and lower traffic simulation. The final load test used realistic peak traffic patterns, which revealed the inference pipeline bottleneck.
Follow-up 2. Level 3 or Level 4 junior depth. What specific optimization reduced the model latency?
Answer: we moved feature preprocessing from synchronous runtime execution to a pre-computed feature store. This significantly reduced the inference pipeline workload.
Follow-up 3. Level 5 or Level 6 senior depth. What if leadership had insisted on launching the system fully despite the latency risks?
Answer: if leadership chose to proceed, I would clearly document the risk and introduce safeguards such as feature flags and automatic fallback mechanisms. Engineering's role is to make risks visible and implement mitigation strategies.
Follow-up 4. Curveball. What if the performance issue had caused a real production incident during launch?
Answer: in that case, I would initiate incident response immediately, disable the feature through feature flags, and conduct a blameless postmortem to identify the root cause and prevent recurrence.
Leadership pro tip. Deliver problems with solutions.
Stakeholders rarely react negatively to bad news itself. They react to uncertainty. When communicating problems, always pair the issue with clear data, risk assessment, and a mitigation plan. This approach builds credibility and trust with leadership. Question 28. Tell me about a time you had to persuade leadership using data. Note: interviewers use this question to evaluate whether you can influence strategic decisions through evidence rather than opinion. Senior engineers are expected to use metrics, experimentation, and operational data to guide leadership toward technically sound decisions. This signal is heavily evaluated at companies like Google and Amazon, where data-driven decision-making is a core engineering principle.
Here are the critical red flags. The instant rejection signals.
Interviewers use this question to detect engineers who rely on authority or intuition instead of evidence. Avoid these traps. 1. The opinion debate, arguing for your solution using personal preference instead of measurable evidence. 2. The appeal to authority, saying the approach should be used because another company or famous engineer recommends it. 3. the cherry-picked data, selecting a single metric that supports your argument while ignoring other risks. 4. The technical monologue, presenting raw system metrics without translating them into business impact. 5. The escalation shortcut, going directly to leadership instead of building a data-driven case.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Evidence-based thinking. Did the candidate collect meaningful data before proposing a solution? 2. Analytical reasoning. Did they interpret system metrics to reveal a clear problem? 3. Decision framing. Did they present trade-offs that leadership could evaluate? 4. Persuasive communication. Did they translate technical metrics into business outcomes? 5. Organizational impact. Did the decision improve system reliability, scalability, or efficiency? Strong engineers use data to transform debates into decisions.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our platform team was experiencing frequent deployment failures due to tightly coupled services in our monolithic architecture. Engineering leadership believed the failures were isolated incidents rather than a systemic issue. Task: I believed we needed to invest in service isolation and improve our CI/CD pipeline, but convincing leadership required demonstrating that the failures were affecting engineering velocity. Action: I collected deployment metrics from our CI/CD pipeline and incident reports from the past 6 months. The data showed that nearly 30% of deployments were failing due to unrelated changes in other parts of the monolith. I presented this data in an architecture review meeting, showing that each failed deployment added an average of 45 minutes of debugging and rollback work. Result: the data clearly demonstrated the operational cost of the monolith. Leadership approved a project to decouple the most frequently changed components into independent services. Within 4 months, deployment failures dropped by 40% and the average deployment time decreased significantly. Learning plus L. The experience highlighted that architectural issues often remain invisible without structured metrics. After the project, I introduced a deployment reliability dashboard that tracked failure rates, rollback frequency, and recovery time for all services. The +L shows that you transformed anecdotal complaints into measurable engineering insight.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong data-driven leadership. 1. Evidence-based thinking matched. You gathered deployment metrics instead of relying on anecdotal evidence. 2. Analytical reasoning matched. The failure rate data revealed a systemic architectural problem. 3. Decision framing matched. Leadership saw the trade-off between architectural investment and engineering productivity. 4. Persuasive communication matched. Deployment failures were translated into lost engineering time. 5. Organizational impact matched. The architecture improvements reduced deployment failures and increased engineering velocity. This demonstrates how senior engineers influence decisions through measurable impact.
Follow-up 1. Clarification probe. Why did leadership initially believe the deployment failures were isolated incidents?
Answer: the failures appeared sporadic when viewed individually. Without aggregated metrics, it was difficult to recognize the systemic pattern affecting deployment reliability.
Follow-up 2. Level 3 or Level 4 junior depth. How did you collect the deployment metrics used in your analysis?
Answer: we extracted data from our CI/CD pipeline logs and incident management system to calculate deployment failure rates, rollback frequency, and recovery time.
Follow-up 3. Level 5 or Level 6 senior depth. What if leadership still rejected the architecture change despite the data?
Answer: if leadership prioritized short-term feature delivery, I would propose incremental improvements such as isolating the highest-risk components first. This would demonstrate the value of decoupling while minimizing disruption.
Follow-up 4. Curveball. What if the architecture migration introduced new operational complexity?
Answer: to mitigate that risk, we standardized service templates and monitoring dashboards so new services followed consistent operational patterns.
Leadership pro tip. Metrics create alignment.
Engineering debates often persist because participants rely on intuition. When you collect the right metrics, the problem becomes visible and decisions become easier. Data transforms disagreement into alignment. Question 29. Describe a situation where miscommunication caused a problem and how you fixed it. Note, interviewers ask this question to evaluate whether you can diagnose communication failures in complex engineering environments and introduce systems that prevent them. Senior engineers are expected to recognize when technical problems are actually coordination problems. This leadership signal is closely tied to dive deep and earn trust at companies like Amazon and Meta.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who treat miscommunication as a personal problem instead of a system problem. Avoid these traps. 1. The blame the other team story, claiming the issue occurred because another team failed to communicate clearly. 2. The one-time fix, resolving the immediate issue but failing to prevent the same miscommunication later. 3. The meeting overload, attempting to solve the issue by adding excessive meetings instead of clarifying technical contracts. 4. The silent engineer, not raising the miscommunication early when warning signals appeared. 5. The documentation dump, writing documentation after the incident but failing to ensure it is integrated into engineering workflows.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Root cause analysis. Did the candidate identify the structural reason communication failed? 2. Ownership. Did they take responsibility for resolving the misalignment? 3. Technical clarity. Did they introduce artifacts such as API contracts or design documents? 4. Operational recovery. Did they fix the immediate technical issue efficiently? 5. Systemic prevention. Did they implement a process that prevents future miscommunication? Strong engineers treat communication failures as engineering problems to solve.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our team was integrating a new payments API with an external service provider. During staging tests, we discovered that the provider expected idempotent requests, while our service retried failed requests without an idempotency key. Task: this mismatch caused duplicate payment attempts during network retries, creating a serious financial risk if the issue reached production. Action: I initiated a joint debugging session with the provider's engineering team and analyzed request logs from our observability dashboard. We identified that the API contract lacked explicit retry semantics. I immediately implemented idempotency keys in our payment service and updated our API documentation to define retry behavior clearly. Result: the fix prevented duplicate payment attempts and ensured safe retries during network failures. We successfully launched the integration with 0 payment duplication incidents. Learning plus L. The incident revealed that informal integration discussions are unreliable for critical systems. After the project, I introduced a contract-driven integration process requiring machine-readable API specifications and explicit failure handling rules before development begins. The +L demonstrates that you transformed a miscommunication into a stronger engineering integration process.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature engineering communication. 1. Root cause analysis matched. The issue was identified as a missing API contract requirement. 2. Ownership matched. You coordinated the investigation across both engineering teams. 3. Technical clarity matched. Idempotency keys and API documentation clarified retry behavior. 4. Operational recovery matched. The fix prevented duplicate transactions before launch. 5. Systemic prevention matched. The contract-driven integration process prevented similar issues in future integrations. This demonstrates leadership through system design rather than blame.
Follow-up 1. Clarification probe. Why did this communication gap occur during the integration?
Answer: both teams assumed retry behavior would be handled the same way. Because the integration lacked a formal API specification, those assumptions were never verified.
Follow-up 2. Level 3 or Level 4 junior depth. How do idempotency keys prevent duplicate transactions?
Answer: each request includes a unique identifier. If the system receives a retry with the same identifier, it recognizes the request as a duplicate and returns the original result instead of processing the payment again.
Follow-up 3, Level 5 or Level 6 Senior Depth. What if the external provider did not support idempotent requests?
Answer: in that case, we would implement a local transaction log and request deduplication mechanism on our side to ensure safe retries before forwarding requests to the provider.
Follow-up 4, Curveball. What if the duplicate payment issue had already reached production?
Answer: the first step would be disabling the retry mechanism to stop the duplication. Then, we would reconcile transaction logs and refund affected customers while implementing the idempotency fix.
Leadership Pro Tip: replace assumptions with contracts.
Most engineering miscommunication comes from unspoken assumptions. Senior engineers eliminate these risks by creating explicit contracts through API schemas, design documents, and integration specifications. Contracts turn fragile conversations into reliable system behavior. Question 30. Tell me about a time you had to present an idea clearly under pressure. Note: interviewers ask this question to evaluate whether you can communicate technical decisions effectively during high-stakes situations such as incidents, executive reviews, or tight deadlines. Senior engineers are expected to explain complex ideas clearly while helping teams make fast, informed decisions. This leadership signal is frequently evaluated at companies like Amazon and Google, where engineers often guide decisions during critical moments.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who struggle to communicate effectively under stress. Avoid these traps. 1. The technical overload, explaining every implementation detail instead of focusing on the key decision. 2. The unstructured explanation, jumping between ideas without presenting a clear recommendation. 3. The defensive presenter, becoming argumentative when stakeholders question the proposal. 4. The last-minute analysis, presenting an idea without supporting data or preparation. 5. The no-decision outcome, delivering a presentation that leaves stakeholders confused about the next step.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Clarity under pressure. Did the candidate structure the explanation clearly despite time constraints? 2. Decision orientation. Did the presentation guide stakeholders toward a concrete decision? 3. Evidence-based communication. Did the candidate support the idea with data or system metrics? 4. Confidence and composure. Did they remain calm and focused while explaining the idea? 5. Organizational impact. Did the decision lead to improved system reliability, scalability, or performance? Strong engineers bring clarity to high-pressure technical decisions.
Here is the FAANG level senior answer, STAR+L.
Pass the senior bar. Structure your answer using the STAR+L method. Situation: during a peak traffic event, our monitoring system detected rapidly increasing latency in the checkout service. Within minutes, the latency had doubled, threatening to disrupt customer transactions. Task: as the on-call senior engineer, I needed to quickly explain the situation to the incident response team and recommend a course of action while the system was under heavy load. Action: I analyzed our observability dashboards and noticed a surge in database queries caused by a recently deployed recommendation feature. During the incident call, I summarized the issue in 3 points: the latency spike, the suspected cause, and the proposed mitigation. I recommended temporarily disabling the recommendation queries using a feature flag while we investigated further. Result: the team executed the mitigation within minutes, and checkout latency returned to normal levels. After the incident, we confirmed that the recommendation feature was generating inefficient database queries under heavy traffic. Learning plus L. The incident revealed the importance of rapid decision frameworks during outages. I later introduced an incident response template that required engineers to present problems using a clear structure: impact, root cause hypothesis, and mitigation plan. The +L demonstrates that you improved how technical decisions are communicated during incidents.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong communication under pressure. 1. Clarity under pressure matched. The issue was explained using a simple 3-point structure. 2. Decision orientation matched. The recommendation focused on a specific mitigation step. 3. Evidence-based communication matched. Observability dashboards provided the supporting evidence. 4. Confidence and composure matched. The explanation guided the team during an active incident. 5. Organizational impact matched. The incident response template improved future communication during outages. This demonstrates leadership in high-pressure engineering environments.
Follow-up 1. Clarification probe. Why did you choose to disable the recommendation feature instead of scaling the database?
Answer: disabling the feature through a flag could be executed immediately and reduced load within seconds, while scaling the database would take longer and might not resolve inefficient query patterns.
Follow-up 2. Level 3 or Level 4 junior depth. How did you identify the problematic queries so quickly?
Answer: our observability dashboards included query performance metrics and request traces. The traces showed a sudden increase in database calls linked to the recommendation feature.
Follow-up 3. Level 5 or Level 6 senior depth. What if disabling the feature had negatively impacted the user experience?
Answer: maintaining checkout reliability was the top priority during the incident. Disabling the feature temporarily reduced functionality, but ensured the core transaction flow remained operational.
Follow-up 4. Curveball. What if the latency issue had continued even after disabling the feature?
Answer: in that scenario, we would escalate the incident response by analyzing database metrics, scaling infrastructure, and rolling back recent deployments until system performance stabilized.
Leadership pro tip. Structure creates clarity.
During high-pressure situations, clarity matters more than technical depth. Presenting problems using a simple structure, impact, cause hypothesis, and mitigation plan helps teams make faster and better decisions.
Category 3 wrap-up. The value of clarity.
You have successfully navigated the communication category. You now understand that senior engineering communication is not about talking more. It is about engineering automated, scalable information flows that prevent misalignment. But perfect communication means nothing if you aren't delivering tangible business value.
Transition from process to payoff.
A beautifully architected system is a failure if it does not move the needle for the business. As you move into senior leadership, you are no longer evaluated on how hard you work or how clean your code is. You are evaluated purely on the leverage you provide to the organization. This brings us to Category 4, Impact and Results.
Category 4. Impact and results.
At companies like Meta and Amazon, effort is irrelevant. Only outcomes matter. Interviewers use this category to filter out ticket takers, engineers who build what they are told without understanding why. At the staff and principal levels, you must prove that your technical decisions directly moved business metrics, whether that means slashing cloud compute costs, reducing P99 latency, or driving user conversion.
Category 4. Impact and results.
These 8 scenarios evaluate your ability to move the needle for the business and deliver measurable technical leverage. 31. Tell me about a project you are most proud of. 32. Tell me about your biggest accomplishment. 33. Tell me about a time when your work had significant impact. 34. Describe a time when you improved a process. 35. Tell me about a time you increased efficiency. 36. Tell me about a time you delivered results under pressure. 37. Describe a time you exceeded expectations. 38. Tell me about a time when you delivered a project with measurable results. If you cannot attach a concrete number to your success, the interviewer will assume there was no impact. Question 31. Tell me about a project you are most proud of. Note: interviewers use this question to evaluate whether you can deliver meaningful engineering impact that improves a system, a team, or a business outcome. Senior candidates are expected to demonstrate ownership of complex initiatives and measurable results. This leadership signal is closely evaluated at companies like Amazon and Meta, where engineers are expected to drive high-impact technical improvements.
Here are the critical red flags. The instant rejection signals.
Interviewers use this question to filter out candidates who mistake activity for impact. Avoid these traps. 1. The feature launch story, describing a project where you simply implemented a feature without measurable system or business impact. 2. The team credit story, explaining a project entirely as a group effort without clarifying your specific ownership or leadership role. 3. The technical vanity project, talking about a technically interesting refactor that had no meaningful effect on reliability, performance, or revenue. 4. The zero metrics outcome, claiming success without quantifying improvements such as latency reduction, cost savings, or user impact. 5. The short-term fix, describing a quick patch instead of a long-term system improvement.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Ownership. Did the candidate lead or significantly drive the initiative? 2. Impact measurement. Did they quantify the results using meaningful metrics? 3. Technical judgment. Did they make important architectural or design decisions? 4. Execution. Did they successfully deliver the solution despite complexity or obstacles? 5. Organizational influence. Did the project create long-term improvements for the team or company? Strong candidates highlight projects where technical leadership produced measurable impact.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our e-commerce platform experienced severe checkout slowdowns during seasonal traffic spikes. Observability dashboards showed that the recommendation engine was making synchronous calls during checkout, significantly increasing response times. Task: as the backend lead for checkout reliability, I was responsible for reducing latency without removing the recommendation feature that drove a significant portion of upsell revenue. Action: I analyzed production traces and confirmed that recommendation requests were adding nearly 120 milliseconds to the checkout request path. I proposed an architectural change to move recommendation generation to an asynchronous pipeline using a caching layer. The recommendations would be pre-computed and stored in Redis, allowing checkout services to retrieve them instantly without blocking the transaction. Result: after deploying the new architecture, checkout latency dropped by 35% and the platform handled peak traffic without timeouts. Conversion rates increased by 8% during the next major sales event due to the improved performance. Learning plus L. The project revealed that performance regressions often hide in cross-service dependencies. After the migration, I introduced latency budgets for all downstream service calls and added automated performance checks to our CI pipeline to detect regressions early. The plus L shows that the project improved not only one system, but also the engineering guardrails around performance.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong engineering impact. 1. Ownership matched. You led the architecture improvement for the checkout system. 2. Impact measurement matched. Latency decreased by 35% and conversion improved by 8%. 3. Technical judgment matched. The decision to decouple recommendations from checkout improved reliability and scalability. 4. Execution matched. The solution was implemented successfully before the next high-traffic event. 5. Organizational influence matched. Performance budgets and CI checks ensured the improvement persisted long-term. This demonstrates that you delivered both immediate results and long-term engineering improvements.
Follow-up 1. Clarification probe. Why did you choose caching instead of simply scaling the recommendation service?
Answer: scaling the recommendation service would have increased infrastructure cost without addressing the synchronous dependency in the checkout path. By pre-computing recommendations and caching them in Redis, we eliminated the blocking network call entirely. This reduced latency, while also improving system resilience during peak traffic spikes. The architecture also allowed recommendations to update asynchronously without affecting checkout performance.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the cached recommendations stayed relevant for users?
Answer: we built a background pipeline that refreshed recommendations every few minutes based on user activity events. The cache entries included expiration timestamps to ensure stale recommendations were automatically replaced. This allowed the system to balance performance and personalization while keeping the checkout path extremely fast. Observability metrics confirmed that cache hit rates remained above 95%.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider before introducing the asynchronous pipeline?
Answer: the main trade-off was freshness versus latency. Pre-computing recommendations means they may be slightly outdated compared to real-time computation. However, the latency reduction and reliability benefits outweighed the minor delay in personalization updates. We also added fast refresh triggers for major user events to reduce staleness where it mattered most.
Follow-up 4, curveball. What if the caching layer failed during peak traffic?
Answer: we designed the system with graceful degradation in mind. If RIDIs became unavailable, the checkout service would bypass recommendations entirely rather than blocking the transaction. This ensured that the core purchasing flow remained stable even if the recommendation feature failed. Protecting the primary revenue path was the top architectural priority.
Leadership pro tip. Impact is measured, not claimed.
When interviewers ask about projects you are proud of, they are not looking for the most technically complicated project. They are looking for projects where your technical decisions produced measurable improvements to the system or the business. Always connect your work to metrics such as latency, reliability, cost savings, or user growth. Question 32. Tell me about your biggest accomplishment. Note: interviewers use this question to evaluate whether your work has produced meaningful and measurable impact. At senior levels, accomplishments are not defined by individual coding achievements, but by improvements to systems, processes, or organizational capability. This leadership signal is commonly evaluated at companies like Amazon and Google, where engineers are expected to deliver results that scale across teams.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to distinguish between activity and real impact. Avoid these traps. 1. The hard work story, explaining how difficult the project was instead of explaining the measurable outcome. 2. The single feature launch, presenting a small feature release as your biggest accomplishment without system-level impact. 3. The individual hero narrative, ignoring collaboration and presenting the story as a solo achievement. 4. The unquantified success, claiming the project was successful without metrics or data. 5. The local optimization, improving something small within your team but failing to influence broader systems.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Scope of impact. Did the accomplishment affect a major system, team, or business metric? 2. Ownership. Did the candidate drive the initiative rather than simply contribute? 3. Strategic thinking. Did the candidate identify a meaningful problem worth solving? 4. Execution excellence. Did they successfully deliver the solution despite complexity? 5. Long-term value. Did the improvement create lasting organizational benefits? Strong candidates describe accomplishments that improved systems at scale.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our data platform handled analytics pipelines for multiple product teams, but query performance was deteriorating as data volumes increased. Dashboards that previously loaded in seconds were now taking over a minute, frustrating internal stakeholders. Task: as the engineer responsible for the analytics infrastructure, I needed to restore query performance while ensuring the system could scale for future growth. Action: I conducted a deep performance analysis and identified that most queries were scanning large raw tables instead of pre-aggregated datasets. I proposed a redesign of the analytics architecture using materialized views and scheduled aggregation pipelines. I documented the approach in an architecture RFC and coordinated implementation with the data engineering team. Result: after deploying the new architecture, average dashboard load times dropped from 65 seconds to under 8 seconds. The optimized data model also reduced compute costs by 30% due to more efficient queries. Learning plus L. The project revealed the importance of proactively managing data growth. Afterward, I introduced query performance monitoring and established guidelines requiring teams to use aggregated datasets for high-traffic dashboards. The plus L demonstrates that the accomplishment improved both performance and long-term data engineering practices.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates meaningful engineering accomplishment. 1. Scope of impact matched. The improvement affected analytics workflows across multiple product teams. 2. Ownership matched. You identified the root cause and led the architecture redesign. 3. Strategic thinking matched. The decision focused on scalable data modeling rather than short-term fixes. 4. Execution matched. The optimized architecture was successfully deployed and adopted. 5. Long-term value matched, monitoring and query guidelines ensured the improvement persisted. This demonstrates a senior engineer who improves systems rather than simply delivering tasks.
Follow-up 1. Clarification probe. Why did query performance degrade so dramatically as the dataset grew?
Answer: most dashboards were querying raw event tables containing billions of records. As the dataset expanded, full table scans became increasingly expensive and slow. By introducing aggregated datasets and materialized views, we reduced the amount of data each query needed to process. This dramatically improved performance while also lowering compute costs.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure that the aggregated datasets remained accurate and up to date?
Answer: we implemented scheduled aggregation jobs that updated the datasets at regular intervals. These jobs processed new event data and refreshed the materialized views automatically. We also added monitoring alerts to detect failures in the pipeline. This ensured that dashboards always reflected recent data without sacrificing performance.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when moving from raw queries to aggregated datasets?
Answer: the main trade-off was between query flexibility and performance. Raw datasets allowed arbitrary analysis, but were extremely expensive to query at scale. Aggregated datasets reduced flexibility slightly but dramatically improved speed and cost efficiency. For exploratory analysis, we still allowed access to raw data through specialized tools.
Follow-up 4. Curveball. What if a product team required real-time analytics instead of aggregated datasets?
Answer: in that case, we would design a separate real-time pipeline optimized for streaming workloads. Technologies like Kafka and stream processing frameworks could deliver near real-time insights without overloading the analytics warehouse. This approach keeps real-time workloads isolated from batch analytics queries.
Leadership pro tip. Scale your impact.
Your biggest accomplishment should not be the most complicated piece of code you wrote. It should be the initiative that improved how systems, teams, or organizations operate. Senior engineers demonstrate accomplishment through measurable improvements that continue delivering value long after the project is complete. Question 33. Tell me about a time when your work had significant impact. Note: interviewers use this question to evaluate whether your work meaningfully changed a system, product, or business outcome. Senior engineers are expected to identify high-leverage problems and deliver solutions that produce measurable improvements at scale. This signal is closely aligned with Amazon's deliver results and Google's emphasis on impact-driven engineering.
Here are the critical red flags. The instant rejection signals.
Interviewers use this question to detect candidates who confuse effort with impact. Avoid these traps. 1. The busy engineer story, describing a project that required a lot of work but produced minimal improvement. 2. The invisible impact, claiming the project was important but failing to explain how the system or business improved. 3. The pure feature launch, talking about shipping a feature rather than improving performance, reliability, or efficiency. 4. The no ownership problem, describing a project where your role was unclear or minor. 5. The short-term win, delivering a quick improvement that did not scale or persist long-term.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Problem identification. Did the candidate recognize a meaningful opportunity for improvement? 2. Strategic thinking. Did they select a solution that would scale long-term? 3. Technical leadership. Did they drive the design or architecture of the solution? 4. Execution. Did the candidate successfully implement the improvement? 5. Measured impact. Did the change produce clear and measurable results? Strong engineers focus their effort on improvements that create disproportionate impact.
Here is the FAANG level senior answer, STAR+L.
Pass the senior bar. Structure your answer using the STAR+L method. Situation: our company's notification platform handled millions of daily alerts across multiple services. However, the system often experienced delays during peak traffic, causing critical alerts to arrive minutes late. Task: as the engineer responsible for the messaging infrastructure, I needed to improve reliability and ensure notifications were delivered consistently under high load. Action: after analyzing our observability dashboards, I discovered that a single centralized message queue was becoming a bottleneck. I proposed redesigning the system to use partitioned message queues with horizontal scaling. I documented the architecture in an RFC and coordinated the rollout with the infrastructure team. Result: the new architecture reduced message processing latency by 70% and eliminated notification backlogs during peak traffic. Incident response teams began receiving alerts within seconds instead of minutes. Learning plus L. The project revealed that system scalability issues often emerge gradually as usage grows. Afterward, I introduced load testing benchmarks in our CI pipeline to ensure future changes could handle projected traffic volumes. The plus L demonstrates that the improvement strengthened both the system architecture and future engineering practices.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates meaningful engineering impact. 1. Problem identification matched. You recognize that alert delivery delays were affecting operational reliability. 2. Strategic thinking matched. Partitioned queues enabled horizontal scalability rather than temporary fixes. 3. Technical leadership matched. You authored the architecture proposal and coordinated implementation. 4. Execution matched. The redesigned messaging system successfully handled peak traffic. 5. Measured impact matched. Notification latency improved by 70%. This demonstrates an engineer who identifies high-impact problems and delivers scalable solutions.
Follow-up 1. Clarification probe. Why did the original messaging system struggle during peak traffic?
Answer: the platform relied on a single centralized queue that processed all notifications sequentially. As traffic increased, the queue became overloaded and message processing slowed dramatically. By introducing partitioned queues, we distributed the workload across multiple consumers. This allowed the system to scale horizontally and maintain consistent performance.
Follow-up 2. Level 3 or Level 4 junior depth. How did you determine the appropriate number of queue partitions?
Answer: we analyzed historical traffic patterns and simulated peak load using load testing tools. Based on those results, we sized the partitions to handle projected traffic growth over the next year. The architecture also allowed partitions to be added dynamically if traffic increased further. This ensured the system remained scalable as usage expanded.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when moving to a partitioned queue architecture?
Answer: partitioning improved throughput but introduced complexity around message ordering and consumer coordination. We designed the system so messages related to the same service were routed to the same partition, preserving order where it mattered. This allowed us to scale processing while maintaining the reliability guarantees needed for alert delivery.
Follow-up 4. Curveball. What if the new architecture introduced operational complexity for the infrastructure team?
Answer: to reduce operational overhead, we built automated monitoring dashboards and alerting rules for each queue partition. These tools allowed the infrastructure team to detect issues quickly without manual intervention. We also documented operational playbooks to guide incident response. This ensured the architecture remained manageable as the system scaled.
Leadership pro tip. Focus on leverage.
The most impactful engineers focus on problems that affect entire systems or teams. Instead of optimizing small components, they identify architectural bottlenecks and design solutions that unlock significant improvements across the organization. Question 34. Describe a time when you improved a process. Note: interviewers ask this question to evaluate whether you can identify inefficiencies in engineering workflows and introduce scalable improvements. Senior engineers are expected to optimize systems not only through code, but also through better development processes, automation, and engineering standards. This leadership signal aligns strongly with Amazon's Invent and Simplify and Google's culture of engineering productivity.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who misunderstand process improvement. Avoid these traps. 1. The more meetings solution, attempting to fix inefficiency by adding recurring meetings instead of addressing the root cause. 2. The manual fix, introducing a manual checklist instead of automating the workflow. 3. The local optimization, improving something small within your team without solving the broader workflow problem. 4. The unmeasured improvement, claiming the process improved without metrics such as cycle time or failure rate. 5. The temporary patch, fixing the issue once without preventing it from recurring.
Here are the signals the interviewer is scoring.
While you answer this question, the interviewer evaluates these 5 leadership signals. 1. Problem diagnosis. Did the candidate identify the root cause of the inefficient process? 2. Systems thinking. Did they design a scalable improvement rather than a temporary fix? 3. Automation. Did they reduce manual effort through tooling or workflow changes? 4. Execution. Did they successfully implement the improvement across the team? 5. Measured impact. Did the improvement reduce cycle time, errors, or operational overhead? Strong engineers improve productivity by removing friction from the development process.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our engineering team frequently experienced failed deployments due to configuration mismatches between staging and production environments. These failures often caused delayed releases and emergency rollbacks. Task: as part of the platform engineering team, I was responsible for improving the reliability of our deployment process and reducing environment-related failures. Action: I analyzed deployment logs and discovered that configuration values were manually maintained across multiple environments. I proposed introducing infrastructure as code using Terraform to standardize environment configurations. I documented the proposal in an internal RFC and led the migration of our deployment pipeline to the new system. Result: after the migration, environment configuration drift was eliminated and deployment failures dropped by 45%. Release cycles became significantly more predictable because deployments behaved consistently across environments. Learning plus L. The project highlighted how manual infrastructure management creates hidden operational risk. After the migration, I introduced automated validation checks in our CI pipeline to detect configuration changes before deployment. The plus L demonstrates that the improvement strengthened both the deployment process and long-term infrastructure reliability.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong process improvement leadership. 1. Problem diagnosis matched. Configuration drift between environments was identified as the root cause. 2. Systems thinking matched. Infrastructure as code standardized environments across the organization. 3. Automation matched. Terraform eliminated manual configuration management. 4. Execution matched. The migration was successfully implemented in the deployment pipeline. 5. Measured impact matched. Deployment failures decreased by 45%. This demonstrates a senior engineer who improves system reliability by fixing the underlying workflow.
Follow-up 1. Clarification probe. Why was configuration drift such a significant problem in your deployment pipeline?
Answer: configuration values were manually maintained in multiple environments, which meant small differences accumulated over time. These inconsistencies caused deployments to behave differently in staging versus production. By defining infrastructure through code, we ensured every environment was created from the same configuration template. This removed a major source of deployment failures.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the team adopted the new infrastructure as code workflow?
Answer: we integrated Terraform directly into the CI/CD pipeline, so configuration changes were validated automatically. Engineers could no longer deploy infrastructure manually, which encouraged adoption of the new process. We also created documentation and internal workshops to help the team learn the workflow. Within a few weeks, all deployments were managed through the new system.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider before introducing infrastructure as code?
Answer: infrastructure as code introduces an initial learning curve and additional tooling complexity. However, the long-term benefits in reliability, reproducibility, and auditability outweighed those costs. Once the system was established, environment provisioning became faster and significantly less error-prone. This made deployments more predictable for the entire engineering organization.
Follow-up 4. Curveball. What if Terraform introduced a misconfiguration that affected all environments?
Answer: we mitigated that risk by introducing automated validation and staged rollouts. Infrastructure changes were first applied to staging environments and verified through automated tests. Only after passing those checks were they promoted to production. This process ensured that infrastructure errors were detected before impacting live systems.
Leadership pro tip: automate the friction.
Many engineering inefficiencies exist because teams rely on manual processes. The most impactful improvements come from automation and standardization. When you remove manual steps from workflows, you not only increase speed, but also dramatically reduce the risk of human error. Question 35. Tell me about a time you increased efficiency. Note: interviewers use this question to evaluate whether you can identify inefficiencies in engineering systems and deliver improvements that increase productivity or reduce operational cost. Senior engineers are expected to recognize bottlenecks and introduce scalable solutions that improve how teams build and operate software. This leadership signal is strongly aligned with Amazon's Invent and Simplify and Meta's emphasis on engineering velocity.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who misunderstand efficiency improvements. Avoid these traps. 1. The minor optimization, improving something trivial that does not meaningfully affect system performance or developer productivity. 2. The local efficiency, optimizing a small component without improving the broader system workflow. 3. The no-metric story, claiming efficiency improvements without measuring time savings or performance gains. 4. The short-term hack, implementing a quick workaround instead of solving the root cause of inefficiency. 5. The solo hero narrative, ignoring the collaboration required to implement system-wide improvements.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Problem discovery: did the candidate identify a meaningful inefficiency in the system or workflow? 2. Technical strategy: did they design a solution that scales rather than a quick fix? 3. Automation or optimization: did the improvement significantly reduce manual effort or system overhead? 4. Execution: did they successfully implement the improvement across the team or system? 5. Measured efficiency gains: did the change produce clear improvements in performance, cost, or developer productivity? Strong engineers improve efficiency by eliminating bottlenecks in systems and workflows.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our CI pipeline had become extremely slow as the codebase grew. Full test suites were running for every commit, causing build times to exceed 45 minutes and significantly slowing down developer productivity. Task: as a senior engineer on the platform team, I was responsible for improving the CI pipeline so developers could receive faster feedback while maintaining test reliability. Action: I analyzed the CI logs and discovered that most builds were running unnecessary integration tests that rarely changed. I proposed introducing test parallelization and a selective test execution system that triggered only relevant tests based on code changes. I documented the proposal in an engineering design document and led the implementation across the CI pipeline. Result: after deploying the improvements, average CI build times dropped from 45 minutes to 12 minutes. Developers were able to iterate faster, and the reduced pipeline time significantly increased overall engineering velocity. Learning plus L. The project highlighted how CI pipelines often degrade as codebases grow. After the optimization, I introduced pipeline performance monitoring and alerts to ensure build times remained within acceptable thresholds. The +L demonstrates that the improvement created lasting guardrails around engineering productivity.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates meaningful efficiency improvement. 1. Problem discovery matched. CI build times were identified as a major productivity bottleneck. 2. Technical strategy matched. Selective test execution and parallelization addressed the root cause. 3. Automation matched. The pipeline automatically determined which tests to run for each change. 4. Execution matched. The improvements were successfully deployed across the CI infrastructure. 5. Measured efficiency gains matched. Build times improved from 45 minutes to 12 minutes. This demonstrates a senior engineer who improves productivity through scalable automation.
Follow-up 1. Clarification probe. Why were the CI build times increasing so dramatically?
Answer: as the codebase grew, more integration tests were added to the pipeline, but they were always executed for every commit. This meant developers waited for many tests that were unrelated to their changes. By analyzing test coverage patterns, we identified opportunities to run only the relevant tests. This significantly reduced unnecessary pipeline work.
Follow-up 2. Level 3 or Level 4 junior depth. How did the selective test execution system determine which tests to run?
Answer: we mapped test suites to specific modules in the codebase and tracked file changes in each commit. The CI system then triggered only the tests associated with the modified components. This allowed the pipeline to focus on the most relevant checks while maintaining confidence in code quality. Parallel test execution further reduced total runtime.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when reducing the number of tests executed per build?
Answer: the primary concern was missing integration issues if too few tests were executed. To mitigate that risk, we maintained a full nightly test run that validated the entire system. This ensured comprehensive coverage while allowing developers to receive faster feedback during daily development cycles.
Follow-up 4. Curveball. What if a bug slipped through because a test was not triggered by the selective execution system?
Answer: to address that risk, we monitored defect reports and reviewed whether any failures were caused by missing tests. If we detected gaps, we updated the module-to-test mappings immediately. Over time, this feedback loop improved the accuracy of the test selection system while preserving the speed improvements.
Leadership pro tip: remove bottlenecks.
Efficiency improvements are often about identifying bottlenecks that slow down entire teams. By removing friction in critical workflows like CI pipelines or deployments, engineers can dramatically increase productivity without adding more people or resources. Question 36. Tell me about a time you delivered results under pressure. Note: interviewers use this question to evaluate how you perform during high-stakes engineering situations such as production incidents, launch deadlines, or system outages. Senior engineers are expected to remain calm, prioritize effectively, and make technically sound decisions under time pressure. This leadership signal aligns strongly with Amazon's bias for action and Meta's culture of rapid execution.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who panic or rely on reckless shortcuts under pressure. Avoid these traps. 1. The hero debugger jumping directly into code changes without first diagnosing the problem. 2. The blame the system story explaining the incident without showing leadership in resolving it. 3. The reckless fix deploying risky changes without understanding the consequences. 4. The no prioritization, trying to fix everything simultaneously instead of stabilizing the most critical component first. 5. The temporary patch, solving the immediate crisis without addressing the root cause afterward.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Situational awareness: did the candidate quickly understand the severity and scope of the issue? 2. Prioritization: did they focus on the highest impact actions first? 3. Decision-making: did they make sound technical decisions despite time pressure? 4. Execution: did the team successfully stabilize the system or deliver the project? 5. Post-incident learning: did the candidate introduce improvements to prevent future crises? Strong engineers remain calm and decisive when systems or deadlines are under pressure.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: 2 days before a major product launch, our monitoring dashboard showed a sharp increase in API latency for the user authentication service. This service was critical because every login request depended on it. Task: as the senior backend engineer on the team, I needed to quickly diagnose the issue and stabilize the service before the launch deadline. Action: I began by analyzing distributed traces and database metrics to identify the root cause. The data revealed that a recent feature had introduced a database query that performed a full table scan under heavy load. Instead of rewriting the entire feature under time pressure, I created an optimized index and introduced a caching layer to reduce repeated queries. Result: the fix reduced authentication latency by nearly 60% and stabilized the service before the launch. The product launch proceeded without any performance issues. Learning plus L. After the incident, I introduced query performance reviews during code reviews and added automated query analysis tools to our CI pipeline to detect inefficient database operations early. The plus L shows that the team not only resolved the immediate crisis, but also prevented similar performance issues in the future.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong leadership under pressure. 1. Situational awareness matched. You quickly identified the authentication service as the source of the latency spike. 2. Prioritization matched. Instead of rewriting the feature, you applied a targeted fix to stabilize the system quickly. 3. Decision-making matched. Adding an index and caching layer addressed the root performance issue efficiently. 4. Execution matched. The system stabilized before the launch deadline. 5. Post-incident learning matched. Query analysis tools and code review guidelines prevented similar issues. This demonstrates a senior engineer who balances speed and technical judgment during critical situations.
Follow-up 1. Clarification probe. Why did you choose to add an index instead of rewriting the feature entirely?
Answer: rewriting the feature would have taken several days and introduced significant risk before the launch deadline. Adding a database index addressed the immediate performance bottleneck with minimal changes. This allowed us to stabilize the service quickly while preserving the feature functionality. After the launch, we scheduled a deeper refactor to further optimize the query.
Follow-up 2. Level 3 or Level 4 junior depth. How did you confirm that the database query was causing the latency issue?
Answer: we used distributed tracing and database performance metrics to analyze request latency across services. The traces showed that authentication requests were spending most of their time waiting for the database query to complete. Query logs confirmed that the new query was scanning a large table without an index. Once the index was added, query execution time dropped significantly.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when introducing a caching layer during the incident?
Answer: caching improves performance but introduces challenges around data consistency and cache invalidation. In this case, authentication data changed infrequently, making it a safe candidate for short-lived caching. We implemented a short TTL to ensure updates would propagate quickly if user credentials changed. This allowed us to gain performance improvements without compromising security or accuracy.
Follow-up 4. Curveball. What if the latency issue had continued even after adding the index?
Answer: if the issue persisted, the next step would have been isolating the service behind a feature flag or temporarily limiting traffic to protect the system. We also prepared rollback plans in case the recent deployment needed to be reverted. Incident response requires having multiple mitigation strategies ready. This ensures the system can be stabilized quickly even if the first fix does not work.
Leadership pro tip. Calm decisions win incidents.
During high-pressure situations, the best engineers slow down their thinking rather than rushing into changes. A clear diagnosis followed by targeted fixes often resolves incidents faster than large, risky changes made under stress. Question 37. Describe a time you exceeded expectations. Note: interviewers ask this question to evaluate whether you proactively deliver more value than originally required. Senior engineers are expected to go beyond task execution by identifying opportunities to improve reliability, scalability, or business outcomes. This leadership signal aligns strongly with Amazon's deliver results and Google's emphasis on engineers who elevate the bar for their teams.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to identify candidates who misunderstand what exceeding expectations means. Avoid these traps. 1. The overtime story, working long hours but not producing meaningful improvements. 2. The extra feature, adding unnecessary features that were not aligned with the business goal. 3. The gold plating, over-engineering a solution instead of delivering practical value. 4. The no stakeholder value, improving something technically interesting but irrelevant to users or the business. 5. The solo achievement, ignoring collaboration and presenting the story as an individual victory.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Initiative. Did the candidate identify opportunities beyond the original requirements? 2. Strategic thinking. Did the additional work create meaningful system or business value? 3. Technical excellence. Did the candidate design a solution that improved reliability, scalability, or performance? 4. Execution. Was the improvement delivered successfully without delaying the original goal? 5. Organizational benefit. Did the improvement create lasting value for the team or system? Strong engineers exceed expectations by solving problems stakeholders did not yet realize existed.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our team was tasked with launching a new internal reporting dashboard for product managers. The original goal was simply to surface existing analytics data through a new interface. Task: my responsibility was to build the backend service that provided the data API powering the dashboard. Action: while implementing the API, I noticed that most dashboard queries repeatedly executed expensive aggregation queries against large datasets. Instead of simply exposing the raw data, I proposed building a pre-aggregation pipeline that generated optimized summary tables. I documented the proposal in an architecture note and coordinated with the data engineering team to implement it. Result: the optimized pipeline reduced dashboard load times from nearly 40 seconds to under 5 seconds. Product managers could now explore analytics interactively instead of waiting for slow queries to complete. Learning plus L. The experience highlighted how internal analytics tools often suffer from performance issues as datasets grow. After the project, I introduced performance guidelines for analytics services and added monitoring alerts to detect slow queries early. The +L shows that the improvement elevated both the product experience and the team's data engineering practices.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates exceeding expectations in a meaningful way. 1. Initiative matched. You identified a performance issue that was outside the original project scope. 2. Strategic thinking matched. Pre-aggregated data dramatically improved system performance. 3. Technical excellence matched. The architecture redesign addressed a fundamental scalability issue. 4. Execution matched. The improvement was delivered alongside the original project timeline. 5. Organizational benefit matched. Monitoring and performance guidelines improved future analytics systems. This demonstrates a senior engineer who improves systems beyond the immediate project requirements.
Follow-up 1. Clarification probe. Why did the dashboard queries take so long before the optimization?
Answer: the dashboard relied on large raw event tables that required expensive aggregation queries every time a user loaded the page. As data volume increased, those queries became significantly slower. By introducing pre-aggregated tables, we shifted the heavy computation into scheduled pipelines instead of real-time queries. This allowed the dashboard to retrieve results almost instantly.
Follow-up 2. Level 3 or Level 4 junior depth. How did you ensure the pre-aggregated data remained accurate?
Answer: we built scheduled aggregation jobs that refreshed the summary tables at regular intervals using the latest event data. The pipeline also included validation checks to ensure the aggregated values matched the underlying raw data. Monitoring alerts were added to detect failures in the aggregation process. This ensured the dashboard always displayed reliable analytics.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when introducing pre-aggregated datasets?
Answer: pre-aggregation significantly improves query speed, but introduces a delay between data ingestion and availability. We balance this by refreshing the aggregated datasets frequently enough to maintain near real-time insights. For deeper exploratory analysis, product analysts could still access the raw event tables. This approach preserved flexibility while optimizing dashboard performance.
Follow-up 4, curveball. What if the data pipeline failed and the dashboard showed outdated information?
Answer: we designed the system with monitoring and fallback mechanisms. Alerts were triggered if the aggregation pipeline stopped updating data within the expected window. In that case, the dashboard would display a warning indicating the timestamp of the latest update. This ensured stakeholders remained aware of data freshness while we restored the pipeline.
Leadership pro tip: anticipate the next problem.
Exceeding expectations does not mean doing extra work randomly. It means recognizing future system problems early and solving them proactively. Engineers who anticipate scalability or reliability issues before they become visible deliver the greatest long-term impact. Question 38. Tell me about a time when you delivered a project with measurable results. Note: interviewers use this question to evaluate whether you can deliver engineering work that produces clear, quantifiable impact. At senior levels, success is not defined by shipping code but by improving reliability, performance, cost efficiency, or business outcomes. This leadership signal aligns closely with Amazon's deliver results and Meta's emphasis on measurable engineering impact.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who cannot connect their work to measurable outcomes. Avoid these traps. 1. The feature launch story, describing a project launch without explaining how it improved system performance or business metrics. 2. The no baseline problem, claiming improvement without comparing results to the original system performance. 3. The vanity metrics, highlighting irrelevant metrics that do not reflect real system impact. 4. The unclear ownership, explaining the project without clarifying your role in driving the result. 5. The short-term win, delivering a quick improvement without considering long-term scalability.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Clear problem definition. Did the candidate identify a measurable system or business problem? 2. Data-driven execution. Did they use metrics to guide the solution design? 3. Technical ownership. Did they drive the implementation or architecture of the solution? 4. Measured results. Did the project produce quantifiable improvements? 5. Long-term sustainability. Did the improvement remain effective over time? Strong engineers define success through measurable system or business outcomes.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our company's search service handled millions of daily product queries, but performance metrics showed that search latency had gradually increased as the product catalog expanded. During peak traffic, some queries took more than 900 milliseconds to return results. Task: as the back-end engineer responsible for the search infrastructure, I was tasked with improving search performance without compromising result relevance. Action: after analyzing query patterns and index performance metrics, I discovered that several filters were being executed inefficiently during query processing. I redesigned the indexing strategy to include pre-computed filter indexes and optimized query execution paths. The changes were documented in an architecture design review and implemented incrementally to minimize risk. Result: after deploying the optimized indexing strategy, average search latency dropped from 900 milliseconds to around 300 milliseconds. The faster response time improved user engagement and increased product search conversion rates by approximately 12%. Learning plus L. The project demonstrated the importance of continuously monitoring search performance as data volumes grow. After the improvement, I introduced automated performance benchmarks that run during index deployments to detect potential regressions. The +L demonstrates that the project created both immediate performance gains and long-term monitoring safeguards.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates measurable engineering impact. 1. Clear problem definition matched. Search latency was identified as a measurable performance issue. 2. Data-driven execution matched. Query analysis and indexing metrics guided the optimization strategy. 3. Technical ownership matched. You led the architecture redesign of the search indexing system. 4. measured results matched. Latency decreased from 900 milliseconds to 300 milliseconds, and conversion improved by 12%. 5. Long-term sustainability matched. Automated performance benchmarks protected the improvement. This demonstrates a senior engineer who ties technical improvements directly to measurable business outcomes.
Follow-up 1, clarification probe. Why did search latency increase as the catalog grew?
Answer: as the catalog expanded, search queries had to evaluate a larger dataset and apply multiple filters dynamically. The original index structure was optimized for smaller datasets and became inefficient at scale. By pre-computing common filter indexes, we reduced the amount of work required during query execution. This significantly improved search response times.
Follow-up 2, Level 3 or Level 4 junior depth. How did you ensure the indexing changes did not affect search result accuracy?
Answer: we validated the new indexing strategy using offline evaluation datasets that compared search results before and after the change. The tests confirmed that ranking quality remained consistent while performance improved. We also deployed the change gradually using canary releases to monitor real user queries. This allowed us to verify the results before full rollout.
Follow-up 3, Level 5 or Level 6 senior depth. What trade-offs did you consider when optimizing the search index?
Answer: pre-computing filter indexes improves query performance but increases index storage size and update complexity. We analyzed the most frequently used filters and prioritized those for optimization. Less common filters continued using dynamic evaluation to avoid unnecessary index bloat. This balanced performance gains with operational efficiency.
Follow-up 4, curveball. What if the new indexing strategy slowed down catalog update operations?
Answer: to mitigate that risk, we separated indexing updates from user-facing search queries. Catalog changes were processed through asynchronous indexing pipelines that updated the optimized indexes incrementally. This ensured that write operations remained efficient while search performance improved. Monitoring alerts were also added to detect indexing delays.
Leadership pro tip: define success with metrics.
One of the strongest signals in senior engineering interviews is the ability to connect technical work with measurable outcomes. Whenever possible, quantify improvements using metrics such as latency, cost reduction, throughput, or business conversion rates.
Category 4 wrap-up: the ROI of engineering.
You have now mastered the impact and results category. You understand that at the elite level, you are not paid for your effort, you are paid for your outcomes. You have learned how to frame your success through the lens of business value, metrics, and technical leverage. You have proven that you do not just close tickets, you move the business forward.
Transition from outcomes to productivity.
Delivering results on assigned projects is the baseline, but the highest-level architects do not wait for a roadmap to tell them what to fix. They identify the gaps, invent the solutions, and challenge the existing way of working before the business even realizes there is a problem. This brings us to Category 5, Initiative and Innovation.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google Caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
The Google STAR+L Interview Bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war-room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If LeetCode is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
Category 5. Initiative and Innovation.
Interviewers use this category to evaluate your ability to drive change without permission. They are looking for force multipliers, engineers who find opportunities that others missed and build systems that improve the entire organization. This is where companies like Netflix and Amazon test your bias for action and your courage to take calculated risks to solve systemic friction.
Category 5. Initiative and Innovation Masterclass questions.
These 8 questions measure your ability to think beyond your role and drive technical evolution. 39. Tell me about a time you introduced a new idea. 40. Tell me about a time you challenged the status quo. 41. Describe a time when you improved an existing system. 42. Tell me about a time you automated something. 43. Tell me about a time you found an opportunity others missed. 44. Tell me about a time you built something from scratch. 45. Describe a time when you drove innovation within your team. 46. Tell me about a time you took a calculated risk that paid off or did not. Innovation is not about new technology. It is about identifying and solving unaddressed business friction. Question 39. Tell me about a time you introduced a new idea. Note: interviewers ask this question to evaluate whether you proactively improve engineering systems rather than simply executing assigned work. Senior engineers are expected to identify inefficiencies, propose innovative solutions, and influence teams to adopt better approaches. This leadership signal strongly aligns with Amazon's Invent and Simplify and Google's culture of engineering innovation.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who confuse novelty with impact. Avoid these traps. 1. The shiny tool idea, proposing a trendy technology without solving a real problem. 2. The personal experiment, building something interesting that the team never actually adopted. 3. The zero-metric story, claiming the idea was successful without measuring its impact. 4. The manager approved everything, presenting the idea as leadership-driven rather than something you initiated. 5. The prototype only, building a demo but failing to productionize the solution.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 innovation signals. 1. Problem recognition. Did the candidate identify a real engineering pain point? 2. Original thinking. Did they propose a new or improved technical approach? 3. Influence. Did they persuade the team to adopt the idea? 4. Execution. Was the idea successfully implemented in production? 5. Measured impact. Did the innovation produce measurable improvements? Strong engineers innovate by solving real problems with practical ideas.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our engineering organization managed more than 60 microservices, but ownership of those services was poorly documented. During incidents, engineers often spent 20-30 minutes just identifying the responsible team. Task: As a senior engineer frequently involved in incident response, I wanted to improve service discoverability so on-call engineers could quickly identify service owners and operational documentation. Action. I proposed introducing an internal service catalog inspired by Backstage. I created an RFC describing how each service would register metadata including owner, repository, runbooks, and dashboards. I built a prototype that automatically extracted service metadata from Git repositories and integrated it with our observability dashboards. Result: after adoption, incident response teams could immediately identify service owners and related documentation. Mean time to identify the responsible team during incidents dropped from roughly 25 minutes to under 5 minutes. Learning plus L. The success of the catalog highlighted how operational metadata should be treated as part of the system architecture. After the project, we introduced CI checks requiring new services to register ownership and runbook information before deployment. The plus L shows that the innovation became a permanent engineering standard rather than a one-off improvement.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates meaningful innovation. 1. Problem recognition matched. Incident response delays revealed a systemic ownership problem. 2. Original thinking matched. The service catalog introduced a new way to organize service metadata. 3. Influence matched. The RFC and prototype helped convince teams to adopt the platform. 4. Execution matched. The catalog integrated with Git repositories and observability tools. 5. Measured impact matched. Incident ownership discovery time improved from 25 minutes to under 5 minutes. This demonstrates innovation that improves operational efficiency across the organization.
Follow-up 1. Clarification probe. Why was identifying service ownership so difficult before introducing the catalog?
Answer: service ownership information was scattered across documentation, Slack threads, and outdated wiki pages. During incidents, engineers often had to manually trace Git repositories or search past tickets to find the responsible team. The catalog centralized that information in a single place. This allowed responders to immediately locate owners, dashboards, and runbooks.
Follow-up 2. Level 3 or Level 4 junior depth. How did the system automatically gather service metadata from repositories?
Answer: we introduced a simple metadata file in each repository containing ownership and operational information. A background service periodically scanned repositories and indexed this metadata into the catalog. This approach minimized manual maintenance and ensured the catalog stayed up to date. CI checks also verified that new services included the required metadata file.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when introducing the service catalog?
Answer: the primary concern was adding operational overhead for teams maintaining metadata. To mitigate that, we automated most metadata extraction and limited manual fields to essential information. This kept the catalog lightweight while still providing critical operational context. Over time, teams saw the value during incidents and adoption increased naturally.
Follow-up 4. Curveball. What if teams resisted adopting the catalog because it required additional work?
Answer: to encourage adoption, we integrated the catalog directly into existing developer workflows. The metadata file was simple to maintain and automatically validated during CI builds. We also demonstrated how the catalog dramatically reduced incident response time. Once teams experienced the operational benefits, adoption grew quickly.
Leadership pro tip. Innovation starts with pain points.
The most valuable innovations do not come from chasing new technologies. They come from observing real engineering pain points and designing solutions that remove friction for the entire organization. Question 40. Tell me about a time you challenged the status quo. Note: interviewers ask this question to evaluate whether you can question established engineering practices when they become inefficient or outdated. Senior engineers are expected to challenge systems constructively using data and experimentation, not just opinion. This leadership signal aligns strongly with Amazon's Have Backbone, Disagree and Commit, and Netflix's emphasis on engineers who challenge inefficient processes.
Here are the critical red flags. the instant rejection signals.
Interviewers use this question to detect candidates who confuse rebellion with thoughtful challenge. Avoid these traps. 1. The opinion fight, challenging an existing process without evidence or data. 2. The lone rebel, ignoring team alignment and trying to force change unilaterally. 3. The technology trend, suggesting a new technology simply because it is fashionable. 4. The no adoption story, proposing a change that the team ultimately rejected. 5. The blame leadership, framing the story as leadership being wrong instead of presenting a thoughtful improvement.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 leadership signals. 1. Critical thinking. Did the candidate recognize that the existing process was inefficient or outdated? 2. Evidence-based challenge. Did they support their argument with data or experimentation? 3. Influence. Did they persuade others to reconsider the current approach? 4. Execution. Was the improved approach successfully implemented? 5. Organizational learning. Did the change improve engineering practices long-term? Strong engineers challenge the status quo using data, not ego.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. Our team deployed services through a manual release process that required engineers to coordinate deployments during scheduled release windows. As our microservices architecture grew, this process began creating delays and deployment bottlenecks. Task. I believe the manual release model was slowing engineering velocity and increasing operational risk. I wanted to propose transitioning to a continuous deployment pipeline that allowed smaller, automated releases. Action. Instead of immediately pushing the idea, I gathered deployment data from the past 6 months. The data showed that manual releases introduced an average of 3 hours of coordination overhead and were responsible for several avoidable rollback incidents. I presented these findings in an engineering design review and proposed introducing automated deployment pipelines with canary releases and monitoring safeguards. Result: the new deployment pipeline allowed teams to release changes independently without waiting for scheduled windows. Deployment frequency increased significantly, while rollback incidents decreased due to smaller release batches. Learning plus L. The project highlighted that release processes must evolve as system complexity grows. After the transition, we introduced deployment observability dashboards and automated rollback triggers to ensure the new pipeline remained safe and reliable. The plus L demonstrates that the change improved both engineering velocity and operational safety.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates constructive challenge. 1. Critical thinking matched. The manual release process was identified as a bottleneck as the system scaled. 2. Evidence-based challenge matched. Deployment data revealed coordination overhead and rollback incidents. 3. Influence matched. The proposal was presented through an engineering design review rather than an informal complaint. 4. Execution matched. Continuous deployment pipelines were successfully implemented. 5. Organizational learning matched. Monitoring dashboards and rollback automation strengthened the deployment process. This demonstrates how senior engineers challenge inefficient systems responsibly.
Follow-up 1. Clarification probe. Why did the team originally rely on manual release windows?
Answer: the manual process was introduced when the system was much smaller and deployments were relatively infrequent. Coordinated release windows helped reduce risk when teams lacked mature monitoring and rollback tools. However, as the number of services increased, the process became a bottleneck. Automation and observability made it possible to safely move to continuous deployment.
Follow-up 2. Level 3 or Level 4 junior depth. How did canary releases reduce deployment risk?
Answer: canary releases deploy a new version of the service to a small subset of traffic first. Monitoring systems observe performance metrics and error rates before the rollout expands to all users. If anomalies are detected, the deployment can be rolled back immediately. This approach allows teams to detect issues early without affecting the entire system.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when moving to continuous deployment?
Answer: continuous deployment increases release frequency, but requires strong monitoring and rollback capabilities. Without those safeguards, frequent releases could introduce instability. We invested in observability tools and automated rollback mechanisms before fully adopting the new process. This ensured the system remained reliable while improving engineering velocity.
Follow-up 4 Curveball. What if a senior engineer strongly opposed the change and insisted on keeping release windows?
Answer: in that case, I would invite them to review the deployment metrics and incident history together. Often resistance comes from concerns about reliability rather than opposition to change itself. By demonstrating how canary releases and automated monitoring reduce risk, we could address those concerns directly. Aligning on shared reliability goals usually resolves the disagreement.
Leadership pro tip: challenge with data.
Challenging the status quo is not about being contrarian. The strongest engineers question existing systems when evidence shows they are no longer effective. By grounding your argument in data and thoughtful design, you turn disagreement into progress. Question 41. Describe a time when you improved an existing system. Note: interviewers ask this question to evaluate whether you can recognize limitations in existing systems and incrementally evolve them to handle scale, reliability, or performance demands. Senior engineers are expected to improve production systems without destabilizing them, which is a core signal evaluated at companies like Google and Amazon.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who approach system improvement recklessly. Avoid these traps. 1. The rewrite everything idea, proposing a complete system rewrite instead of improving the existing architecture. 2. The local optimization, improving a small component while ignoring system-wide bottlenecks. 3. The no metric story, claiming the system improved without measuring performance or reliability changes. 4. The risky refactor, deploying large architectural changes without incremental rollout or safeguards. 5. The short-term patch, fixing a symptom instead of addressing the root cause.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 engineering leadership signals. 1. Root cause analysis: did the candidate identify the underlying limitation of the system? 2. Architectural thinking: did they design an improvement that scales with system growth? 3. Operational safety: did they deploy the change in a controlled and safe way? 4. Execution: did the candidate successfully implement the improvement? 5. Measured impact: did the system show measurable gains in performance, reliability, or scalability? Strong engineers improve systems incrementally without destabilizing production environments.
Here is the FAANG-level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our internal job processing platform handled background tasks such as email notifications and analytics processing. As the platform grew, job processing delays began appearing during peak traffic periods. Task: as a senior engineer responsible for back-end infrastructure, I needed to improve the system's throughput without disrupting existing workflows used by multiple teams. Action: after analyzing queue metrics and worker utilization dashboards, I discovered that a single centralized queue was becoming a processing bottleneck. I proposed partitioning the job queue by task type and introducing independent worker pools for each category. I documented the design in an architecture proposal and implemented the change using incremental rollout strategies. Result: the new architecture increased job processing throughput by nearly 3 times and eliminated the backlog issues that previously occurred during peak workloads. Learning plus L. The project highlighted how shared infrastructure components can become bottlenecks as systems scale. After the migration, we added queue monitoring dashboards and automated scaling rules to ensure the platform could handle future traffic growth. The +L demonstrates that the improvement strengthened both system scalability and operational monitoring.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates mature system improvement. 1. Root cause analysis matched. Queue metrics revealed a centralized processing bottleneck. 2. Architectural thinking matched. Partition queues improved scalability without rewriting the system. 3. Operational safety matched. The change was rolled out incrementally to avoid disruption. 4. Execution matched. The new architecture successfully processed higher workloads. 5. Measured impact matched. job processing throughput increased by nearly 3 times. This demonstrates a senior engineer improving an existing system through thoughtful architecture evolution.
Follow-up 1, clarification probe. Why did the centralized queue become a bottleneck as the system grew?
Answer: all job types were competing for the same queue and worker pool, which created contention during peak workloads. High-volume tasks could delay smaller but time-sensitive jobs such as notifications. By partitioning the queue by task type, we isolated workloads and allowed each worker pool to scale independently. This removed the shared bottleneck and improved overall throughput.
Follow-up 2, Level 3 or Level 4 junior depth. How did you safely migrate the system to the new queue architecture?
Answer: we introduced the new queue partitions gradually and routed a small percentage of jobs to the new worker pools first. Monitoring dashboards tracked queue latency and worker utilization during the rollout. If anomalies appeared, we could immediately revert traffic to the original queue. This phased rollout allowed us to validate the architecture without risking system stability.
Follow-up 3, Level 5 or Level 6 senior depth. What trade-offs did you consider when introducing multiple queues and worker pools?
Answer: partitioning improves scalability but increases operational complexity because more worker pools must be monitored. To address that, we implemented centralized observability dashboards that tracked metrics across all queues. This allowed the operations team to monitor the system from a single interface. The additional complexity was manageable compared to the scalability gains.
Follow-up 4, curveball. What if the partitioned queue system caused uneven workload distribution?
Answer: we designed the worker pools to scale dynamically based on queue backlog metrics. If one queue experienced heavier traffic, additional workers could be provisioned automatically. This ensured that workloads remained balanced even when job volumes fluctuated. Monitoring alerts also helped us detect imbalances early.
Leadership pro tip: evolve systems, do not rewrite them.
The best system improvements often come from evolving existing architectures rather than replacing them entirely. Incremental improvements reduce operational risk while allowing systems to scale with growing demand. Question 42. Tell me about a time you automated something. Note: interviewers ask this question to evaluate whether you proactively remove operational toil and improve engineering efficiency through automation. At companies like Amazon and Google, senior engineers are expected to eliminate repetitive manual work and build systems that scale through automation.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who misunderstand the purpose of automation. Avoid these traps. 1. The tiny script, automating a trivial personal task that had no team impact. 2. The one-time tool, building a script that only runs once instead of a reusable automation system. 3. The no-metric story, claiming automation helped without measuring productivity improvements. 4. The shadow tool, building automation that bypasses official infrastructure and becomes hard to maintain. 5. The over-engineering, creating a complex automation platform for a simple problem.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 engineering signals. 1. Toil recognition. Did the candidate identify repetitive work slowing down engineers? 2. Automation design. Did they design a scalable automation solution? 3. Adoption. Did other engineers actually use the automation? 4. Operational reliability. Did the system run consistently without manual intervention? 5. Measured impact. Did automation significantly improve productivity or reliability? Strong engineers eliminate repetitive work by building systems that run themselves.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our engineering team maintained over 40 microservices, and each release required manual verification of service health, database migrations, and configuration validation. These manual release checks often took nearly an hour per deployment. Task: as part of the platform engineering group, I wanted to eliminate this manual verification process so engineers could deploy safely and quickly without needing to perform repetitive checks. Action: I designed an automated deployment verification pipeline integrated into our CI/CD system. The pipeline executed health checks, validated service dependencies, confirmed database migrations, and ran synthetic traffic tests before marking the deployment as successful. I documented the workflow and integrated alerts with our observability dashboards. Result: deployment validation time dropped from roughly 60 minutes of manual verification to about 5 minutes of automated checks. Engineers were able to deploy more frequently, and deployment-related incidents decreased significantly. Learning plus L. The project showed how operational guardrails should be embedded directly into the deployment pipeline. After this initiative, our platform team standardized automated verification checks across all services to ensure consistent release safety. The plus L shows that the automation became a permanent reliability guardrail across the organization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates impactful automation. 1. Toil recognition matched. Manual deployment verification consumed nearly an hour of engineer time. 2. Automation design matched. A CI/CD pipeline automated health checks, migrations, and service validation. 3. Adoption matched. The pipeline became part of the standard deployment workflow. 4. Operational reliability matched. Automated monitoring ensured deployments were verified consistently. 5. Measured impact matched. Deployment verification time dropped from 60 minutes to 5 minutes. This demonstrates automation that significantly improves developer productivity and system reliability.
Follow-up 1. Clarification probe. Why could not engineers simply perform these checks manually during deployments?
Answer: manual verification works for small systems, but as the number of services grew, it became unreliable and time-consuming. Engineers occasionally missed critical checks during late-night deployments or high-pressure releases. Automating the verification process ensured every deployment followed the same safety checks consistently. This reduced human error and improved release confidence.
Follow-up 2. Level 3 or Level 4 junior depth. What kinds of automated checks did the deployment pipeline perform?
Answer: the pipeline verified service health endpoints, validated database schema migrations, and confirmed service dependencies were reachable. It also generated synthetic traffic to ensure critical APIs responded correctly under expected workloads. These checks ran automatically before the deployment was marked successful. Engineers received alerts if any validation step failed.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when introducing automated deployment checks?
Answer: automation adds additional steps to the deployment pipeline, which can slightly increase build time. However, the reliability benefits far outweighed the few extra minutes required for automated validation. By catching deployment issues early, we prevented costly production incidents. Over time, the automated checks actually accelerated development velocity by reducing rollback events.
Follow-up 4. Curveball. What if the automated pipeline incorrectly flagged healthy deployments as failures?
Answer: false positives are possible with automated systems, so we designed the checks to provide detailed diagnostic logs for engineers. If a deployment failed incorrectly, engineers could quickly inspect the logs and rerun the validation. We also continuously refined the health checks based on real deployment data. Over time, the system became increasingly accurate and reliable.
Leadership pro tip: automate the boring work.
Great engineers automate repetitive operational tasks so they can focus on solving harder problems. When you remove manual toil through automation, you improve both productivity and system reliability across the organization. Question 43. Tell me about a time you found an opportunity others missed. Note: interviewers ask this question to evaluate whether you proactively identify hidden system improvements that others overlook. Senior engineers are expected to spot inefficiencies or scaling risks early and convert those insights into measurable engineering improvements. This signal aligns strongly with Amazon's ownership and Netflix's emphasis on proactive engineering judgment.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who mistake coincidence for initiative. Avoid these traps. 1. The lucky discovery, accidentally noticing something but never taking action to improve it. 2. The minor optimization, improving a tiny piece of code that had no meaningful system impact. 3. The no adoption story, identifying an idea but never convincing the team to implement it. 4. The personal optimization, improving your own workflow instead of improving the broader system. 5. The no metrics story, claiming the opportunity was valuable without demonstrating measurable results.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 initiative signals. 1. Observation: did the candidate detect an inefficiency or risk others overlooked? 2. Analytical thinking: did they investigate and validate the opportunity with data? 3. Initiative: did they take ownership of exploring the improvement? 4. Execution: did they implement a solution that addressed the opportunity? 5. Measured impact: did the improvement produce measurable gains? Strong engineers continuously scan systems for opportunities to improve performance, reliability, or efficiency.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our API gateway handled millions of requests per day, and engineers believed the system was operating within acceptable latency thresholds. However, while reviewing our observability dashboards, I noticed occasional spikes in response time during peak traffic periods. Task: although the system was technically within SLA limits, I suspected there was an underlying inefficiency that could become a major bottleneck as traffic increased. I decided to investigate the issue further. Action: I analyzed distributed tracing data from our monitoring platform and discovered that several downstream services were repeatedly fetching identical configuration data from the database on every request. I proposed introducing an in-memory caching layer within the gateway service and documented the design in a short architecture proposal. After validating the approach through load testing, we implemented the cache with automatic refresh logic. Result: the caching layer reduced average API response latency by nearly 40% and significantly decreased database load during peak traffic windows. Learning plus L. The investigation revealed that several services lacked caching strategies for frequently accessed configuration data. After this project, we introduced internal performance guidelines recommending caching patterns for read-heavy endpoints. The +L shows that the insight became an engineering performance standard rather than a one-time optimization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong initiative. 1. Observation matched: latency spikes were detected through observability dashboards. 2. Analytical thinking matched: distributed tracing identified redundant database calls. 3. Initiative matched: the candidate investigated the issue even though the system technically met SLAs. 4. Execution matched: a caching architecture was introduced with automatic refresh logic. 5. Measured impact matched: API response latency improved by nearly 40%. This demonstrates proactive system improvement before the issue became critical.
Follow-up 1. Clarification probe. If the system was already meeting SLAs, why did you spend time optimizing it?
Answer: while the system met current SLAs, the latency spikes suggested hidden inefficiencies that could worsen as traffic scaled. Addressing the issue early allowed us to prevent future performance incidents. Proactively improving systems is much cheaper than reacting to outages. The improvement also reduced database load, which improved overall system resilience.
Follow-up 2. Level 3 or Level 4 junior depth. How did the caching layer reduce database load?
Answer: the configuration data being queried was relatively static and changed infrequently. Instead of retrieving it from the database on every request, the gateway cached the data in memory. Periodic refresh logic ensured the cache remained accurate when configurations changed. This drastically reduced redundant database queries during high traffic periods.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider before introducing caching?
Answer: caching improves performance but introduces the risk of stale data. To mitigate that risk, we implemented a short TTL and added cache invalidation hooks triggered by configuration updates. We also monitored cache hit ratios and data freshness metrics. This ensured the system gained performance benefits without compromising correctness.
Follow-up 4. Curveball. What if the caching layer caused subtle consistency issues?
Answer: we anticipated that possibility and implemented monitoring around configuration update events. If stale data appeared, the cache could be invalidated immediately. Because configuration updates were rare, the risk of temporary inconsistency was extremely small. Continuous monitoring ensured we could respond quickly if any anomalies appeared.
Leadership pro tip: great engineers notice small signals.
Many large engineering improvements begin with small signals hidden in system metrics. Engineers who regularly review dashboards and traces often discover opportunities others overlook. Developing the habit of observing system behavior carefully is one of the most powerful skills in engineering leadership. Question 44. Tell me about a time you built something from scratch. Note: interviewers ask this question to evaluate your ability to design and deliver systems from zero to production. Senior engineers are expected to translate ambiguous requirements into working architecture while balancing trade-offs such as scalability, reliability, and development speed. This capability is heavily evaluated at companies like Amazon and Meta, where engineers frequently build new internal platforms or services.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who misunderstand what from scratch actually means. Avoid these traps. 1. The toy project, describing a side project that never reached production use. 2. The solo hero, claiming you built everything yourself without collaborating with a team. 3. The no architecture, jumping straight into coding without explaining system design decisions. 4. The feature focus, talking about UI features rather than system architecture and reliability. 5. The no impact, building something technically interesting but not widely used by others.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 system design signals. 1. Problem definition. Did the candidate identify a clear need for the new system? 2. Architecture design. Did they design scalable and maintainable components? 3. Execution. Did they successfully build and launch the system? 4. Operational readiness. Did the system include monitoring, deployment, and reliability safeguards? 5. Impact. Did the system provide measurable value to the organization? Strong engineers turn ambiguous ideas into reliable production systems.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our engineering organization frequently struggled with debugging production incidents because logs were scattered across multiple services and environments. Engineers often spent significant time correlating logs manually during outages. Task: I proposed building a centralized log aggregation platform, so engineers could quickly search and analyze logs across all services in one place. Action: I designed a logging architecture that streamed application logs from each microservice into a centralized processing pipeline. Logs were parsed, indexed, and stored in a search-optimized data store. I documented the architecture in an RFC and built the initial ingestion service along with dashboards for engineers to query logs during incidents. Result: after the platform launched, engineers could trace cross-service failures within seconds instead of manually searching through individual servers. Incident investigation time improved significantly, especially during distributed system failures. Learning +L. The project highlighted how critical observability infrastructure is for operating distributed systems. After the initial rollout, our platform team expanded the system to include trace correlation and alerting capabilities. The +L shows the platform evolved into a core observability capability across the organization.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong system creation skills. 1. Problem definition matched. Distributed logs made debugging incidents extremely slow. 2. Architecture design matched. A centralized logging pipeline improved visibility across services. 3. Execution matched. The system was successfully built and deployed. 4. Operational readiness matched. Logs were indexed and accessible through dashboards. 5. Impact matched. Engineers could debug cross-service failures significantly faster. This demonstrates the ability to build foundational engineering infrastructure from the ground up.
Follow-up 1. Clarification probe. Why was centralized logging necessary for this system?
Answer: when systems become distributed, debugging failures across multiple services becomes extremely difficult without centralized logs. Engineers had to manually connect to individual servers to inspect logs, which slowed incident response. Centralizing logs allowed engineers to correlate events across services instantly. This dramatically improved troubleshooting speed during outages.
Follow-up 2, Level 3 or Level 4 Junior Depth. How did the logging system handle high log volume from multiple services?
Answer: we used a streaming pipeline that buffered log events before indexing them into the data store. This allowed the system to handle spikes in log volume without overwhelming the storage layer. Backpressure mechanisms ensured the ingestion service remained stable during traffic bursts. Monitoring dashboards also tracked ingestion throughput and error rates.
Follow-up 3, Level 5 or Level 6 Senior Depth. What trade-offs did you consider when designing the logging platform?
Answer: one major trade-off was balancing indexing speed with storage cost. Highly indexed logs make queries fast but increase storage requirements. We solved this by indexing critical fields such as request IDs and service names while keeping less critical data compressed. This approach kept search performance high without excessive storage costs.
Follow-up 4, Curveball. What if the logging system itself failed during a major outage?
Answer: observability systems must be highly resilient, so we deployed the logging pipeline across multiple nodes with failover capability. Logs were temporarily buffered locally if the central pipeline became unavailable. This ensured log data was not lost during system disruptions. Once the pipeline recovered, buffered logs were automatically replayed.
Leadership Pro Tip. Build platforms that multiply productivity.
The most impactful systems built from scratch are internal platforms that improve how other engineers work. Observability, CI/CD, and infrastructure tooling often provide the greatest long-term value because they amplify productivity across the entire organization. Question 45. Describe a time when you drove innovation within your team. Note: interviewers ask this question to evaluate whether you can introduce new engineering approaches that improve how the team builds and operates software. Senior engineers are expected to elevate team capabilities by introducing better tools, architectures, or processes. This leadership signal is commonly evaluated at companies like Google and Netflix, where engineers are expected to push technical standards forward.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who misunderstand innovation in engineering teams. Avoid these traps. 1. The hackathon project describing an experiment that never became part of the team's workflow. 2. The technology trend introducing a new framework without solving a real engineering problem. 3. The solo innovation building something personally without influencing the team to adopt it. 4. The no metrics story, claiming the innovation was successful without measurable improvements. 5. The complexity increase, introducing tools that made the system harder to maintain.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 innovation leadership signals. 1. Problem recognition. Did the candidate identify a limitation in the team's workflow or system? 2. Idea generation. Did they propose a novel solution or improvement? 3. Influence. Did they convince the team to adopt the innovation? 4. Execution. Was the idea implemented successfully? 5. Impact. Did the change measurably improve engineering productivity or system quality? Strong engineers drive innovation by improving how teams build and operate systems.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our backend services experienced recurring performance regressions whenever new features were deployed. These issues were usually discovered only after code reached staging or production environments. Task: as a senior engineer responsible for system reliability, I wanted to introduce a way to detect performance regressions earlier in the development process. Action: I proposed integrating automated load testing into our CI pipeline. I created an internal benchmarking framework that simulated production traffic patterns and compared performance metrics against baseline thresholds. I documented the process and trained the team on how to interpret performance reports generated during builds. Result: performance regressions that previously surfaced late in the release cycle were now detected during pull request validation. Over several months, production latency incidents caused by performance regressions dropped significantly. Learning plus L. The initiative demonstrated how performance validation should be treated as a first-class CI check. After the project, our engineering standards required services to define performance benchmarks before new features could be merged. The plus L shows the innovation became a permanent engineering quality guardrail.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates team-level innovation. 1. Problem recognition matched. Performance regressions were discovered too late in the release process. 2. Idea generation matched. Automated load testing was proposed as a CI capability. 3. Influence matched. The candidate trained engineers and integrated the tool into team workflows. 4. Execution matched. Performance benchmarks were successfully integrated into the CI pipeline. 5. Impact matched. Production performance incidents caused by regressions dropped significantly. This demonstrates innovation that improves both reliability and development workflows.
Follow-up 1. Clarification probe. Why were not performance regressions detected earlier before introducing this system?
Answer: most teams relied on functional tests in CI and manual load testing later in the release process. This meant performance regressions were often discovered after features had already progressed through development stages. Integrating performance checks directly into CI shifted detection earlier in the lifecycle. This significantly reduced late-stage surprises.
Follow-up 2. Level 3 or Level 4 junior depth. How did the benchmarking framework determine whether performance had degraded?
Answer: each service defined baseline performance metrics such as latency and throughput under simulated traffic. The CI pipeline executed the load test and compared results against those baselines. If latency exceeded defined thresholds, the build would fail and alert engineers. This ensured regressions were detected before code was merged.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when adding load tests to CI pipelines?
Answer: performance testing increases pipeline execution time, which can slow developer feedback loops. To balance this, we ran lightweight performance benchmarks during pull requests and reserved full-scale load tests for nightly builds. This approach maintained fast CI cycles while still catching most regressions early.
Follow-up 4. Curveball. What if engineers initially resisted adding performance tests because it slowed down builds?
Answer: I demonstrated historical incidents where performance regressions caused production outages and emergency fixes. By comparing those incidents with the minimal overhead of CI benchmarks, the trade-off became clear. Once engineers saw the reliability benefits, they supported the new testing workflow. Over time, it became a normal part of development.
Leadership pro tip. Innovation should improve the system, not just the code.
The most valuable innovations in engineering teams improve how software is built, tested, and operated. When your ideas make the entire development process more reliable or efficient, your impact multiplies across every project the team builds. Question 46. Tell me about a time you took a calculated risk that paid off, or did not. Note: interviewers ask this question to evaluate engineering judgment under uncertainty. Senior engineers are expected to take thoughtful risks when necessary, but those risks must be backed by data, controlled experimentation, and rollback strategies. This leadership signal is commonly evaluated at companies like Netflix and Amazon, where engineers are trusted to make high-impact decisions.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who confuse recklessness with calculated risk. Avoid these traps. 1. The YOLO deployment, taking a risky action in production without safeguards or rollback plans. 2. The zero analysis, making a decision without gathering performance data or validating assumptions. 3. The hero story, framing the story as bravery rather than engineering judgment. 4. The no-risk mitigation, ignoring monitoring, testing, or rollback mechanisms. 5. The blame outcome, if the risk failed, blaming others rather than explaining what you learned.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 engineering leadership signals. 1. Risk identification, did the candidate clearly understand what could go wrong? 2. Analysis, did they collect data or run experiments before making the decision? 3. Mitigation, did they design safeguards such as monitoring, canary releases, or rollbacks? 4. Execution was the decision implemented responsibly. 5. Learning. Did the candidate improve engineering practices based on the outcome? Strong engineers take calculated risks backed by data and controlled experimentation.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation. Our platform handled user authentication through a centralized service that was becoming a latency bottleneck during peak traffic. Some engineers suggested simply scaling the existing service horizontally, but I suspected the architecture itself was the limitation. Task. I proposed introducing a token validation cache at the edge layer so requests could be verified without calling the central authentication service every time. However, the team was concerned that caching authentication tokens might introduce security risks or stale validations. Action. To evaluate the idea safely, I ran a controlled experiment in staging environments using simulated production traffic. I implemented a short-lived cache with strict expiration rules and built monitoring dashboards to track authentication success rates and potential inconsistencies. After validating the approach, we gradually rolled it out using a canary deployment strategy. Result: the edge caching layer reduced authentication latency by nearly 50% during peak traffic periods while maintaining correct validation behavior. Central authentication service experienced significantly lower load, improving overall system stability. Learning plus L. The experiment demonstrated the value of controlled architectural experiments. After this project, we introduced an engineering guideline encouraging teams to validate architectural changes through staged experiments before full production rollout. The +L shows the risk-taking process became a repeatable engineering practice.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates responsible risk-taking. 1. Risk identification matched. The candidate recognized both performance gains and potential security concerns. 2. Analysis matched. Experiments were conducted in staging environments with simulated traffic. 3. Mitigation matched. Short cache expiration and monitoring safeguards reduced potential risk. 4. Execution matched. The feature was deployed gradually through a canary rollout. 5. Learning matched. The team adopted a standard process for validating architectural changes through experiments. This demonstrates mature engineering judgment rather than reckless decision-making.
Follow-up 1. Clarification probe. Why did caching authentication tokens introduce risk?
Answer: authentication tokens represent security-sensitive data, so caching them could potentially allow invalid tokens to be accepted if they remained in the cache too long. That was the main concern raised by the security team. By implementing extremely short expiration times and validating cache consistency metrics, we minimized that risk. Continuous monitoring ensured any anomalies could be detected immediately.
Follow-up 2. Level 3 or Level 4 junior depth. How did the canary rollout help reduce deployment risk?
Answer: the canary deployment routed a small percentage of authentication traffic through the caching system first. This allowed us to monitor latency improvements and verify that token validation remained correct. If any inconsistencies appeared, traffic could immediately revert to the original architecture. Gradually increasing traffic ensured the system remained stable.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when implementing the cache?
Answer: the main trade-off was performance versus strict consistency in authentication validation. Caching reduced load and latency, but introduced the possibility of temporarily accepting outdated token states. By limiting the cache duration to a few seconds and monitoring token revocation metrics, we maintained security guarantees while still improving performance.
Follow-up 4. Curveball. What if the caching approach had introduced a security bug in production?
Answer: because we deployed the feature using canary traffic and real-time monitoring, any anomalies would have triggered alerts immediately. The rollback strategy allowed us to disable the caching layer quickly and revert to the original authentication path. That safety net ensured the risk remained controlled. The experiment design prioritized safety before performance gains.
Leadership pro tip. Smart risks are measured risks.
Engineering innovation often requires taking calculated risks, but the best engineers reduce uncertainty through experimentation, monitoring, and rollback strategies. When risks are managed thoughtfully, teams can innovate without compromising reliability.
Category 5 Wrap-Up, the Proactive Architect.
You have now mastered the initiative and innovation category. You have learned how to prove you are a force multiplier, someone who does not just follow a roadmap, but helps build it by identifying hidden opportunities and automating away organizational friction. You have demonstrated the courage required to challenge the status quo for the sake of long-term technical health.
Transition, the Ultimate North Star.
Innovation and initiative are internal drivers, but they must always point toward a specific destination. In the world's most successful tech companies, that destination is the user. A perfect architecture is a failure if it does not solve a problem for the person paying the bill. This brings us to Category 6, Customer Focus.
Category 6, Customer Focus.
At companies like Amazon and Apple, customer obsession is not a marketing slogan. It is an architectural requirement. Interviewers use this category to see if you can look past the code, and the servers to see the human impact of your decisions. For senior engineers, this means advocating for the user even when it increases technical complexity or challenges the current product roadmap.
Customer Focus, Masterclass Scenarios.
These 5 scenarios test your ability to balance technical rigor with user-centric advocacy. 47. Tell me about a time you advocated for the customer. 48. Describe a time you had to handle a difficult customer. 49. Tell me about a time when customer feedback changed your approach. 50. Tell me about a time you delivered an exceptional customer experience. 51. Tell me about a time when you balanced customer needs with technical constraints. Senior architects do not just build systems, they build solutions that customers love. Question 47. Tell me about a time you advocated for the customer. Note: interviewers ask this question to evaluate whether you prioritize user impact when making engineering decisions. At companies like Amazon and Google, engineers are expected to advocate for reliability, performance, and usability improvements when customer experience is at risk, even if those improvements require additional engineering work.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who misunderstand customer focus in engineering. Avoid these traps. 1. The customer support story, describing a help desk interaction instead of an engineering decision that improved the product. 2. The feature bias, advocating for a new feature rather than improving reliability or performance. 3. The opinion argument, claiming the change helped users without analyzing customer metrics. 4. The short-term fix, applying a quick patch that solved the immediate complaint but ignored the underlying system issue. 5. The no impact, advocating for something but failing to implement or deliver the improvement.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 customer obsession signals. 1. Customer awareness. Did the candidate recognize how a technical issue affected users? 2. Data analysis. Did they analyze customer metrics or system data to understand the impact? 3. Advocacy. Did they push for a change that improved the user experience? 4. Execution. Was the improvement successfully implemented? 5. Impact. Did the change measurably improve the customer experience? Strong engineers protect customer experience even when it requires extra engineering effort.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our checkout service was experiencing intermittent latency spikes during high traffic periods. While the system technically met its service level objectives, customer analytics showed that slower checkout times were correlated with increased cart abandonment. Task: I believed we needed to prioritize improving checkout performance even though the system was technically operating within acceptable limits. Action: I analyzed distributed tracing data and identified that several back-end calls in the checkout workflow were executed sequentially rather than in parallel. I proposed restructuring the service orchestration so independent API calls could execute concurrently. I documented the design change in an architecture proposal and collaborated with the payments team to implement the updates safely. Result: after the optimization, checkout latency dropped from an average of 1.8 seconds to around 900 milliseconds during peak traffic. Product analytics later showed a measurable decrease in cart abandonment rates during those periods. Learning plus L. The project reinforced the importance of aligning engineering metrics with real customer outcomes. After this change, we introduced performance budgets for customer-critical APIs to ensure user experience remained a priority during feature development. The +L demonstrates how customer-focused improvements can become permanent engineering standards.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong customer advocacy. 1. Customer awareness matched. Checkout latency was directly impacting user behavior. 2. Data analysis matched. Customer analytics and tracing data were used to diagnose the issue. 3. Advocacy matched. The candidate prioritized performance improvements even though the system met internal SLOs. 4. Execution matched. Service orchestration was redesigned to run backend calls concurrently. 5. Impact matched. Checkout latency improved significantly and cart abandonment decreased. This demonstrates customer-focused engineering decisions backed by data.
Follow-up 1. Clarification probe. Why was reducing checkout latency so important if the system was already meeting its SLA?
Answer: service-level objectives often represent minimum acceptable performance, but customer expectations are usually higher. Even small increases in checkout time can affect user behavior during purchases. By reviewing product analytics alongside system metrics, we realized latency spikes were hurting conversion rates. Improving performance, therefore, had direct business impact.
Follow-up 2. Level 3 or Level 4 junior depth. Why did executing backend calls sequentially cause higher latency?
Answer: each backend dependency introduced additional wait time before the next call could begin. When several services were queried sequentially, the total latency accumulated quickly. Running independent calls concurrently allowed the system to complete multiple operations simultaneously. This significantly reduced the overall request time.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider before parallelizing the service calls?
Answer: parallelizing requests can increase system load because multiple services are called simultaneously. We analyzed downstream capacity and ensured the services could handle the increased concurrency. We also implemented timeouts and circuit breakers to protect the system during failures. This ensured the performance gains did not introduce reliability risks.
Follow-up 4. Curveball. What if the payments team had refused the change because it increased system complexity?
Answer: in that case, I would present the customer analytics data showing the relationship between latency and cart abandonment. Aligning the discussion around customer impact usually helps teams prioritize improvements. We could also test the optimization through staged experiments before committing fully. This approach reduces risk while demonstrating real user benefits.
Leadership pro tip. Customer impact beats internal metrics.
Internal system metrics such as SLAs are important, but they do not always reflect real user experience. Strong engineers regularly connect engineering performance metrics with product analytics to ensure that system improvements translate into better outcomes for customers. Question 48. Describe a time you had to handle a difficult customer. Note: interviewers ask this question to evaluate how engineers handle high-stakes situations where a customer's experience is severely impacted. At companies like Amazon, Google, and Meta, senior engineers are expected to respond calmly, investigate the technical root cause, and restore trust through transparent communication and system improvements.
Here are the critical red flags. The instant rejection signals.
Interviewers use this question to detect candidates who approach customer issues defensively or emotionally. Avoid these traps. 1. The customer blame, suggesting the customer misused the system instead of investigating the issue. 2. The support ticket story, describing a routine bug fix without meaningful customer impact. 3. The technical jargon, overwhelming the customer with technical explanations instead of clear communication. 4. The quick patch, applying a temporary fix without addressing the root cause. 5. The no follow-up, resolving the issue but failing to prevent similar problems in the future.
Here are the signals the interviewer is scoring.
While you answer this question, Interviewers evaluate these 5 customer trust signals. 1. Customer empathy. Did the candidate understand the impact on the customer's business or experience? 2. Technical investigation. Did they analyze system data to identify the root cause? 3. Communication. Did they explain the issue clearly and maintain transparency? 4. Resolution. Was the technical problem solved effectively? 5. System improvement. Did the candidate implement safeguards to prevent recurrence? Strong engineers restore customer trust through both communication and technical resolution.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: one of our enterprise customers reported that their analytics dashboard was intermittently failing to load during peak usage hours. Because the dashboard powered their internal reporting workflows, the issue created significant frustration for their operations team. Task: as the backend engineer responsible for the reporting API, I needed to investigate the issue quickly and provide both a technical resolution and clear communication to the customer. Action: I analyzed error logs and monitoring dashboards and discovered that the reporting API occasionally timed out when generating complex queries on large datasets. I coordinated with the database team to optimize the query plan and introduced a caching layer for frequently requested reports. Throughout the investigation, I worked with our customer success team to keep the client informed about our progress and expected resolution timeline. Result: after the optimization, dashboard load times improved significantly and the timeout errors were eliminated. The customer confirmed that their reporting workflows were stable again and appreciated the transparent updates during the investigation. Learning plus L. The incident revealed that our reporting APIs lacked performance monitoring for large queries. Afterward, we introduced query performance alerts and added automated load tests to ensure reporting endpoints remained stable as data volumes grew. The +L demonstrates how resolving a customer issue can lead to long-term reliability improvements.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates effective customer issue resolution. 1. Customer empathy matched. The candidate recognized the customer's operational workflow was disrupted. 2. Technical investigation matched. Logs and monitoring dashboards revealed query performance issues. 3. Communication matched. Progress updates were provided through the customer success team. 4. Resolution matched. Query optimization and caching eliminated the timeouts. 5. System improvement matched. Monitoring and load tests were introduced to prevent future issues. This demonstrates both technical competence and professional customer communication.
Follow-up 1. Clarification probe. Why did the issue only affect certain customers with larger datasets?
Answer: customers with larger datasets triggered significantly more complex database queries. These queries occasionally exceeded the API timeout threshold during peak load periods. Smaller datasets did not create the same level of query complexity, which is why the issue appeared inconsistent. Optimizing the query plan and adding caching eliminated the performance bottleneck.
Follow-up 2. Level 3 or Level 4 junior depth. How did the caching layer improve dashboard performance?
Answer: many dashboard reports were requested repeatedly with identical parameters. Instead of recomputing the same database query each time, the system cached the generated results for a short period. Subsequent requests could retrieve the cached data instantly. This dramatically reduced database load during peak usage.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when adding caching for report results?
Answer: caching improves performance but introduces the possibility of slightly stale data. Because the reports were not real-time critical, we selected a short cache expiration window that balanced freshness with performance gains. We also monitored cache hit rates and query latency metrics. This ensured the optimization improved user experience without compromising data accuracy.
Follow-up 4. Curveball. What if the customer remained frustrated even after the fix?
Answer: in those situations, transparency becomes extremely important. I would walk the customer through the root cause, the improvements implemented, and how we were preventing similar issues in the future. Demonstrating a clear learning process often restores confidence. Customers usually respond positively when they see engineers take their problems seriously.
Leadership pro tip. Difficult customers reveal system weaknesses.
When customers experience frustration, it is often a signal that the system has an underlying reliability or performance issue. Instead of viewing complaints defensively, strong engineers treat them as valuable signals for improving the system. Question 49. Tell me about a time when customer feedback changed your approach. Note: interviewers ask this question to evaluate whether engineers listen to real user feedback and adapt their technical decisions accordingly. At companies like Amazon and Google, engineers are expected to incorporate customer insights into product and system design rather than relying solely on internal assumptions.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who ignore or misunderstand customer feedback. Avoid these traps. 1. They ignore the feedback, explaining why the customer was wrong instead of adapting the system. 2. The single complaint, reacting to one isolated complaint without validating broader user impact. 3. The surface fix, addressing a visible issue while ignoring deeper usability problems. 4. The feature overload, adding complexity instead of solving the real customer problem. 5. The no-metric story, implementing changes without measuring the impact.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 customer insight signals. 1. Customer listening. Did the candidate genuinely analyze customer feedback? 2. Problem diagnosis. Did they identify the root cause behind the feedback? 3. Adaptability. Did they change their original technical approach? 4. Execution. Was the improved solution implemented successfully? 5. Impact. Did the change measurably improve the customer experience? Strong engineers treat customer feedback as valuable system design input.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our team built a search feature for an analytics dashboard that allowed users to filter large datasets. From an engineering perspective, the feature was functioning correctly, but customer feedback consistently mentioned that search results felt slow and difficult to navigate. Task: initially we believed the issue was simply the size of the datasets being queried. However, the repeated feedback suggested there was a usability problem that needed deeper investigation. Action: I reviewed product analytics and noticed that many users were repeatedly refining the same queries. Instead of forcing users to rerun expensive database searches each time, I proposed introducing incremental filtering and client-side caching for recent search results. I collaborated with the front-end team to redesign the query flow and implemented a caching layer to store intermediate results. Result: after the change, search response time improved dramatically and users could refine filters almost instantly. Product analytics showed a significant reduction in repeated full database queries and an increase in successful search interactions. Learning plus L. The feedback revealed that system performance must be evaluated through the lens of user workflows, not just back-end metrics. After this change, we incorporated product analytics reviews into our feature design process to better understand real user behavior. The +L shows that customer insights were integrated into future engineering decisions.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong customer responsiveness. 1. Customer listening matched. The team recognized repeated user complaints about search usability. 2. Problem diagnosis matched. Analytics revealed users repeatedly rerunning similar queries. 3. Adaptability matched. The original query approach was redesigned based on feedback. 4. Execution matched. Incremental filtering and caching improved system responsiveness. 5. Impact matched. Search response times improved and user interaction metrics increased. This demonstrates how customer insights can directly shape better engineering solutions.
Follow-up 1. Clarification probe. Why did not backend performance metrics reveal the usability problem earlier?
Answer: backend metrics only measured query execution time, which appeared acceptable from an infrastructure perspective. However, those metrics did not capture how users interacted with the search interface. Product analytics revealed that users frequently repeated similar queries while refining filters. This behavior indicated that the workflow itself needed improvement.
Follow-up 2, Level 3 or Level 4 Junior Depth. How did incremental filtering reduce database load?
Answer: instead of executing a full database query each time the user adjusted filters, the system reused previously retrieved results. The front-end applied additional filtering logic locally while cached results remained valid. This significantly reduced repeated database queries. As a result, the system handled search requests more efficiently.
Follow-up 3, Level 5 or Level 6 Senior Depth. What trade-offs did you consider when introducing caching for search results?
Answer: caching improved responsiveness, but introduced the possibility of slightly outdated results. Because the search data changed infrequently, we used a short expiration window to balance freshness with performance. Monitoring metrics ensured cached results remained accurate. This approach improved usability without sacrificing data correctness.
Follow-up 4, Curveball. What if customer feedback conflicted with your technical performance metrics?
Answer: in those cases, it is important to investigate how users interact with the system rather than relying solely on back-end metrics. Sometimes workflows or UI design create friction even when the infrastructure performs well. Combining product analytics with engineering telemetry helps reveal these issues. That perspective often leads to better design decisions.
Leadership Pro Tip. Metrics and feedback together reveal the truth.
Engineering metrics tell you how the system behaves, while customer feedback reveals how users experience the system. The best engineers combine both perspectives when designing improvements. Question 50. Tell me about a time you delivered an exceptional customer experience. Note: interviewers ask this question to evaluate whether engineers go beyond basic functionality to significantly improve how customers experience a product. At companies like Amazon, Apple, and Netflix, engineers are expected to design systems that delight users through reliability, speed, and thoughtful product behavior.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to filter out candidates who misunderstand what exceptional customer experience means in engineering. Avoid these traps. 1. The customer support story, describing helping a user individually instead of improving the system for all users. 2. The feature launch, talking about releasing a feature without explaining how it improved the user experience. 3. The aesthetic focus, focusing only on UI changes while ignoring system reliability or performance. 4. The one-time fix, solving a single incident without making systemic improvements. 5. The no-metrics story, claiming success without measurable improvements in user behavior.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 customer impact signals. 1. User understanding: did the candidate identify what customers actually needed? 2. Technical insight: did they recognize how system behavior affected user experience? 3. Engineering solution: did they design a technical improvement that enhanced the experience? 4. Execution: was the improvement successfully implemented? 5. Impact: did the change produce measurable improvements in user engagement or satisfaction? Strong engineers create exceptional experiences by improving system behavior, not just features.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our mobile application allowed users to upload images for content sharing. However, during peak traffic periods, users frequently experienced long upload times or failures due to network instability on mobile devices. Task: although the feature technically worked, the poor reliability created frustration for users. I wanted to redesign the upload system so it would behave reliably even under unstable network conditions. Action: I proposed implementing a resumable upload architecture that allowed large files to be uploaded in smaller chunks. The client application could retry failed chunks instead of restarting the entire upload. I collaborated with the mobile team to implement the protocol and introduced monitoring dashboards to track upload success rates. Result: after the change, upload success rates increased significantly, and users were able to complete uploads even on unstable mobile connections. Customer support tickets related to upload failures dropped noticeably in the following weeks. Learning +L. The project reinforced that mobile network conditions require different engineering strategies than desktop environments. After this improvement, our engineering guidelines recommended resumable upload protocols for all large file transfers. The +L shows how improving one feature led to broader engineering best practices.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates exceptional customer experience engineering. 1. User understanding matched. Mobile users struggled with unreliable network conditions. 2. Technical insight matched. The system forced users to restart uploads after failures. 3. Engineering solution matched. A resumable upload protocol allowed partial retries. 4. Execution matched. The system was implemented across mobile clients and backend services. 5. Impact matched. Upload success rates improved and customer support tickets decreased. This demonstrates how engineering decisions directly improve the customer experience.
Follow-up 1. Clarification probe. Why were mobile users more affected by upload failures than desktop users?
Answer: mobile networks are inherently less stable than wired connections and often experience temporary drops in connectivity. When the original upload system required restarting the entire transfer after a failure, users lost significant progress. This created frustration for large uploads. Resumable uploads allowed the system to recover from intermittent network disruptions.
Follow-up 2. Level 3 or Level 4 junior depth. How did chunked uploads improve reliability?
Answer: instead of sending the entire file in a single request, the system divided the file into smaller segments. Each segment could be uploaded independently and retried if it failed. The server tracked which chunks had already been received. This allowed uploads to resume from the last successful segment.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when introducing chunked uploads?
Answer: chunked uploads increase protocol complexity and require additional state tracking on the server. However, the reliability improvements for large file transfers were substantial. We designed the system to clean up incomplete uploads automatically to avoid storage issues. Monitoring metrics ensured the system remained efficient.
Follow-up 4. Curveball. What if the resumable upload system introduced additional latency for small files?
Answer: for smaller files, we bypassed the chunked upload mechanism and used the original single request method. This ensured that users uploading small files experienced minimal overhead. The resumable protocol was only activated for larger files, where reliability mattered more than slight latency differences. This hybrid approach balanced performance and reliability.
Leadership pro tip. Exceptional experience comes from resilient systems.
Customers rarely think about system architecture, but they immediately notice reliability and responsiveness. Engineers who design systems that gracefully handle real-world conditions create experiences that feel effortless to users. Question 51. Tell me about a time when you balanced customer needs with technical constraints. Note: interviewers ask this question to evaluate engineering judgment when customer expectations conflict with system limitations. Senior engineers must navigate trade-offs between user experience, technical feasibility, reliability, and delivery timelines. This signal is strongly evaluated at companies like Amazon, Google, and Netflix, where engineers must frequently balance product ambitions with infrastructure realities.
Here are the critical red flags, the instant rejection signals.
Interviewers use this question to detect candidates who struggle with engineering trade-offs. Avoid these traps. 1. The say yes to everything, promising customers unrealistic solutions that the system cannot support. 2. The technical excuse, rejecting customer requests without exploring possible alternatives. 3. The feature rush, shipping a risky solution that introduces reliability issues. 4. The customer ignore, prioritizing technical convenience over customer experience. 5. The no trade-off discussion, failing to explain how competing priorities were balanced.
Here are the signals the interviewer is scoring.
While you answer this question, interviewers evaluate these 5 engineering judgment signals. 1. Customer awareness. Did the candidate understand the customer's request and its business importance? 2. Technical constraints. Did they identify the system limitations or risks? 3. Trade-off evaluation. Did they carefully weigh possible solutions? 4. practical solution did they find a compromise that addressed both concerns? 5. Impact. Did the final decision improve the user experience without compromising system stability? Strong engineers balance customer needs with technical reality through thoughtful trade-offs.
Here is the FAANG level senior answer, STAR+L.
To pass the senior bar, structure your answer using the STAR+L method. Situation: our product team wanted to introduce real-time analytics updates on the customer dashboard so users could see activity instantly. However, the existing analytics pipeline processed data in batch intervals and was not designed for real-time streaming. Task: the product team believed real-time updates would significantly improve user engagement, but implementing a fully real-time architecture would require a major infrastructure overhaul that could delay the release by several months. Action: I analyzed user behavior data and found that most customers refresh the dashboard roughly every 20 to 30 seconds rather than needing true real-time updates. Based on that insight, I proposed implementing near real-time updates using a lightweight caching layer and incremental data refresh every 15 seconds instead of redesigning the entire pipeline. Result: the dashboard appeared almost real-time from the user's perspective, while avoiding the complexity of a full streaming architecture. The feature launched on schedule and improved user engagement without introducing system instability. Learning plus L. The project demonstrated that perceived performance often matters more than technical implementation details. After this project, our team began validating product assumptions with user behavior data before committing to complex architectural changes. The plus L shows how balancing customer expectations with engineering constraints can lead to smarter design decisions.
Our answer breakdown. Here is how our answer is hitting those signals perfectly.
Notice how the STAR+L story demonstrates strong engineering judgment. 1. Customer awareness matched. Real-time analytics was requested to improve user experience. 2. Technical constraints matched. The existing pipeline was not designed for real-time processing. 3. Trade-off evaluation matched. A full streaming architecture would have delayed the release significantly. 4. Practical solution matched. Near real-time updates provided a user-friendly compromise. 5. Impact matched. The feature improved engagement without requiring a risky infrastructure rewrite. This demonstrates balancing user expectations with responsible engineering decisions.
Follow-up 1. Clarification probe. Why did users believe they needed real-time updates?
Answer: users often associate faster feedback with better control over their data and workflows. However, when we analyzed actual behavior patterns, most users manually refresh the dashboard periodically rather than requiring millisecond updates. This insight helped us design a solution that felt real-time without the complexity of true streaming infrastructure. Understanding user behavior helped align engineering effort with real needs.
Follow-up 2. Level 3 or Level 4 junior depth. How did the caching layer enable near real-time updates?
Answer: the caching layer stored recently processed analytics results, so the dashboard could retrieve updated data quickly. Instead of recalculating analytics from the full dataset every time, the system refreshed cached values at short intervals. This significantly reduced processing overhead while maintaining fresh data. The approach provided near real-time responsiveness.
Follow-up 3. Level 5 or Level 6 senior depth. What trade-offs did you consider when choosing near real-time updates instead of true real-time streaming?
Answer: a full streaming architecture would have required new infrastructure components and introduced operational complexity. While it could provide millisecond-level updates, that level of precision was unnecessary for most user workflows. The near real-time solution delivered a similar user experience while maintaining system simplicity. This approach balanced customer satisfaction with engineering sustainability.
Follow-up 4. Curveball. What if some customers eventually demanded true real-time analytics?
Answer: in that case, we would evaluate the demand through product analytics and customer feedback to confirm the need. If real-time updates became a critical feature, we could design a streaming architecture incrementally. Starting with near real-time updates allowed us to validate the feature's value first. This staged approach reduces engineering risk.
Leadership pro tip. Great engineers design for perceived experience.
Customers care about how a system feels, not necessarily how it is implemented internally. Engineers who balance technical feasibility with user perception often deliver the most effective solutions.
Category 6 Wrap-Up, the true north of architecture.
You have conquered the customer focus category. You now understand that at the FAANG level, engineering does not exist in a vacuum. Elite architects do not just build technically perfect systems, they build solutions that relentlessly serve the customer. When you demonstrate that you can push back on technical constraints to protect the user experience, you signal true engineering maturity.
Part 1 Wrap-Up, you have mastered influence.
You have just completed the first half of the FAANG Behavioral Masterclass. We have covered leadership, teamwork, communication, impact, initiative, and customer focus. If you have mastered these frameworks, you now know how to prove to an interviewer that you can guide teams and deliver massive business value without relying on a formal title.
Transition from influence to survival.
But delivering results when things go well is only half the interview. In Part 2, we tackle the hardest, most grueling part of the FAANG loop, the crisis and judgment round. We are moving from the light into the dark side of engineering leadership.
Part 2, the crisis and judgment.
When a hiring manager at Amazon, Google, or Meta asks you about your biggest failure, they are not looking for a cute story about a missed meeting. They want to know what you do when a database drops, when a multi-million-dollar project is going to miss its deadline, or when you face an impossible ethical dilemma. They are testing your emotional resilience and your systemic thinking under extreme stress.
What is coming in Part 2?
In Part 2, we apply our FAANG-optimized STAR+L Framework to the final 7 categories, covering 51 high-stakes scenarios. Category 7, Failure and Mistakes, How to Own Catastrophic Production Outages. Category 8, Problem-Solving, Debugging Under Fire. Category 9, Ambiguity and Decision-Making, Designing Systems When Requirements Are Terrible. Category 10, Pressure and Deadlines, Negotiating Scope When the Business Demands the Impossible. Category 11, Learning and Growth, Demonstrating Continuous Improvement. Category 12, Ethical Judgment and Integrity, Pushing Back on Leaders Who Want to Cut Critical Corners. Category 13, Self-Reflection and Motivation, Understanding Your Own Professional Drive. Part 2 separates the senior engineers from the principal architects. The link to Part 2 is the first thing in the description below. Subscribe, take a breath, and I will see you in the next masterclass.
Check the comments section or description of this video. I have given a link to download a magical bundle that teaches you to develop Google caliber thinking and provides a complete mental model in a way that screams Google SRE. This bundle is the only end-to-end system that teaches you to think, act, and communicate like a Google SRE before you even set foot in the interview. It is the only structured playbook for Google's impossible rounds like NALS and troubleshooting. Most candidates sound like outsiders. The magic of this bundle makes you sound like you already work at Google. Cracking the Google SRE interview is one of the toughest challenges in tech. Most resources only prepare you for parts of the process, a few coding problems here, some system design notes there. But Google's SRE loop is multidimensional. It tests how you think, act, and communicate. Imagine preparing with scattered LeetCode problems, random design blog posts, and still wondering how to survive the NALS round. That's how most candidates prep, fragmented, incomplete, and unstructured.
Now, imagine having one complete system.
Imagine instead you had one system that gave you everything.
A system that gives you
1. End-to-end coverage of every single round. 2. Playbooks that turn chaos like NALS and troubleshooting into structure. 3. Realistic practice drills that simulate the actual interview loop. 4. Insider language and frameworks that make you sound like you already belong. That's what this bundle does. It's not just prep material, it's a game changer because it transforms the way you think, act, and communicate into the exact style Google interviewers are looking for.
The Google SRE interview bundle covers
1. Recruiter screen and resume prep, tailored templates and scripts that pass the first filter. 2. Coding rounds, Python and Go question and answers designed for SRE-style reliability tasks. 3. System design and NALS, playbooks for both high-level design and Google's infamous NALS round. 4. Troubleshooting and debugging, a step-by-step handbook to master war room-style scenarios. 5. Behavioral and Googleness, real reliability scenarios that make you sound like you already work at Google. 6. Post-interview and hiring committee, an insider breakdown of how decisions are made. 7. Salary negotiation, recruiter-proof scripts and strategies to maximize your offer confidently. If leak code is practice mode, this bundle is the real game simulation. It doesn't just prepare you for questions. It prepares you to think, act, and communicate like a Google SRE before you even set foot in the interview.
For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development and more that will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.